All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. Please let me know in the chats if everything is perfectly fine. If you guys can hear me, if you can see me, let me know in the chats, okay? And light the chats with the fire emojis, okay? And one more important thing, my dear friends. Make sure everybody of you smash the like button because liking the session means marking the attendance. And that's very much mandatory. You guys are supposed to mark the attendance. Everyone means everyone. Everyone means everyone. And let the people join. Let everybody come. We are going to start this particular session. You are going to fall in love because I will be starting from the scratch. I will be starting from the basics, okay? And I will take you to the level which you actually need for the NEET 2025. Okay? Okay. Doesn't matter if you have studied these chapters before. Okay, you are going to understand each and every single thing. That is for sure. That is for sure. Okay. Let the people come. Let the people come. Let the people join. Okay, guys. Smash the like button. Everyone means everyone. Light up the chats with the fire emojis. I would want you guys to burn the chat box. That is very much mandatory at this point of time. Yo, that's great. That's great. So guys, how is it going? How is everything going? How is everything going? Tell me. Tell me. Okay. And my dear friends, I want you guys to stay with me for the next 10 to 12 hours. Because I will be completing 9 chapters, okay? 9 chapters is a big deal, and that too from the 11th portion, okay? So if you stick to this particular session for the next, we say 10 to 12 hours, you are definitely going to smash all these 9 chapters in the NEET 2025. That is my guarantee. That is my guarantee, okay? Yes, yes, that is great. That's great. So, questions will be there, problems will be there, okay? We say complete concepts will be there, everything will be there. And my dear friends, let me just tell you, when it comes to the number of chapters that we are going to cover in this one, the first chapter we have units and dimensions, okay? Then we will be move on to the kinematics 1D. And when it comes to the units and dimensions, we say 4 questions are expected from this one. Kinematics 1D. Projectile motion and relative motion, okay? Like a rain man problem, you have got riverboat problem, everything will be from the scratch. Then Newton's laws of motion, then friction, then work, power and energy. Then you have got the center of mass along with the collisions portion, okay? And then you have got rotational motion, and then you have got the gravitation, okay? Okay. Yes, yes, yes. That's great. That's great. That's great. Shall we start? Shall we start? Okay. That's nice. That's nice. I think we should start with the first chapter. That is units and measurements. That's units and measurements. Okay. Yes. 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 Now, my dear friends, let's begin with the session. And the first chapter that we have exactly over here, that's units and measurements. Okay. Now, guys, when it comes to the units and measurements, it's a small chapter, but every single year, 3 to 4 questions are being asked from this particular chapter. Okay. Now, guys, listen to me very, very, very carefully. We say the first topic of units and measurements is physical quantity. What is a physical quantity? Listen to me very carefully. What is a physical quantity? We say a quantity that can be measured is called a physical quantity. A quantity that can be measured is called a physical quantity. Like you have got length. We say, sir, length of this is how much? 5 meters, 10 meters. It is a measurable quantity. We call it physical quantity. We have mass, velocity, temperature, okay, area. We have volume, density. All of these are physical quantities. We said these are all the measurable quantities, okay? That's what we call the physical quantity. And then we have the non-physical quantity. We say a quantity that cannot be measured. Okay, that quantity which cannot be measured is called as non-physical quantity. Like we say goodness. If I say, or we say love. Okay, how much love do you have for that particular person? Do you say, I have 5 kg love? No. So we say it is immeasurable. Goodness is immeasurable. Hatred, immeasurable. Light is immeasurable. Sir, intensity of light is a measurable quantity. But light itself is immeasurable. Sound itself is immeasurable. But intensity of sound is a measurable quantity, physical quantity. Okay, like it is mentioned, intensity of sound, loudness is a physical quantity. But sound only is immeasurable. Okay. Then, my dear friends, we have got physical quantity of 3 types. There are 3 types of physical quantities. Okay. The first one is what we call the fundamental physical quantity. Okay. Then we have the supplementary physical quantity. Then we have got the derived physical quantity. Okay. Then we have got the derived physical quantity. Now, my dear friends, in this particular case, when it comes to the fundamental physical quantity, these are those physical quantities which are independent of each other. These are independent from each other. Like they are not from derived. They are not derived from some other quantity. Okay. Like let's suppose, my dear friends, let's suppose if I say, I have got velocity. We say velocity is displacement upon time. What is displacement? Displacement is length and time. So when you take length and divide it with the time, then you get velocity. So means this velocity is a derived quantity. It is derived from length and time. It is derived from length and time. As simple as that. But when it comes to the fundamental quantities, these are not derived from any quantity. Like you have got length. It is not derived from anything. Time. Okay. You have got mass. Similarly, my dear friends, we say these are, when it comes to the supplementary quantities, those fundamental quantities, okay, these are also fundamental, but they do not have the dimensions. They have only unit. For now, please ignore this. After some time, you'll get to understand this. You'll get to understand. Okay. Okay. Now, fundamental and we say derived. Right now, we will be focusing on fundamental and derived. Derived, those physical quantities which are derived from fundamental quantities, like you have area, you have force, acceleration, work. Okay. Like area is length into breadth. Okay. When you multiply length and breadth, then only you get area. That's why we call it derived quantity. Force, mass into acceleration. Density is a derived quantity, mass by volume. Yes. Now, guys, when it comes to the fundamental quantities, we say there are 7 fundamental quantities. Okay. Now, what are those? We say mass. Mass is not derived from anything. We say length. Length is not derived from anything. We say time, temperature, amount of substance, electric current, luminous intensity. These are 7 fundamental quantities. Okay. Okay. And my dear friends, when it comes to the SI unit, we measure this mass in kgs, this length in meters, this time in seconds, this temperature in Kelvin, amount of substance in mole, electric current in ampere, luminous intensity in candela. And this is the symbol kg, m, s, k, mole, ampere, candela, CD. I hope this is crystal and clear till over here. One more important thing, guys, I will be sharing the notes afterwards. Please join my Telegram channel, that is t.me/YAWARMANZOOR. So join this Telegram channel, and in this Telegram channel, I'll be putting up the notes and everything. Okay. Make sure everybody of you join this Telegram channel, t.me/YAWARMANZOOR. Okay. Yes. Because we put up all the information out there only. Now, my dear friends, let's talk about this one. Derived quantities. When it comes to the velocity, everybody knows that, sir, velocity is displacement upon time. Velocity is displacement upon time. Displacement means length. How much is the displacement? It means length upon, we say, time. So when you divide length with time, you will get velocity. Acceleration means velocity upon time. Okay, velocity itself is length upon time, and then you have one more time, it means time square. It means time square. It means time square. Okay? Okay? Yes. Absolutely clear. Okay. Now, my dear friends, one more important thing I just want to say over here. What is that? What is that? What is that? That is unit. That is unit. Let's first talk about this. If I say I have got a distance, let's suppose that this is a road, okay? And the length of this road is 25 kilometers. What is this kilometer? This kilometer is what we call the unit. This kilometer is what we call the unit. So basically, you are measuring this distance in kilometers. Kilometer means unit over here. Okay? It is 25 times 1 kilometer. Similarly, you can also say it is 25,000 meters. This is also the unit. This is also the unit. Okay? This is also the unit. Now, my dear friends, unit means in which you are exactly measuring. Now, my dear friends, listen to me very carefully. There were different system of units previously. Like. One country was following CGS system. Another country was following FPS system. Another country was following MKS system. Another country was following SI system. Okay, this was the this was the modified system later on. Okay. Now, guys, listen to me very carefully. Listen to me very carefully. When it comes to the CGS system, what does this mean? Guys. C means centimeter, means this is that country. Imagine this is that country where length is measured in centimeters, where mass is measured in grams, where time is measured in seconds. Okay, this is length, this is mass, and this is time. Similarly, another country was following FPS system. They were measuring length in foot, okay, mass in pound, time in seconds. Another country was following MKS. M means meter, K means kg, S means second. Okay. Then when these different countries were following different system of units, finally they came up with SI system. Okay. And this was accepted by all the countries. We say it is the modified version of MKS system, SI system. Okay. When the different people were supposed to trade between each other, at that point of time, they were facing the problems. They were saying, sir, give me, we say 5-foot rod. These people were saying, what is this foot? So that's the reason they came up with the SI system. Okay. Here it is centimeter, gram, second, foot, pound system. Second, okay, this is meter, kg, second. And then we have this SI system over here. Now, guys, listen to me very carefully. I'll just write over here. Units for different physical quantities in MKS system, CGS system. Take a look over here. Let's suppose velocity. It is displacement upon time. When it comes to the MKS system, meter, kg, second. How do you write? Displacement means meter. Time means second. So it is meter per second. Here in MKS system, it is meter per second. But here in CGS system, meter, we write centimeter. Here we measure the length in centimeter. Time in seconds also. When it comes to the velocity upon time, velocity means meter per second. So here it is meter per second, and time. Once again, time is second. So meter per second square. This is acceleration. Then, my dear friends, here, instead of meter, I'll write centimeter upon. Instead of second, I'll write over here second square only. It is same. Then force, mass into acceleration. We measure the mass here in kilograms, kg. Acceleration is, we say meter per second square. Here in CGS system, if we have to write its unit, instead of kg, I'll write grams. Okay, gram, and then meter, you have centimeter upon second square. Similarly, momentum is mass into velocity. So mass means kg, velocity is meter per second. And here, instead of kg, we'll write gram, and then we say centimeter per second. Is this clear? Is this clear? Is this clear? Guys, let me know in the chats if this is crystalline clear till over here. If this is crystalline clear till over here. If this is crystalline clear till over here. Everyone. Everyone means everyone. With the fire emojis. And guys, if you have not liked the session yet, smash the like button as soon as possible. Okay? Everyone means everyone. That's great. Similarly, when it comes to the pressure, pressure means force per unit area. Pressure means force per unit area. Sir, for force, we say it is kg, meter, and when it comes to the MKS system, meter, kilogram, second, okay? Kg, meter, per second square, okay? And then we have area. When it comes to the area, area means length into breadth. That is meter square only. Length is meter, breadth is meter. So meter square only. This and this will cancel. So it will come out to be kg. And then we say in this particular case, kg meter per second square upon. This will be something like this. This is kg upon second square. And then we have meter in this particular case. Okay. Because when it comes to this, we say, what is the value of this? Kg meter per second square. Okay. And then you have over here kg meter per second square. This is the force. And when it comes to the area, area means meter square. So 1m will cancel with this m and this will be over here. And similarly here it will be gram, and then we write over here. When it comes to the second, it will be second and you have got the centimeter over here. Okay. 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 Yes. And when it comes to the work, work is force multiplied by displacement. Force in this particular case, that is kg meter per second square. Okay. Mass into acceleration, kg meter per second square, meter per second square. And then you have multiplied by displacement, that is m. So you guys can write it something like this. So it will be m into m is m square, meter square divided by second square. Okay. Now guys, here, can I say instead of kg, I'll write gram and then we say centimeter square upon we say second square. Similarly, density means mass by volume. Mass is, in this case is kg. Volume means meter cube, kg per meter cube. And here you can write centimeter. Here you can write that is gram per centimeter cube in this particular case. This is how you guys are supposed to write this. Now guys, let's suppose we have got the first question over here on the screen. Convert the momentum of a ball from MKS system to CGS system. Let's suppose you have got a ball over here. Its mass is, let's suppose, 10 kgs. Okay. And its velocity is, let's suppose, 5 meter per second. If I say, what is the momentum of a ball? You'll say, sir, momentum of a ball is mass into velocity. This is the formula. You'll say P is equal to mass is 10 kgs. Okay, this is 10 kg. Velocity is 5 meter per second. Yes. So this will be 10 into 5 is, this is 50. Kg, then we say meter per second. Kg meter per second. Okay. Okay. Now, my dear friends, listen to me very carefully. This is in MKS system. You have to convert this in CGS system. You have to convert this in CGS system. Guys, listen to me very carefully. If I say this is 50 kg meter per second, listen very carefully. I'll show you the trick. How many grams is equal to 1 kg? You say, sir, 1000 grams is equal to 1 kg. Yes. Instead of 1 kg, I'll write 50 as it is. Instead of 1 kg, can I write 1000 grams? Yes, I'll write 1000 grams. And How many centimeters is equal to 1 meter? We say 100 centimeters is equal to 1 meter. Instead of 1 meter, I'll write 100 centimeters. Yes. Then divided by second as it is. Now guys, how can I write? See. This is 10 raised power 2, 10 raised power 3. So means 10 raised power 5 and 1 0, 10 raised power 6. So it becomes 5 into 10 raised power 6. Then you have got gram. Then you have got centimeter per second. This is how we are converting. This is how we are converting. Okay. Now, my dear friends, you have got this one. Let's suppose you have given a density in this particular case. You have given a density in this case. And you are supposed to convert it to CGS system. See. Density is given as 6 kg per meter cube. You are supposed to convert it. How do we convert it? It is 6. And when I say kg, guys, it is 6 kg per meter cube. Can I write instead of kg? I'll write over here 1000 grams. Yes. And divided by meter cube. Instead of meter, I'll write 100 centimeters. Okay. Then I say whole cube because it is meter cube. So can I say in this particular case, this is 6 into 10 raised power 3 grams divided by, here, it is 10 raised power 2 whole cube because it is meter cube, 10 raised power 2 whole cube. So that is going to be 10 raised power 6. Okay. And this will be centimeter cube. Now 10 raised power 3 and this will cancel over here. So this will be 6 into 10 raised power minus 3 gram per centimeter cube. This is how we guys are supposed to convert this. Yes, exactly. Let's suppose now, if you have to do the reverse, how do you do the conversion over here? Guys, density in this case is 6 gram. We say 6 gram per centimeter cube. You have to convert this to the MKS system. See. We say 1000 grams is equal to 1 kg. Okay. How many, if I say 1 gram will be 1 upon 1000 kg. Yes, take it over here. So can I say it something like this also? 1 gram will be also, guys, this is 10 raised power 3. So you can take it in the numerator, 10 raised power minus 3 kgs. Yes. Similarly, 100 centimeter is equal to 1 meters. And 1 centimeter will be equal to 1 divided by 100 centimeter. Now this is 1 upon 10 raised power 2. So you can write 1 centimeter is equal to 10 raised power minus 2 centimeters, something like this. Now put it over here. Guys, density will come out to be 6. Instead of 1 gram, can I write 10 raised power minus 3 kgs? Yes, I can write it something like this. Now, divided by centimeter, 1 centimeter. 1 centimeter is 10 raised power minus 2. It is 10 raised power minus 2. I can say, okay, 10 raised power minus 2 meters. Then we say whole cube. Yes. Now, guys, can I write over here? Guys, see. 10 raised power minus 2 whole cube. That is 10 raised power 6. 10 raised power 3, 10 raised power 6. So this will be 6 into, guys, 10 raised power minus 3, 10 raised power minus 3. So here it remains 10 raised power minus 3. That will go in the numerator. So 10 raised power 3. This will be kg per meter cube. Is this clear? Is this clear? Is this clear? Tell me, guys, quickly in the chats. Everyone means everyone. Everyone means everyone. And if you have not liked the session yet, I would want you guys to smash the like button. Everyone means everyone. Everyone means everyone. Now. Let's move on to the dimensions. Yes, PDF will be shared. So I would want you guys to join this Telegram channel because I'll be sharing the PDF here. t.me/YAWARMANZOOR. So please do join this Telegram channel. I'll be sharing here also. Okay. Yes. Now, guys, take a look. Dimensions. What does dimensions exactly mean? See, we say it gives us an idea how many fundamental quantities are involved in a physical quantity. How many fundamental quantities are involved in a physical quantity? Now guys, we say velocity, it is displacement upon time. How many displacements, sir? One displacement. Is it displacement square? No, no, no. One displacement, one time. So displacement means length. So I'll write L1, one length. And time, how many time? One. So I'll write T1. Now, if I take this in the numerator, it will be LT minus 1. This is the dimensional formula of velocity. What does it say? What does it say? If I say LT minus 1, it says this is the dimensional formula of that physical quantity in which one length is involved, one time is involved, but time is in the denominator because it is minus 1 here. Yes. Now, for velocity, we say LT minus 1. Now for acceleration is velocity upon time. Guys. For velocity, what is the dimensional formula? LT minus 1. And upon, you have got time over here. Now guys, see. If you take this time in the numerator, so it will become LT minus 2. What does it say? It says acceleration is that physical quantity in which one length is involved, okay? One time is involved because of the velocity, another time is because of the acceleration, v divided by t. Similarly, when it comes to the force is mass into acceleration. For mass, we say m. We measure mass with m, we write mass with m. Acceleration, LT minus 2. This is the dimensional formula of acceleration. Work means force multiplied by displacement, F into S. For force, it is ML T minus 2. And when it comes to the displacement, my dear friends, that is L only. So can I say this will be M L2 T minus 2? Yes. Energy. Guys, what is energy? Energy, you can say, sir, that is 1 divided by 2 mv square, kinetic energy, whatever you say, you can also take that formula. Now guys, 1 by 2 is a pure number. Pure number is always dimensionless. Ignore this. So for mass, it will be m. For velocity, it will be L. For velocity, it will be LT minus 1. But it is velocity square, so I'll put square over here. So it will be M L2 T minus 2. For power means energy upon time. What is the formula for energy? That is M L2 T minus 2 upon time is T. Now take this in the numerator. So it will become ML2 T minus 3. This will be the dimensional formula for the power. Okay. Now guys, similarly, momentum, mass into velocity, ML. For mass, it is M. For velocity, it is LT minus 1. Angular displacement, it is dimensionless, my dear friends. M0, L0, T0. Okay, keep this thing in your mind. Angular displacement means theta, angle. Now guys, angular velocity, that is theta upon time. For theta, it is dimensionless. So divide by time. Time will go in the numerator, so it will be T minus 1. Even you can write it like this also. M0, L0, T minus 1. No mass, no length, only time. That too in the denominator. Angular acceleration, that is omega upon time. Angular velocity means omega. Okay. So for omega, it is T minus 1. Divided by time, so it will become T minus 2. Frequency, 1 upon time, inverse of time period. So it is T raised power minus 1. I hope this is clear. Now, different physical quantities can have same dimensional formula. Different physical quantities can have same dimensional formula. Take a look. Physical quantities having same dimensional formula. Physical quantities having same dimensional formula. Sir, what is distance? Distance means length. What is displacement? Length. What is radius? Length. What is light year? It is also length. Okay. Wavelength, it is also length. Radius of gyration, length. Focal length, okay, parsec length, astronomical unit, length. So all of these have the same dimensional formula L. Means different physical quantities can have same dimensional formula. Yes. Now speed, velocity, velocity of light, velocity of sound, terminal velocity, average velocity, orbital velocity. All are velocities now. So they are having the same dimensional formula LT minus 1. Next, acceleration. Average acceleration, acceleration due to gravity, intensity of gravitational field, centripetal acceleration, tangential acceleration, all have the same dimensional formula, that is LT minus 2. Impulse, change in momentum, same having the dimensional formula of momentum MLT minus 1. Impulse is also change in momentum. Force, weight is also force. Tension is also force. Thrust is also force. Gravitational force is also force. Spring force, electrostatic force, magnetic force, normal reaction, friction, all are the different versions of force, so they will be having the same dimensional formula. That is the dimensional formula of force. MLT minus 2. These are the simple things. These are the simple things. Okay? Okay. So we can say different physical quantities can have same dimensional formula. Different physical quantities can have same dimensional formula. Okay? Yes. Yes. Now, let's talk about Planck's constant. Sir. Can you find for the Planck's constant? See. We say energy of a photon is equal to h into f. This is the formula we study in the modern physics. Now, I can say what is this h? H is Planck's constant. H will be energy divided by frequency. Okay? Okay. So Planck's constant is energy by frequency. What is the dimensional formula for energy? We recently got the dimensional formula of energy. What is that? What is that? That is, for energy, it is mL2T minus 2. mL2T minus 2. So can I say over here it is mL2T minus 2 divided by frequency is inverse of time period. So means it is T minus 1. So I'll write over here T minus 1. Okay. Now tell me, if you take this in the denominator, numerator, so T minus 1 will cancel. So it will be mL2 T minus 1. This is the dimensional formula of Planck's constant. Angular momentum. Sir, angular momentum is RP, R cross P, RP sine theta. Okay, R means radius, P means momentum. For radius, it is L. For momentum, it is ML T minus 1. So now it will be M. Okay, L into L becomes L square T minus 1. Spring constant. Guys, there is a relation F is equal to K times of X. Basically, if you know the formula, you would be able to find it. Okay. Okay. Now, I can say K will be equals to F divided by, in this particular case, X. So, for force, you know, MLT minus 2 and X will be L. You can put the formula exactly over here and you can get this value. You can get this value. Now, guys, listen to me very carefully. Let's suppose if you are getting capacitance. If you are getting capacitance, listen to me very carefully. Sir. In order to find the dimensional formula of capacitance, I would recommend one single thing. See, there are two formulas of capacitance. Q is equal to CV, U is equal to Q square by 2C. This is the energy stored in a capacitor. This is the energy stored in a capacitor. Okay, this is the charge on the capacitor. Sir, will you prefer to use this formula or this formula? I would suggest you guys to use that formula in which energy is involved. Why? Because it will make it simple. It will help us to solve it quickly. Don't use this formula. Okay. Here, it becomes complicated. You have to find this is V means potential. You have to find the dimensional formula of potential first. Use this formula. Use that formula of a physical quantity in which energy is involved. U means energy, Q means charge, C is capacitance. Now, see, take it over here, C. So, C will be Q divided by U. Now, guys, listen to me very carefully. We say current is charge upon time. Can I say charge will be current multiplied by time? Yes. Now, current means current only, I only, okay? I only. Time means time only, T minus 1, T1, I1, T1. This is the dimensional formula of charge, okay? Now, for charge, it is IT, it is square, so square. For energy, we know it is ML2 T minus 2. Now, do the simplification. This will be the dimensional formula of capacitance. Similarly, for inductance, use that formula of inductance in which energy is involved. Okay, So now you will say, sir, can I use this? Phi is equal to L into I. This is also the formula of inductance. Phi means flux, L means self-inductance, I means current. In this case, you have to first find the dimensional formula of flux. So that becomes complicated. That's why we say use this formula in which energy is involved. U is equal to 1 by 2 Li square, energy stored in an inductor. See here, 1 by 2, remove it. So U, here, this L will be equals to U divided by I square. U is the energy, I is the current. Put the values and get the dimensional formula. So the simple trick is use that formula in which energy is involved, okay, in which energy is involved. I hope this is crystal and clear. Okay, now guys, take a look. Energy density. Okay, some people say when it comes to the current we write ampere, also, some write, I also say some write ampere also. It's one and the same thing. Okay, it's one and the same thing. Now when it comes to the energy density means energy per unit volume. Guys, energy divided by volume. For energy it is ml 2t minus 2. Volume means L cube. So this will be for the energy density. Mass density means mass per unit volume. For mass it is m, for volume it is L cube. So this will be m L raised power minus 3. Charge density means charge per unit volume. So Q divided by L cube. So for Q it is I into T, L raised power minus 3. Then we say areal mass density. It is basically mass divided by area, that is ml L raised power minus 2. Then we say for pressure, force per unit area. For force it is mlt minus 2. For area it is L square, length square. So it will be m L raised power minus 1 because it is L2. And this and square will cancel, L raised power minus 1, T raised power minus 2. Okay, I hope this is crystalline clear. And when it comes to the strain means change in length divided by original value of length, delta L by L. Guys, what is change in length? That is length only, length. What is this? This is length, and cancel, so it is dimensionless. If the same physical quantity is divided, then it becomes dimensionless. This will cancel with this. Okay, dimensionless. Coefficient of friction. Guys, frictional force is equal to mu into N. So mu will be frictional force divided by, this is force. Normal reaction is also force. Force cancel. This is also dimensionless. That's why if same physical quantity is in division, it will become dimensionless. Pure number 4, 5, 10, 15, etc. These are all dimensionless. Pure numbers are also dimensional. Now tell me in the chats, is this crystalline clear? Tell me in the chats, is this crystalline clear? Quick. With the fire emojis. Make sure everybody has smashed the like button. That's great. Now guys, we have another topic, that is principle of homogeneity. What does principle of homogeneity say? It says we cannot compare two different physical quantities. Like, if I say 4 meter plus 2 kg, can you add mass with the length? Sir, no. 4 meter length is added to 2 kg mass. It is not possible. It is incorrect. It is wrong. Because mass is a different physical quantity, okay? Length is a different physical quantity. Similarly, my dear friends, 3 meters minus 2 seconds. So you cannot subtract time from length. This is also incorrect. Now, if I'm saying, sir, 5 kg is greater than 3 meters, it is also incorrect. It is illogical. How can you compare two different physical quantities? It is not possible. Okay, okay. But my dear friends, if I say 8 meter plus 7 meter, this is also length, this is also length, that will be 15 meters. It is correct. So we say two different physical quantities cannot be added or subtracted. Two quantities must be of same unit and dimensions. Two quantities must be of same unit and dimensions, which can be added or subtracted or equated. This is called principle of homogeneity. Sir, what about multiplication? But remember, you can multiply two different physical quantities. Sir, how? We say force is equal to mass into acceleration. Okay. Force is equal to mass into acceleration. So mass is one physical quantity, acceleration is another physical quantity. You can do it. Sir, when it comes to the momentum is mass into velocity. So mass is one physical quantity, velocity is another physical quantity. Sir, can we divide? Yes, we can say acceleration is force divided by mass. This is one physical quantity, this is another physical quantity. Two different physical quantities cannot be added, subtracted, equated, but they can be multiplied, they can be divided. This is called the principle of homogeneity. Now, on the principle of homogeneity, we have a question over here. If A and B are different physical quantities, then which one is correct? A plus B, is this correct? If A is one physical quantity, B is another physical quantity, is it correct? Incorrect. Why? Because it says two different physical quantities cannot be added or subtracted. Now, A by B. Yes, sir. Example is acceleration is force divided by mass. So yes, here it is no, not possible. A minus B square. See guys, if I say, let's suppose A is area. Let's suppose A is area. And let's suppose B is length. B is length. Now, can I say here, this is area minus. What is B? B is length square. So length into length also becomes area. So this is also area. So area minus area. Yes, now it becomes similar physical quantity. Yes, area minus area is area. So yes, this is possible. What about this one? Is this possible? Is this possible? D option. See guys, we say yes, this is also possible. Let's suppose if I say A is 5 kgs. Okay, A is 5 kg. Okay, this is mass. A is a physical quantity, 5 kg. And I'm saying B is a constant. I'm saying 5 into 4. Okay, then we say plus A. A is again 5 kg because we have kept A as 5 kg. Now 5 into 4. You can multiply. Multiply is possible. 5 into 4 is, we can say 20 kg. Then we say plus 5 kg. Now, two similar quantities, this will come out to be 25 kgs. So yes, this is possible, this is possible, this is possible, this is not possible. Okay, what about this one? What about this one? What about this one? What about this one? Take a look, guys. If velocity v is equal to alpha t, here, v is equal to alpha t plus beta x minus gamma x t. Okay. Yes. This is the value of velocity. Then find the dimensions of alpha, beta, and gamma. Then we are supposed to find the dimensions of alpha, beta, and gamma. Okay. We are supposed to find the dimensions of alpha, beta, and gamma. Okay. I want you to understand one thing. Guys, is the speed fine or am I going fast? Please let me know in the chats. We have to cover a lot. I have to move bit fast. You need to understand that. Let me know in the chats if the speed is perfectly fine or am I going fast? Perfect. Slow is not the option. Option is fast or fine. Fast or fine. Okay, only two options. That's great. That's great. Take a look. Guys. If I'm saying in this particular case, velocity is equal to this, it is only possible. Listen to me very carefully. It is only possible if this quantity is equal to this quantity. Why? Because if I'm saying velocity is equal to this plus this minus this, two physical quantities can only be added or subtracted if they are dimensionally or if they are the similar physical quantities. So can I say according to the principle of homogeneity, this V must be equals to alpha t, and this must be equals to beta x, this must be equals to, we can say, gamma xt. Yes, because then only we can add them, subtract them. Okay, if they are similar, if they are equal, we can say it something like that. Now guys, see, I can say V is equal to alpha t. This is how we guys are supposed to solve this. So alpha will be equals to V divided by t. What is the value of V? It is LT minus 1 divided by, what is the value of this? This is t. So alpha is going to be LT minus 2. It is going to be LT minus 2. So dimensional formula of alpha is LT minus 2. Then we can say V is equal to beta x. V is equal to beta x. Equate this with this one. So here you can get beta is equal to V divided by x. So V is velocity. So for this it is LT minus 1. For x it will be L. This and this will cancel. It will be T minus 1. Then my dear friends, I can say V is equal to gamma xt. So here for gamma it is going to be V divided by x into t. For gamma, what is the dimensional formula of velocity? LT minus 1 upon, for this it is L, for this it is t. This and this will cancel, so it will be t raised power minus 2. This is how you guys are supposed to solve this. Equate them, because principle of homogeneity says that two physical quantities can be only added or subtracted if they are similar. Then if velocity V is equal to a sine of this, then find the dimensions of alpha. Guys, don't you think that you can compare it with V is equal to a sine of theta? You can compare this equation with this one. You can compare this equation with this one. Yes, here it is a, here it is sine, here this is the angle, here this is theta. So we say from the two equations, I can say theta is equal to x under root of alpha t. Yes. Now guys, can I write it? When it comes to the theta, I have told you theta is a dimensionless physical quantity, okay? So I can say this is 1 divided by x is equal to under root of alpha t. Instead of theta, I'll write 1. Now take this root. Instead of this root, we can put square over here. So I can write 1 divided by x square is equal to alpha t. So can I write here. Alpha will be equals, take this t over here. So alpha will come out to be 1 upon x square into t. Yes. Now, how many of you can answer this? Sir, when it comes to the dimensional formula of alpha, you'll be writing 1 upon x. X means length. So it will be length square. Then we say time. Take this in the numerator. Alpha will be L raised power minus 2, T raised power minus 1. This is the dimensional formula of alpha. Okay. Then. Okay. Take a look. Check. The equation is dimensionally correct or not. Which of the three equations is dimensionally correct or not? First of all, let's talk about physically. Guys. What is the formula for kinetic energy? 1 by 2 mv square. So it is physically correct. Physically correct. Okay. Okay, 1 by 2 mv square. Sir, is this physically correct? We say it is physically incorrect. Sir, what about this? This is not the kinetic energy formula mv square sine theta. This is physically incorrect. Okay, let's talk about dimensionally. Sir, what is the dimensional formula of this one? So for this kinetic energy, it is, what is the dimensional formula of energy, kinetic energy? It is m. For velocity, it is lt, I can say minus 1 whole square. So it will be L2 t minus 2. For velocity, it is Lt minus 1. Then if you put the square, L2 t minus 2. Yes, because 1 by 2 is dimensionless. So dimensionally, yes, dimensionally correct. Dimensionally correct. What about this one? What about this one? Sir, dimensional formula of this one, 2 by 5 is dimensionless. So for this m, for this v square, L2 t minus 2. This is also dimensionally correct. This is also dimensionally correct. Yes. Sir, what about this one? What about this one? Listen, guys, what about this one? For this kinetic energy, this is m. For velocity, L2 t minus 2. For sine theta, it is dimensionless. So this is also dimensionally correct. Yes. This is also dimensionally correct. Means all the three formulas are dimensionally correct. But physically only this is correct. Now, can I say the statement? From this we can say, listen guys. If an equation is dimensionally incorrect, then physically it will be incorrect for sure. Physically also it will be incorrect. If an equation is dimensionally incorrect, physically also it will be incorrect. But if an equation is physically incorrect or wrong, dimensionally it can be or cannot be incorrect. Like here, these are physically incorrect, but dimensionally they are correct. But if there is a, we say, see, take a look at this equation. This equation is dimensionally incorrect. Okay, it is, sorry. If an equation is dimensionally incorrect, let's suppose if I say kinetic energy, take a look. If I say kinetic energy is m square v square, tell me, okay, or I'll write it like this, 1 by 2 m square v square. Sir, this is physically incorrect. And what about dimensionally? Dimensionally also it is incorrect. See, for this it is m square L2 t minus 2, means wrong. So, if an equation is physically incorrect, dimensionally it can be correct or cannot be correct. But if an equation is dimensionally incorrect, physically 100% it will be incorrect. I hope this point is crystalline clear. 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 Is this clear? Is this clear? That's great. That's great. That's great. Now take a look. Guys, if you have not liked the session, like the session as soon as possible. If you have not liked it, do like the session. And do join my Telegram channel. Take a look. Significant figures. Let's suppose if I ask you the question, sir, 5, 6, 7, 2, 5, 2. How many significant figures are there in this this number? Sir, how do we find the number of significant digits or figures? See, there are some rules which you need to follow. Rules for significant figures. All non-zero digits are significant. Example, 56 has how many significant digits? You'll say, sir, 1 and 2, all non-zero. Non-zero means 1, 2, 3, 4, 5, 6. Okay, so means 2 significant figures. Okay, tell me, 5, 6, 2, 1, how many significant digits? Sir, 4. Okay. all zeros between non-zero digits are significant. All zeros between non-zero digits. 1, 2, 0, 5, 3, 1. How many significant figures? 1, 2, 3, 4, 5, 6. Why? Here you consider this as significant. Why? Because it is between the non-zeros. All zeros between the non-zeros. Okay? All zeros on the left side are non-significant. If the zero is placed on the left side, it is non-significant. It is non-significant. Okay? Okay? Like this. These are placed on the left side. How many significant figures? 0.000085. These are not significant. These two are significant. Only two. Yes. Now, power forms are not considered as significant. Like if I say 2.4 into 10 raised power minus 9. How many significant figures? Only two. These are not considered as significant. Non-significant. Trailing zero after the decimal place is significant. Okay, after the decimal place, you consider that as significant. Like you have, how many significant over here? How many significant digits over? Just a second. Yeah, let's take a look here in this particular case. 85 mm. How many significant? 2. 8.5. How many significant? 2. So basically, guys, if you are converting it to the another unit, 85 mm to 8.5 centimeter. 8.5 centimeter, if you write in meters, 0.085 meters. So here, these are considered to be non-significant. These two are significant. Significant figures remain the same. Okay, here in this particular case, 8.5 into 10 raised power minus 2. Only these two will be significant. So 2 significant. Here, these are considered as non-significant. Only 85s. So it is 0.00085. So only these two are significant. Okay. So means. Guys, simply, these are the rules which you need to go for the significant. All non-zero digits are significant. 56. Okay, I'm slowing down a speed a bit. 56 has got 2 significant digits. All zeros between non-zero digits are significant. Okay. All zeros on the left side are considered as non-significant. Zeros on the left side, non-significant. Power forms are not considered as significant. Trailing zero after decimal place is significant. Okay. Now, even if you change it to the another unit, we say significant digits remains the same. Significant digits remains the same. Yes. Like. There is an important question in this one. Okay. Listen, guys. Listen. Okay. Last point is this one. Even if you convert to the another unit, means 85 mm, you can write it 8.5 centimeter. 8.5 centimeter, if you convert to the meters, it will be 0.085 meters. If you convert this into kilometers, it will be 0.00085 kilometers. We say, no doubt you are changing the unit, but significant figures remain the same. That's what I'm trying to say. Okay. Now guys, an important point. We say multiplication or division of significant figures. See. Let's suppose you have got over here A is equal to 25.5. Okay. A is equal to 25.5 and B is equal to 5. Okay. Find A divided by B. If I say A divided by B, what will you say? This is 25.5 divided by, I would say 5. 5 5s are 25. Okay, 5 1s are 5. So this is 5.1 in this particular case. But here it is mentioned, final result is written in minimum significant figures. Final result is written in minimum significant figures. Now guys, see. If I say in this particular case, if I say, let's suppose it is 5.1. Okay. Now, my dear friends, you are not supposed to say this is the final answer. Why? because you have to write this in the minimum significant figures. Okay, you have to write this in the minimum significant figures. Minimum significant figures means how many significant figures are in this one? 1, 2, 3. How many significant figures are in this one? 1. So you have to write the result in minimum significant figures, means in the result there should be only one significant figure. So answer is 5. Okay, so I'll write over here in this particular case, answer is 5. Is this clear? So, in case of multiplication and division, minimum answer, final answer is written in minimum significant figures. Here, 3 significant figures, B is 1, here 1 significant figure. So answer should be also in minimum significant figures. Like this was the question asked in NEET 2020. See. It is 9, this is multiplication and division. Okay. Before this, you need to understand this. Let me first teach you this. Yeah, this is the question for this one. Okay, let's take a look. See. Guys. 97.52 divided by 2.54. What must be the answer in all the 4 cases? When you have to divide, answer must be in the minimum significant figures. See guys, how many significant figures are in this one? 1, 2, 3, 4. How many significant figures are in this one? 1, 2, 3. So answer should be also in the minimum significant figures. So option D, without solving, option D is the answer. I hope now you got it. Okay. This one. Take a look at this one. Taking in, okay. Before this, you need to understand this one. Yeah, this one. See guys, addition and subtraction of significant figures, final result is written in minimum decimal place. See guys, in this particular case, if I say A is equal to 2.413, okay, B is equal to 1.2, you are supposed to find in this particular case, sir, A plus B. Now tell me, 2 plus 1 is 3, okay, 4 plus 2 is 6. Now, final result, like, if I show you here, taking into account what is the value of, directly I will say 9.99 minus 0.0099. Okay, in this particular case, you are supposed to tell me, guys, final result is written in minimum decimal place. Now see, in this particular case, after the decimal, how many digits? 1 and 2 digits. Okay, after the decimal, in this case, there are 2 digits. After the decimal, how many digits? 4. So final result is written in minimum decimal place. So tell me, which of the 4 options is correct? Option A, because after the decimal you have got how many? 2. Because in case of CCC, here final result is written in minimum decimal place. And when it comes to here, after the decimal, how many? Sir, 2. So you check here, you have got 2. Is this clear? Please tell me in the chats. Everyone means everyone. Guys, with the fire emojis, I want you guys to tell me if this is crystalline clear to each and every single student. I want you guys to tell me if this is crystalline clear to each and every single student. Okay. That's great. That's great. Okay. And in this one, final result is written in minimum decimal place. Okay. Here after the decimal, how much? You have 1. So answer after the decimal. So it should be 3.6 only. Yes. Yes. Now guys, take a look. Yes, 3.6 is the correct answer. Now guys, take a look. Take a look. You have got measuring instruments, meter scale. Have you ever seen this meter scale in your life? Sir, why do we use it? So that we can measure the length. We can measure the length. We can measure the length. Okay. Now guys, take a look. Take a look. I want you to understand this. Sir. This meter scale, if you can see exactly over here. Guys. See. If you say, sir, from 1 to 2, if you take this, sir, if I see from 1 to 2, this is called 1 centimeter. This is 1 centimeter, 2, 3, 4, and so on. This 1 centimeter. How many divisions are in this 1 centimeter? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So means there are 10 divisions. This is what we call the meter scale division or main scale division. Meter scale divisions. So can I say in 1 centimeter there are 10 meter scale divisions, and this one division is equal to 1 mm. 1 mm. Either you say 1 main scale division or 1 mm, it's one and the same thing. So 10 main scale divisions is equal to 10 mm is equal to 1 centimeter. I hope this is clear. Now if I say 1 mm, 1 main scale division, it is equal to how many centimeters? You say it will be 1 divided by 10 centimeter. 1 divided by 10 centimeter. Okay. So 1 mm is 1 divided by 10 centimeter, or you say it is 1 MSD. 1 MSD. Yes. Now guys, why do we use this? For what purpose we use this? Sir, we say we use this to measure the length. Let's suppose we are supposed to measure the length of the rod. This is the rod. Okay. And guys. Now, from 1 to 2, this I am making over here in a zoomed view. So this is 1 mm, 2, 3, 4. Okay. This is not the complete scale. This is from here to here. It is 1 centimeter. It is 1 centimeter. Yes. Now guys, see. If I say this is the rod over here, listen to me very carefully. What is the length of rod? You say, sir, length of the rod is 3, it is crossing 3 mm. Sir, 3.5. Is it correct or incorrect? It is incorrect. Because, sir, between this and this, there is no numbering. Nothing is mentioned over here, so you can't say 3.5. Okay. Now, if I say, guys, if I say, sir, what is the length of this till here? It is 4 mm, but it is 4 point something. Something we don't know. So how do we take the reading over here? We say it is main scale reading, okay, plus minus least count, like it is mentioned over here. Main scale reading plus minus least count. Least count means the maximum error produced or the minimum reading that we can take. My dear NEET aspirants, please take a look. If I say, sir, can you measure this much? Yes, sir, here till here. This is 1 mm, 2 mm, 3 mm, 4 mm. Yes. But if it is between 3 mm and 4 mm, can you measure that? No, not possible with the help of meter scale. So what is the maximum error that can be produced in the meter scale? That is this 1 mm. This is called least count. Least count is the minimum reading that we can take or maximum error produced. Minimum reading or maximum error. So how do you measure the length? How do you measure the length in case of a meter scale? Main scale reading plus minus least count. So here. What is the length of the rod? 3 mm is confirmed. Plus minus 1 mm. We don't know. It can be plus 0.5, 0.6, 0.3, 0.4. We don't know. Plus minus 1 mm. This is the least count. Okay. So maximum error or the minimum reading that we can take. I hope this is clear. Similarly, if I say, what is the length of this rod? Sir, L1, 4 mm plus minus 1 mm. Sir, what is the length of second rod? 4 mm plus minus 1. What is the length of third rod? It is exactly 5 mm. It is exactly 5 mm. Okay. So when it comes to the least count, we say it is the minimum reading that can be taken by the instrument. It is the minimum reading that can be taken by the instrument. Okay. Or maximum possible error that can be produced by an instrument. For meter scale, what is the least count? 1 mm. So means, my dear NEET aspirants, if there is an object which is less than 1 mm, like if I say this rod, can you measure it? No. If there is an object which is less than 1 mm, you can't measure it with the help of a meter scale. Okay. Then, if you have to measure the object which is less than 1 mm, you use another measuring device, that is vernier caliper. Now, this vernier caliper actually looks like this. It has two scales. This is the main scale and this is the vernier scale. It has two scales and this vernier scale is slidable. Let me show you over here. See guys, this main scale is over here. How many divisions are in the main scale? 10 divisions, 10 mm. Okay. Then this vernier scale, we said this vernier scale has got, this is the main scale. This vernier scale has got, we say, I would say in this particular case, this has also got 10 divisions. But, the point is, 10 divisions of vernier scale is equal to 9 divisions of main scale. 10 divisions of vernier scale is equal to 9 divisions of main scale. So, 10 vernier scale divisions is equal to 9 main scale divisions. 9 main scale divisions means 9 mm. Can you tell me, one vernier scale division will be equal to how much? That will be 9 divided by 10. 9 divided by 10 mm. That is 0.9 mm. That is 0.9 mm. Okay. Okay. Now, my dear friends, means. This vernier scale has got this division equal to how much? 0.9 mm. This is also 0.9 mm. But this is 1 mm. Vernier scale division is 0.9 mm. Now, guys, if this is 1 mm, this is 0.9. How much will be this? 1 minus 0.9, this will be 0.1. Okay. Now, this is 0.9. 0.9 means 0.18. 0.9, 0.27. Okay. So, here it is 3. 3 minus 0.27. So, this will be 0.3. This will be 0.3. This will be 0.3. Is this clear? Is this clear? Is this clear, guys? Is this clear? Yes. Now, guys, take a look. So, listen to me very carefully. Guys. in this particular case, this is 1 mm, this is 0.9 mm. What is the gap between this and this? This will be 0.1. This gap will be 0.2. This gap will be 0.3. I hope. And 1 VSD is equal to 0.9 mm. 1 VSD will be equals to 0.9 mm. Okay, okay. Now, my dear friends, first I will show you how do we calculate the least count in case of vernier scale, in case of vernier caliper. See, least count in case of vernier caliper is 1 main scale division minus 1 vernier scale division. Main scale division is 1 mm. Vernier scale division is 0.9 mm. Already calculated. Okay. So that will be equals to 0.1 mm. What is this? This is the least measurement that you can take. Okay. Don't go into much depth. Please, please, please. Whatever I say, just keep on remembering that. Please. Okay. So least count in this particular case is main scale minus vernier scale. That is 0.1 mm. Okay. Yes. Yes. Now, guys, listen to me very carefully. Listen to me very carefully. In case of vernier caliper, if you have to find the length or measurement, see, you will take the main scale reading, okay? Then you will plus least count multiplied by vernier scale reading. That's it. That's it. Please don't go into much depth. Let me show you. Let me show you the question. Let's suppose here. And one more thing. If you have to measure something, you need to keep that over here. Then you measure the length. See, we have to measure the length of this rod. We have to measure the length of this rod. This is the vernier caliper. This is the main scale. This is the vernier scale. How do you find the length? Length will be main scale reading MSR. Then we say plus minus MSR. Then you say plus least count into vernier scale reading plus least count into VSR. See guys. Main scale reading. This is the main scale. So it is crossing, this rod is crossing 1. So it will be 1 mm. Whatever I say, please follow it. Least count. What is the least count of vernier scale? 0.1. Done. Vernier scale. Vernier scale means you have to see which number of the vernier scale is coinciding with the main scale. 2, no. 3, no. Yeah, 2 is coinciding with this. 2 is coinciding with the 3 over here. So it will be 2. I hope this is clear. How do you measure? Main scale reading. You have to check it is crossing 1. It is more than 1, so it will be 1. Then plus least count. That is 0.1 for vernier caliper. Vernier scale reading. You have to check which number of vernier scale is coinciding with the main scale. So that is 2. So this will be 0.2. So how much it will be? 1.2 mm. 1.2 mm is the length of the rod. I hope this is clear. I hope this is clear. Okay. So first you have to check the reading of main scale. Okay. Like if there is an object, this you need to measure. So this is 0. Okay. And this is 1 over here. Let's suppose this is 1. So it is crossing 1. Then you have to check which number of this is coinciding with the main scale. Okay. See. Here, it is coinciding with the main scale in this particular. Okay. Like I have shown you in this particular question. That's how you guys are supposed to take it. Now, let me show you one more question. Simply, in this case. See guys, don't go into much depth. When it comes to the least count and reading, that's it. That's more than sufficient. In a vernier caliper, 8 main scale division is coinciding with 10 vernier scale division. Means 8 MSD is equal to 10 VSD. Tell me one thing. In this vernier caliper, which I gave you here, 10 VSD is equal to 9 MSD. Now tell me, in this case, 8 MSD is equal to 10 VSD. 1 VSD will be equals to how much? 8 divided by 10 MSD. Yes. Now, further, what does it say? Then find the least count. How do we find the least count? Least count means 1 MSD minus 1 VSD. This is the formula, na? This is the formula that I have told you. 1 MSD minus 1 VSD. So in this particular case, can I just write over here, least count will come out to be 1 MSD minus 1 VSD. That is 8 divided by 10 MSD. Done, done, done. Yes. So least count will be MSD, you can take common. Okay, MSD you can take common. And then you can say 1 minus 8 divided by 10. So you can say MSD, this is 10 minus 8. This is 10 minus 8 divided by 10. That is 2 by 10. 2 divided by 10. Okay. Now that is 0.2. And MSD means 1 mm. So it will be 0.2 mm. So for this vernier caliber, we say least count is 0.2 mm. So please remember, only when it comes to the reading, that is main scale reading plus least count into vernier scale reading. That's it. Then we have screw gauge. Then we have screw gauge. Now guys, take a look. Screw gauge. Guys, listen to me. I'll give you the break. Wait. We say we need a more advanced instrument which can measure up to 2 digits after the decimal. It is called screw gauge. Guys, what is the least count of meter scale? 1 mm. It can measure 1 mm. What is the least count of vernier caliber? 0.1 mm. Okay. Sir, if you have something less than 0.1 mm, we can measure that with the help of screw gauge. I hope now you are getting the feel. With the help of meter scale, you can measure up to 1 mm. Less than 1 mm, you cannot measure. Then for that, we have vernier caliper. Okay. If it is less than 1 mm also, you can measure. Then, my dear friends, if there is something less than 0.1 mm, you can use screw gauge. Now see, how does this screw gauge actually look like? Let me show you this. Screw gauge looks like this. Okay. If you have to measure something, you need to put it over here. Okay. It has got, this is the main scale. This one is the main scale. And this is the circular scale. It has got 2 scales, circular scale. Okay. Let me show you directly. See guys, we say in this particular case, this is the main scale. This is the circular scale. And this is the reference line. We say this circular scale has got 100 divisions. Okay. Main scale, this is the 1 division of main scale. Now, when you listen to me very carefully, when you rotate this circular scale, main scale also slides. See, let's suppose you are rotating this circular scale by 100 divisions, complete one cycle, tuk, one cycle. Okay. No, I'm not going slow. Please, when it comes to these instruments, here I need to go a little bit slow. Okay. But I'll go with the speed of light. Let everybody's frequency match with me so that we can, I know my job. Okay. I know how to finish 9 chapters. I have done this before. Okay. Take a chill pill. Okay. Sometimes some topics take more time. Some topics take less time. If I go fast over here, you won't be able to understand. Now see, we say if you rotate this circular scale, we say this main scale also slides. If you rotate this by 100 mm, let's suppose initially it was here. You are rotating, you have completed one cycle. It will reach here. Okay. Yes. Now guys, listen to me very carefully. So when circular scale rotates 100 divisions, complete one cycle, the main scale slides by 1 division or 1 mm. Main scale slides by 1 mm. That's it. Yes. So can I say 100 circular scale divisions is equal to 1 mm? Yes. or 1 MSD? Yes. So one circular scale, one CSD will be equals to 1 mm divided by 100. This is the least count. This is the least count of what? This is the least count of screw gauge. Okay. 1 mm means this. This is also called pitch. Okay. Okay. 100 means number of circular scale divisions. So can I define least count means pitch divided by number of circular scale divisions? Pitch means 1 MSD. Number of circular scale divisions means number of circular scale divisions. I hope this is clear. Now guys, how do we take the reading? See. First we check where the main scale is on the, where the circular scale is on the main scale. Note down the reading. Note down the reading of the main scale. Like. See guys, let's suppose you have to measure something. You are rotating. Now see, this main scale is present exactly at this circular scale is present exactly at 5 point something. Let's suppose this circular scale was here exactly at 5. So the reading of main scale was 5 in that case. Like. If I say in this case, if I say this main scale, circular scale is not here, it is present here. Okay, at 2. What is the reading of main scale? 2. Reading of main scale is 2. That is what it is saying. First check where the circular scale is on the main scale. If it is at 2, reading is 2. Note down the reading of main scale. Okay. Then check the reading of circular scale. Then you have to check the reading of circular scale, where it is coinciding with the main scale, like here. Then check, see, 75, it is coinciding with the main scale at what? 75. If you, let's suppose, rotate more. Now, if this 80 reaches here, now 80 is coinciding. Right now, what is coinciding? 75. So I would say CSR is 75. And least count, that you know, 0.01, so that you can put over here. This is how you take the reading. First, you have to check where main scale is on the circular, where circular scale is on the main scale. Then you have to check the reading of circular scale where it is coinciding with the main scale, multiplied by least count. I hope this is clear. I hope this is clear. Okay. Yes. And important is least count. Now tell me, in this particular case, guys, a screw gauge of least count 0.01, LC is given as 0.01 mm. Okay. And there are 50 divisions in its circular scale, means number of CSD is given as, this is the NEET 2020 question, that is 50. Okay. The pitch of the screw gauges, we are supposed to find pitch. Guys, we know least count is pitch divided by number of CSD. Now tell me, my dear friends, in this particular case, pitch will be least count, that is 0.01, multiplied by number of circular scale divisions, that is 50. That will be how much? 0.5. Is this clear? Is this clear? Option B. Is this clear? This is how we are supposed to find. As simple as that. Now let's come on to the errors. Okay, let's come on to the errors. See guys, last 3 slides. This one. Errors. Guys, see. First of all, absolute error. It is the difference between true value and measured value. Okay. True value minus measured value, that is called delta x. Delta x means absolute error. True value minus measured. What does that mean? Let's suppose you have a rod. Okay. The actual length of this rod is, let's suppose, 5 mm. That's called true value. In reality, it has true value. Okay. Yes. Now, my dear friends, if we are measuring this rod, I want you to understand this. If we are measuring this rod and Measured value came out to be 3. Sir, why measured value came out to be 3? Because you are not able to measure it properly, you are an illiterate, or because you have a broken instrument. There may be different number of reasons. So measured value came out to be 3. So true value is 5, measured is 3. So error came. So true value minus measured value. So 5 minus 3. So 2. 2 is the absolute error in that particular case. Okay. Okay. True value minus measured value. Okay. Now. Come over here. Come over here. Then we say relative error. Listen to me very carefully. When it comes to the relative error, listen guys. We say relative error simply means absolute error divided by true value. Relative error compares the error with the original value. Like. Listen. If I say, sir, error in the length is 1 kilometer. Error in the length is 1 kilometer. Okay. Yes. And true value is 6,400 kilometer. 6,400 kilometer. Like this is a long road. Its length is 6,400 kilometer. While you were measuring the length of the road, error came out to be 1. Okay. So means true value is 64. Measured value came out to be 6,399. That's why you are getting 1 kilometer. And if I say, one more example, sir, there is a rod. This rod has got a length of, let's suppose we say 5 centimeters, true value. Measured value came out to be 4 centimeter. How much is the error? 5 minus 4, that is 1 centimeter. Okay. Here error is this. Now, in this particular case, we say when you were measuring 5 centimeter, error came out to be 1 centimeter. When you were measuring 6,400 kilometer, error came out to be 1 kilometer. Tell me, in which of the two cases error is large? In which of the two cases error is large? Sir, error is large here. Don't say here. Sir, here 1 kilometer is error. No. You are measuring 6,400 kilometer. In 6,400 kilometer, 1 kilometer is very small. But here you are measuring 5 centimeter. In 5 centimeter, you are getting error 1 centimeter. So that is called relative error. Comparing the error with the original value, this is called a relative error. Okay. It compares the error with the original value and then tells you where the error is large and where the error is less. Okay. Relative error tells us how much big the error has been made. Yes, sir. What is the formula of relative error? Absolute error divided by true value, delta x by xt. Yes. Now, percentage error. Percentage error simply means finding the error in percentage. Sir, 2% error came, 10% error came, okay, 5% error came. That is the percentage error. How do we find the percentage error? Guys, simply when it comes to the percentage error, simply whatever is the relative error, delta x by x, multiply it with 100, it will give you the error in percentage. That's it. Like this example. See. Delta L is equal to 1 kilometer. Okay. So error, absolute error is 1 kilometer. True value is 6,400. Let's check the percentage error. Delta L by L into 100. Delta L is how much? 1. LT is 64 into 100. 1 divided by 6,400 into 100. This and this will cancel. 1 divided by 64. 1 divided by 64, not even 1%. It is less than 1%. So error in this case is less than 1%. But if you check this error here, absolute error is 1 centimeter. True length is 5 centimeter. Okay, tell me the percentage error. That is 1 divided by 5. That is 1 by 5. Percentage error will be. How do you find the percentage error over here? That will be delta L by L into 100. So delta L in this case is 1. This is 5 into, that is this 100 by 5, that is 20%. In this case, error is 25%. Okay, 20%, sorry, it is 20%. Okay, and in this case, error is not even 1%. That's what I was saying. Absolute relative error helps you to check how big the error is. Percentage error helps you to check. Percentage helps you to check how many percent the error is. I hope this is clear. Please let me know in the chats if this is crystalline clear. Okay, before this, let me show you this. If this is crystalline clear, guys, everyone means everyone. Hey guys, tell me, is this crystalline clear? Is this crystalline clear? How is the Josh, by the way? As I can see, the Josh is very high. Okay. Wait, bro. Let's finish, okay? Okay. That's great. Okay. How from guys, tell me your state's name, okay? From which state you guys are watching? Let me know in the chats. Tell me. Any Kashmiri here? Majority of the crowd will be from south. Yeah. Yo, 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 yo. That's great. That's great. That's great. Okay. Okay. Now let's focus over here. Guys, see. Let's suppose we have a physical quantity y is equal to a raised power n. Okay. Or we say y is equal to x. Guys, see. What does it mean? Y is that physical quantity which depends upon x. Means if you get the error in x, you will get error in y. Remember it directly. So how do we write this? If I say y is equal to x, if I say there is error in y, sir, delta x divided by x, this is the relative error in x. We say there will be error in y. Why? Because y depends upon x. So that will be delta y divided by y. If you will find this in percentage, multiply in 100. So multiply in 100. Similarly, if you have a physical quantity y is equal to a raised power n, y is that physical quantity which depends upon a. If there is error in a, there will be error in y. And my dear friends, see how do we write the error over here? Percentage error in y, delta y divided by y, okay? Percentage error in y is equal to, see, error in a, power down, take this n down, delta a divided by a, multiply with 100, this will give you the error in percentage. Similarly, if you have a physical quantity, this y depends upon a as well as b. If there is error in a, there is error in b, there will be error in y. See how do we write over here? Here, percentage error in y, delta y divided by y into 100, okay? Or we say percentage error in y, okay? So I can say this will be n down, delta a divided by a plus error of b, m down, this is m down, delta b divided by b, multiply with 100. This is how we find the percentage error here. Let's check the question. This one. If the error in measuring the radius of a sphere, like this is the sphere, its radius is r, is 2%, okay? It says while we were measuring the radius of the sphere, error came out to be 2%. Means delta r divided by r into 100. This is called percentage error in radius. This is given as 2%. Okay. Now, if you are measuring the radius, you are getting error 2%. the error will be in the volume. How much will be the error in the volume? See guys, volume is equal to 4 divided by 3 pi r cube. 4 by 3 pi is constant, leave constant. So we say volume is proportional to r cube. Volume is proportional to r cube. Now, percentage error in volume, how do we write? Delta V divided by V into, we can say 100, or you say percentage error in volume will be equals to power down, 3 down, delta R divided by R into 100. This is how we write. So now this is 3 into delta R by R into 100 is 2%. So 3 into 2 is 6%. So if you are getting error in the radius 3%, in volume you will get the error of 6%. Now, one more question. This is a previous year question. This one. In an experiment, 4 quantities A, B, C, and D are measured with the percentage error 1%, 2%, 3%, and 4% respectively. Okay. And P is given as this. This is the relation. This is the relation. P is equal to, that is A cube, then B square, then we say CD. A cube, B square, then we say CD. Okay. Now, my dear friends, in this particular case, if I say delta P divided by P into 100 will be equals to, this is the percentage error in P. Now here, A cube, 3 down, delta A divided by A. This is the error in A. Then we say plus error of this, 2 down, delta B divided by B. And whatever is in the numerator, error of this will be also added. No doubt if it is in the numerator. So we say plus delta C divided by C plus delta D divided by D. Because error always adds up. We do not subtract the error. Okay. So in this case, this is 3 and multiply with 100 because you have to find this in percentage. Now tell me, is equal delta A by A into 100. Percentage error in A, that is 1%. So this is 3 into 1%. Okay. Then we say plus 2 into delta B by B into 100. Percentage error in B is 2%. Then we say plus delta C by C is, percentage error in C is 3%. Okay. Then we say delta D by D is, percentage error in D is 4%. Now tell me, this is 3%, 4%. 4 plus 3 is 7, 7 plus 3 is 9, 9 plus 4 is 13%. So it is 13. Okay. 3. 2 into 2 is 4. 4 plus 3 is 7. 14. Yo. 14%. Yeah. 7 plus 3 is 10. It's not 9. Okay. Yes, that's great. Okay. Now guys, let's move on to the next chapter, that is Kinematics 1D. That's Kinematics 1D. Okay. Rounding off is simple, bro. There are only 3 rules when it comes to the rounding off. Now guys, let's take a look exactly over here. Now guys, take a look. We have got kinematics. I would want you guys to focus exactly over here. I need to finish this chapter first, okay? Then we will take the break. Do you want to finish 9 chapters? Okay. So then don't ask for the break. If you have to finish 2-3 chapters, okay, I'll give you 5 to 6 breaks. Chill. We'll enjoy. But if you want to finish 9 chapters with complete detail, all the problems, then you have to stick to this particular session. I'll give you the break. Wait, guys, okay? I'll give you the break. When it comes to the kinematics, the first topic that we understand over here, distance and displacement. Okay? Let's suppose, my dear friends, you are living at point A, your friend is living at point B. When you are moving from point A to point B, listen to me very carefully. Let's suppose you are traveling with this distance. You are traveling with this through this path. This is the path that you are traveling through. Okay? Or sometimes you travel through this path. So while, my dear friends, traveling through this particular path, so can I ask you a simple question, sir? Is there any path which is the shortest path between A point and B point? You say, sir, yes, this is the shortest path. So this shortest path is what we call the displacement. Okay. And sir, this is called the distance, the actual path covered, Okay, and this is the shortest path. Sir, does this has a proper direction? No, here direction is this, here direction is this, here direction is this, here direction is this, but here direction is unique, one direction. So, distance is actual path covered, displacement is the shortest path covered. Okay. So, my dear friends, can I say when it comes to the distance, it has magnitude only, it does not have the direction, it's a scalar quantity. It is the total path length or the actual path covered. Okay, if I say, sir, you have traveled along this path, this is 10 meters and displacement is 5 meters only. So actual path covered is 10, displacement is 5. Displacement is 5. It is a scalar quantity, my dear friends. It cannot decrease with time. It cannot decrease. It will keep on increasing. It cannot be negative. Distance cannot be negative. Okay, when it comes to the displacement, it has got magnitude as well as direction. It is the shortest path between initial and final point. It is always a straight line. It is always a straight line. Join initial and final point. It is a vector quantity. It can decrease with time. It can be positive, negative as well as zero. Let me just give you the example. My dear friends, listen. If let's suppose you started from point A, okay, you traveled and you reached this point A once again. Okay, here you have covered this much is, this length is, let's suppose 120 meters. Tell me how much is the distance and how much is the displacement. In this case, we say distance covered is 120 meters. But when it comes to the displacement is 0. Why? Because initial and final point are same. You have returned to the same point, so that's why displacement is 0. Okay. Now, listen guys. Let's suppose this is the origin, 0, 0. This is the origin, 0, 0. And from this side, this is x is equal to +1, x is equal to +2, x is equal to +3, okay? And from this side, it is x is equal to -1, x is equal to -2, you say x is equal to -3, okay? And so on. Now, guys, listen to me very carefully. If I say you have traveled from this point to this point, how much is the displacement? This much is the displacement. Sir, we say x is equal to -2 is the displacement. Displacement can be negative also. If you have traveled from this point to this point, x is equal to +3. Displacement is +3. But when it comes to the distance you always take positive. Distance will be always positive. Here, displacement can be 0, negative as well as positive. 0, negative as well as positive. As simple as that. Even if you come back to the original position, displacement will decrease also. But if you come back to the original position, distance will become 3 plus 3, that is 6. Distance always increases. Okay, like here in this case, if you are traveling from this point to this point, then coming back to this point, what is the distance traveled? Distance will be 4 plus 3. 4 plus 3, that is 7 meters. And what is displacement? Displacement is this much only. That is 4 minus 3, that is 1. Displacement is 1 meter. Displacement is 1 meters. Okay. Okay. Yes. 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 Okay. So this is the distance, displacement. Okay. And one more important thing, guys. Let's suppose if an object moves from A point to B point along the straight line only, this is the actual path. In this particular case, we say displacement is equal to distance. Okay. Always remember, when it comes to the distance, it is either greater or equal to displacement. Distance can never be less than displacement. Distance can never be less than displacement. Keep that thing in your mind. If it is a straight line, distance and displacement is 0. And if it is not a straight line, if it changes the direction, in that case, we say distance is greater than this one. Here it is equal. Now, guys, let's talk about velocity. Let's talk about velocity. Or before velocity, let's talk about speed. Let's talk about speed. Let's talk about speed. Okay. Okay. Now, guys, listen to me very carefully. What does speed mean? Speed simply means how fast an object is moving. Simply how fast an object is moving. And there is one more quantity, that is what we call velocity. What is the difference between speed and velocity? What is the difference between speed and velocity? See, it is how fast an object is moving towards where? Towards where? Towards where means direction. Means. Guys. Let's suppose if I say, this is the car over here. This is the car over here. I am saying this car is moving with 20 meters per second. What does it mean? Every second it is covering 20 meters of distance. Okay, this is the speed. Okay, how fast the car is moving. Now, if I am saying this car is moving with 20 meters per second towards east. Now, here, speed with direction, that is velocity. Here I am talking about velocity. Here I am talking about speed. Now, let's suppose, guys, listen to me very carefully. If I say I have got a car over here. I have got a car over here. Okay, I have got a car over here. This car is moving with 20 meters per second. This car is also moving with 20 meters per second. This is moving towards right. This is moving towards left. Now, understand this very carefully. I am saying, sir, in this particular case, how fast this car is moving? 20 meters per second. How fast this car is moving? 20 meters per second. I say speed of A is equal to speed of B. Speed of A is equal to speed of B. Okay. But when it comes to velocity of A is not equal to velocity of B. Why? Because the direction of this velocity is towards right. Direction of this velocity is towards left. So when it comes to the velocity, you have to check the direction also. When it comes to the speed, you have to check the magnitude only. Okay. Now guys, if I write speed, we say speed is total distance traveled upon total time taken. Okay. And when it comes to the velocity, it is total displacement traveled upon total time taken. Here we take displacement, here we take distance. That is the difference, because distance is a scalar quantity. Now guys, Now guys, in this particular case, let me move over here. Let me move over here. Let me show you this one. Yeah, now you have got velocity. Now you have got velocity. See guys. It is how fast an object is moving and where. Okay, simply I have explained. Now we have instantaneous velocity. There are two types of velocities: instantaneous velocity and average velocity. Instantaneous velocity means if you are moving from A point to B point, what is the velocity at any particular instant? Okay, like you are from Delhi to Mumbai. What was the velocity at that toll post? That is the velocity at any particular instant. That's called instantaneous velocity. Now, if I say what is the velocity between A point to B point in general, that is the average velocity. Instantaneous velocity is simply dx by dt, differentiation of displacement with respect to time. And when it comes to the average velocity, it is total displacement traveled from A to B upon total time taken. Instantaneous velocity means velocity at any particular instant. Average means between this interval. What is the total? That's it. Total displacement traveled upon total time taken. Okay. Yes. One more important thing. What is that? If I say velocity, car is moving towards right, we consider its velocity as positive. If I say body is moving towards left, we consider its velocity as negative. Directly, remember. That's it. Let's suppose this is the question. Question on average velocity. A car is moving 2/5. A car is moving 2/5 of its total distance with V1. 2/5d it is moving with V1. Then it is moving 3/5d with V2. Okay. Find the average velocity. Find VAVG. Okay. Guys. Whenever they ask you to find the average speed, average velocity, there is one golden formula. Please do remember that. In every question, use that formula. That is, when I say average velocity or average speed, total displacement traveled upon total time taken. That's it. Nothing else. So I say total displacement traveled. How much is total displacement? 2/5d plus 3/5d. 2/5d plus 3/5d. Yes, upon total time taken. Guys, sir, here velocity is given, distance is given. How to find time? We say velocity is displacement upon time. Time will be displacement upon velocity. So here displacement 2d/5, velocity is v1. So I can write 2d divided by 5v1 plus 3d divided by 5v2. That's it. Done. Solve this, we are done. Now see. 2d, 2/5d plus 3/5d. This will come out to be d. Solve this will be d. And here. In this particular case, we can say this will be 2d by 5v1 plus 3d by 5v2. Now d will cancel. So this will be 1 upon 2/5v1 plus 3/5v2. Now you can solve it, simplify it from your end only. Okay, it is simple. So what is the basic formula? That is this. Now if from now onwards, sir, they are giving this much of distance, then this much of distance with v2, what is the formula? This formula use and get the answer. Use this formula and get the answer. Okay. Now guys, listen. I have told you, when it comes to the instantaneous velocity, what is that? That is ds divided by dt. Differentiation of displacement with respect to time. Means if displacement or position is given, you are supposed to find the velocity, you do the differentiation. Can you do this also? Take it over here. ds will be equals to v dt. Yes. Now integrate from both the sides. Integration of ds will be total displacement. So total displacement will be integration of v dt. Means if velocity is given, you are supposed to find displacement, you do integration. Yes. Now come here. If the position of an object is this, x is equal to t square minus 4t plus 5. X is equal to t square minus 4t plus 5. This is the position of an object. Then find the instant when velocity becomes 0 and position when it comes to rest. You have to tell me that time when object comes to rest, when its velocity becomes 0. Guys, position is given. First calculate velocity. Velocity is dx divided by dt. Okay. So that will be differentiation of this. 2 down. So 2t minus 4t is 4. Differentiation of 4t is 4. For 5 it is 0. Now guys, you have to tell me that time when velocity is 0. So put velocity is 0. So 2t minus 4 will be equals to 0. Take it over here. 2t will be equals to 4. 2 ones are 2 twos are. So t is equal to 2 seconds. Now see, at t is equal to 2 seconds, velocity is 0. Check, check. Sir, put t is equal to 2 over here. 2 into 2 is 4. 4 minus 4, velocity is 0. So at t is equal to 2 seconds, velocity is 0. Body comes to rest. Okay. Okay. So find instant when velocity becomes 0. So that is 2 seconds. Also find position when object comes to rest. Object comes to rest when time t is equal to 2 seconds. Now at t is equal to 2 seconds, let's find the position. X will be that is 2 square minus 4 into 2 plus 5. So x will be equals to, that is 2 square is 4 minus 4 into 2 is 8 plus I can say 5. Okay. Now 5 plus 4 is 9. 9 minus 8 is 1. So 1 meter. So position of the object is 1 meter. Is this clear? Is this clear? Please tell me in the chats. Is this clear? Guys, with the fire emojis, I want you guys to let me know in the chats if this is clear. And smash the like button. Smash it. Somebody was writing in the chats, how do you smash the like button? Okay. Smash it. Okay, do it as soon as possible. That's great. That's great. That's great. Okay. Now, guys, take a look. Take a look. X is equal to t square plus 4t plus 10. Find the time when object comes to rest. Again, bro. See, x is equal to t square plus 4t plus 10. You guys are supposed to tell me time when object comes to rest. We say velocity is simply dx divided by dt. First find velocity. So that is 2t plus we say 4. Now, you have to find the time when object comes to rest. Object comes to rest when velocity is 0. So put velocity equals to 0 is equal to 0. So 2t will be equals to minus 4. Minus 4. 2 ones are 2 twos are. So t will be equals to minus 2. 2 seconds. Tell me, is it possible that time can be negative? Is it possible that time can be negative? Time cannot be negative. Time cannot be negative. So what does that mean? So object never comes to rest. Comes to rest. So object will never come to rest. Never ever. Okay? Object will never come to rest. Let's move on to the acceleration. See guys, what is acceleration all about? Acceleration simply, let's suppose you are inside the car, okay? Now you are asking your friend, increase the speed. What does he do? So he'll basically accelerate the car. He'll increase the speed. He'll change the speed. So acceleration is simply changing the speed. Like here, this car is moving, its velocity is 0. Now it starts increasing its speed. Here velocity is 10. Here velocity is 18. Here velocity is 24. So here car is accelerating. Car is accelerating. How fast velocity is changing, that is called acceleration. Okay. How fast velocity is changing, that is called acceleration. And when I say acceleration, my dear friends, acceleration is simply change in velocity upon change in time. Change in velocity upon change in time. So that is delta V divided by delta T. Okay, let's suppose if you have to find the acceleration during this period. If you have to find the acceleration during this period, how will you find acceleration? Change in velocity. That is final velocity minus initial velocity. 10 minus 0 upon time is 1 minus 0, 1 minus 0. So this is 10. And acceleration's change in velocity, meter per second square. Because acceleration is velocity, change in velocity upon change in time. What is the unit for velocity? Meter per second. For time, it is second. So meter per second. Okay. Now guys, you have positive acceleration, negative acceleration. Listen. Positive acceleration means acceleration is positive. Tell me, here value of acceleration came out to be positive or negative? Sir, it is positive. So plus. So here acceleration is positive. Okay. Like negative acceleration means when acceleration is negative. Like. Let's suppose this is the car. It is moving with 20 meter per second. Here it is moving with 10 meter per second. It is decreasing the speed. Okay. What is the acceleration? Acceleration will be final minus initial. 10 minus 20 divided by 1. Let's suppose time is 1 second. So this will be minus 10 meter per second square. Your acceleration is negative. And acceleration is positive means acceleration is forward. Okay. It means acceleration is forward. Sir, does that mean? No. It is not retardation. Don't try it retardation. Wait. Acceleration is, see, acceleration is positive means acceleration is forward. Does that mean car is moving in the forward direction? It can be, it cannot be. Direction of motion is not decided by acceleration. Direction of motion is decided by velocity. Okay. Negative acceleration means acceleration is backward. Does that mean car is moving backward? No. See, here, acceleration is negative. Means here acceleration is backward. This is the direction of acceleration. But car is moving forward. Okay. It is simply direction of acceleration. Okay. This is direction of acceleration. Does it mean car is moving forward? No. Does it mean car is moving backward? No. Just the direction of acceleration. Change in velocity. Now, retardation. Lot of people have confusion, sir. Negative acceleration means retardation. Negative acceleration does not mean retardation. Negative acceleration also can be retardation. It cannot be. Even positive acceleration can also be retardation. Retardation means slowing down. Retardation means slowing down. See. Guys, take a look. Here, body is moving in the backward direction with 20 meter per second. Here, its speed is 10 meter per second. So its speed is decreasing from 20 to 10. Find the acceleration. Final velocity minus initial velocity upon time. Final velocity is 10. And if the body is moving in the left direction, we take its velocity as negative, minus 10. I'll give you the brake weight. And here, then final velocity minus 10 minus initial velocity. Initial velocity is minus 20. Now minus of minus 20 plus 20. So it will be plus 20 minus 10 plus 10 meter per second square. Now here, is the body slowing down? Yes. And is the acceleration positive? Yes. And this acceleration is called retardation and it is positive. Retardation can be positive also. Retardation can be negative also. Arey yaar. Negative acceleration means direction of change in velocity is negative. Why is it confusing, bro? See, I'll explain once again. Positive acceleration. Guys. Let's suppose you have got an object which is moving in a forward direction. Its velocity is 10 meter per second. Here its velocity is 20 meter per second. Time is 1 second. In this particular case, tell me, is velocity positive or negative? Sir, positive. Forward. What about acceleration? Acceleration is 20 minus 10 is 10. 10 meter per second square. And acceleration in this case is positive. Okay. Here, direction of velocity is also positive. Direction of acceleration is also positive. Okay, it is forward. And here car is also moving in the forward direction. Okay, yes. Sir, what about negative acceleration? See, negative acceleration, this car is moving with 20 meter per second. Here velocity of the car is 10 meter per second. Time is 1 second. Tell me, here velocity is positive. Means car is moving in the forward direction. Okay, velocity positive, car is moving in the forward direction. What about acceleration? Acceleration is 10 final minus initial. 10 minus 20 minus 10 meter per second square. Here acceleration is negative. Here acceleration is backward. So acceleration negative means direction of acceleration is negative. Direction. Does that mean car is moving in a backward direction? No. Car here is moving in a forward direction, but acceleration is backward. That's it. Now. Okay. Now take a look. So when it comes to the retardation means slowing down. Whenever the body slows down, it is retardation. It can be positive also, it can be negative also. That's it. Okay. Then you have got average acceleration. Now guys, if a body is moving from A to B, it is changing the velocity from A to B. In general, how much is the acceleration? That is total change in velocity upon total change in time. Delta V divided by delta T. As simple as that. And when it comes to, if a body is moving from A to B, if it is changing the velocity, how much is the acceleration at any particular instant? That is called instantaneous acceleration, dV by dt. Okay, how much is the change in velocity at this instant? Divided by change in time. Acceleration is dV by dt. That's this. That's it. Okay. Yes, one more important thing. Guys, see. If I say acceleration is dV divided by dt. Now take it over here. Can I say dV is equal to a dt? Yes. Now integrate both the sides. Integration of dV will give you the large change in velocity. That is delta V is equal to integration of a dt. Okay. Yes. So if acceleration is given and you do the integration, you will get what? Change in velocity. If velocity is given and you do the differentiation, you will get what? Acceleration. That's it. One more important relation. Guys, see, acceleration in terms of displacement. We say acceleration is equal to dV by dt. Multiply with ds, divide with ds. Now interchange the position. Take it over here, take it over here. Now see guys, dV by ds into ds by dt. What is ds by dt? This is velocity. Okay. So instead of this, I am writing velocity into dV by ds. This is acceleration in terms of displacement. Okay. Average acceleration is delta V by delta T. Instantaneous acceleration is dV by dt. Acceleration in terms of displacement is V dV by ds. That's it. Now this is very important. See guys, if you have displacement, if you want to find velocity, what will you do? Differentiation. V is equal to ds by dt. Now if velocity is given, you have to find displacement. What will you do? Integration of V dt. Already discussed. Reverse process. Now if you have velocity, you are supposed to find acceleration. What will you do? Differentiation. dV by dt. If acceleration is given, you are supposed to find change in velocity, not velocity, change in velocity. You do integration. That's it. Already we have discussed. This is very important. Okay. Yes, let's move on to this one. Object is moving such that its position changes as a function of time. This is the position of an object. Okay. It is given as x is equal to alpha t square plus beta t plus we say gamma. Okay. Okay. Then find the initial velocity, initial acceleration, and initial position. See guys. Initial velocity means velocity at t is equal to 0. Okay. Initial acceleration means acceleration at t is equal to 0. See, first find velocity. If x is given, so velocity is dx by dt. So that will be differentiation of this. So 2 down, 2 alpha t plus I can say beta. For beta is constant. Okay. Alpha, beta, and gamma are constants. Okay. Okay. For gamma, it is 0. Differentiation is 0. Okay. Now at t is equal to 0, we have to find the velocity. So velocity will be, put t is equal to 0, this will be 0, only beta. This is the initial velocity. Now guys, you have to find the acceleration. So acceleration is going to be, that is dv divided by dt. Now what is velocity? 2 alpha t plus beta. So what is the differentiation of 2 alpha t? That is 2 alpha only. Okay. For beta it is 0. So it is constant. 2 alpha is, well, acceleration is constant. So whatever is the value initially, that will be finally. Okay. What is the position at t is equal to 0? Let's find the position. X will be equals to, put t is equal to 0, this term will be 0. Put t is equal to 0, this term will be 0, only gamma. This is the initial. This is the initial velocity. This is the initial position. This is the acceleration. Okay, this is the acceleration. Okay, if the velocity of an object is v is equal to 3t square, velocity is given as 3t square. Then find the displacement in 2 seconds. See guys, velocity is given. Take a look. Velocity is given. You have to find the displacement. What will you do? Integration. Simple. You say S is equal to integration of v dt. Okay. Now I can write over here S is equal to integration of. Now in 2 seconds means from 0 to 2 seconds. Velocity is 3t square into dt. Now S will be equals, take this 3 out. Now integration of t square. It is t cube divided by 3. It is from 0 to 2. This and this will cancel. Now displacement in this case will be, put the upper limit over here, t cube, 2 cube, that is 8. 8 minus 0, that is 8 meters. That is 8 meters. Okay, what about this one? A particle is moving along a straight line such that its displacement at any time is given by this. Its displacement is given as S is equal to t cube minus 6t square plus 3t plus 4. The velocity when its acceleration is 0. Okay. You have to find its velocity when its acceleration is 0. You have to find its velocity when its acceleration is 0. Guys, velocity is equal to simply, that is ds divided by dt. First find velocity, that is differentiation of this. 3t square minus 2 6 are, that is 12t. Then we say plus we say 3. Okay, for this it is 0. This is velocity. Now find acceleration. Acceleration is differentiation of velocity, dv by dt. Now for this 3 2s are, this is going to be 60 minus this is 12. For this it is 0. Now it says the velocity when acceleration is 0. So put acceleration is equal to 0, put a is equal to 0, means that is 60 minus 12 will be equals to 0. So 6t is equal to 12. 6 1s are, 6 2s are. So t will be equals to 2 seconds. So when t is equal to 2 seconds, its acceleration is what? 0. Put t is equal to 6 2s are 12, 12 minus 12 is 0. So at t is equal to 0, acceleration is 0. It says find velocity when acceleration is 0. When is the acceleration 0? When t is equal to 2 seconds. When t is equal to 2 seconds. Now we will find the velocity at t is equal to 2 seconds only. Now velocity at t is equal to 2 seconds only. So velocity is going to be, that is, here this is the velocity. Put t is equal to 2, 3 into 2 square minus 12 into 2 plus we say 3. So velocity is going to be 3 into 2 square is 4, 3 4s are 12 minus 24 plus 3. Okay. Okay. Is this clear? Minus 9, 15, minus 9, 39. Huh? Is this clear? Tell me, guys. Is this crystalline clear? And if velocity is negative, means velocity is in the backward direction. As simple as that. Everybody of you, let me know in the chats if this is crystalline clear. If this is crystalline clear. Okay. If this is crystalline clear to each and every single student. That's great. That's great. That's great. Okay. So how much is the velocity over here? 12 plus 3 is 15. 24 minus 15. Minus 24 plus 15. Minus 9. Minus 9. What does negative sign means? Body is moving in a backward direction. Okay. Yes. Equations of motion. See, guys. Equations of motion. Let's suppose you have a car over here. At t is equal to 0, the car is present exactly at this point. Okay. At t is equal to 0, the car is exactly at this point. Okay. Now, guys, its initial velocity is u. And acceleration in this case is constant. This is very much mandatory. Now, let's suppose it is moving. After some time, its velocity becomes v. Initially, it started with velocity u. Acceleration is constant a. After some time, its velocity became v. What is the value of this v? After time t, how much is the velocity of the body? We say v is equal to u plus at. There is a derivation for this. We'll skip that. V is equal to u plus at. And this is used only when acceleration is constant. Sir, if acceleration is not constant, what is the equation I can use in order to find the velocity? V is equal to ds by dt. Delta V is equal to integration of a dt. Always valid. If acceleration is constant, if acceleration is not constant, every time you can use this in order to find. Okay. Every time. But this is used only when acceleration is constant. Okay. Now, if I say the same car moves from this point to this point, initial velocity is u, acceleration is constant. After time t, how much is the displacement it has covered? Displacement will be s is equal to ut plus 1 by 2 at square. U is initial velocity, t is time. 1 by 2. A is acceleration, t is time. This is the displacement covered after time t. Displacement covered in time t. Please explain this sum. Which sum? Which sum are you saying? Next. Okay. Now guys, let's suppose if here body starts from this point, initial velocity is u. Okay. Initial velocity is u. Now, after covering displacement s, what is the final velocity of the body? how much is the velocity of the body after covering displacement s, after traveling displacement s. Sir, what was this? This is how much is the velocity of the body after time t. And what is this? How much is the velocity of the body after covering displacement s? So that will be v square minus u square is equal to s. You can write v square is equal to u square plus 2as, like this also. This is velocity after displacement s. Okay, one more equation. What is that? That is, take a look. We say displacement in nth second. Let's suppose a body is covering, let's suppose from here to here. After 1 second's body is here. After t is equal to 2 seconds, body is here. After t is equal to 3 seconds, body is here. After t is equal to 4, body is here. After t is equal to 5, body is here. We said this is the displacement in first second. This is the displacement in second second. This is the displacement in third second. This is the displacement in fourth second. This is the displacement in fifth second. Similarly, if this is nth second, okay, displacement in nth second. So that is displacement in nth second. Okay, this is the displacement in fourth second. That will be displacement in nth second is u. U is the initial velocity. A by 2. A is the acceleration constant. 2n minus 1. If you have to find the displacement in fourth second, you put n is equal to 4. If you have to find the displacement in third second, you put n is equal to 3. Okay, so this will give you the displacement in that particular second. And what is this? This will give you the total displacement in the entire journey. Okay. Okay. Write down in the Google. Why cannot you find my Telegram channel? Write down in the Google this one. t.me/YAWAR MAN, it should be small, MANZOOR. In the Google, directly search this link and it will land onto my Telegram channel. Now guys, see, ratio of displacements. Take a look. A ratio of displacement. Very important. Ratio of total displacements in 1 second, 2 seconds, 3 seconds. Okay. Like let's suppose there is a car. It started from this position. And if it is starting from this position, if it starts from this position, initial velocity is 0. We say acceleration is constant. Initial velocity is 0 and acceleration is constant. Okay. We say after t is equal to 1 second, the car is here. After t is equal to 2 seconds, the car is here. After t is equal to 3 seconds, car is here. After t is equal to 4 seconds, car is here. Now guys, if I say how much is the displacement covered in 1 second? Okay, that will be this. Okay. And how much this? Let's suppose it is x. How can you find it? Guys, you can find it. S is equal to ut. Initial velocity is 0 ut plus 1 by 2 at square. So S will be equals to, this is 0, initial velocity is 0. 1 by 2 at square. T is 1 second, in 1 second. So that will be a into 1 square. So this will be a divided by 2. So put this a by 2 as x. So this is x. Okay. Now if I say, what is the displacement covered in 2 seconds? You will say, sir, displacement covered in 2 seconds is 1 by 2 at square, because u into t, initial velocity is 0. S is equal to 1 by 2. That is a. What is the value of t? T is 2 square. 2 square becomes 4. Now a by 2 is x. So this will be 4x. That's what I'm saying, 4x. Similarly, you can find the displacement covered in 3 seconds. That will be 9x. Now, I want you to directly remember this particular ratio. If a body starts from rest, acceleration is constant. Displacement covered in 1 second is x. Displacement covered in 2 seconds will be 4x. Displacement covered in 3 seconds will be 9x. In 4 seconds, 16x. In 5 seconds, 25x. So, this is displacement in 1 seconds is to displacement in 2 seconds is to displacement in 3 seconds is to displacement in 4 seconds will be x is to 4 is to 9 is to 16x. So 1 is to, this will be the ratio. This will be the ratio. This will be the ratio. Now, next. See. Difference. Ratio of displacements in first second, second, third second, fourth second. See, if the body starts from this point, it is moving. Okay. I say, sir, after t is equal to 1 second, this is the displacement. In 2 seconds, this much is the displacement. In 3 seconds, this much is the displacement. In 4 seconds, this much is the total displacement. What if somebody asks you, what is the displacement in first second? That is this much only. What is the displacement in second? That is this much only. What is the displacement in third second? That is this much only. What is the displacement in fourth second? That is this much only. Yes. How can you find this ratio? Displacement in first second, second, third second, fourth second. See guys. If you see. If this is x, okay, now you have to find this displacement. Now from here to here, how much is this displacement? 4x, already calculated. So 4x minus x, this will be equal to how much? 3x. Now, displacement in third second. See, how much is the displacement in 3 seconds? That is 9x. Total is 9. And how much is the displacement in 2 seconds? That is 4. 9x minus 4x, that will be 5x. So this displacement is. Now if I say, sir, displacement in this fourth second, we'll say how much is the total displacement in 4 seconds? That is 16x. And how much is the displacement in 3 seconds? That is 9x. 16 minus 9, that is 7. So this will be 7x. So I can write displacement in first second is to displacement in second is to displacement in third second is to displacement in fourth second. It will be x is to 3x is to 5x is to 9x. Please don't get confused. Here, this is the ratio of displacement in first, second, third, fourth, fifth, sixth in a particular second. And when it comes to this is the ratio of displacement in 1 second, 2 seconds, 3 seconds, complete 3 seconds, complete 4 seconds. How many of you understood this? Please let me know in the chats with the fire emojis. Very important. Now you see, questions will be solved in a fraction of seconds. Okay, and all previous year questions. Okay, this is a previous year question. This is a previous year question. Okay. Sir, how long you have been working out? Your arms are impressive. Really? You think so? It's been almost 8 months, huh? Last year, when I was taking this marathon, okay, I was very fat. I was approximately 107 kgs. And right now I am 79 only, okay? I dropped my fat percentage from, I would say 23% to, and right now it's around 10, 11, yeah. I dropped 25 kgs in 5 months. Extreme crash dieting. That's what I did. Yeah. Extreme level transformation. That's what you can say. Okay. Maybe you can take the motivation from this to push your NEET so that you enter the medical college in the upcoming time. Okay. Yo, yo. Okay. Peak motivation in a second. Yeah. Did you guys smash the like button? Okay. And did you see that warning video which I posted in the Telegram channel? This is the last warning that I'm giving you. Final warning. Yo. So let's move. Let's solve this particular question. We have got this question over here. Okay. Lot of questions have been asked from this particular topic. Okay, let me see more if I have over here. Now, guys, take a look. I want you guys to understand this particular topic over here. I want you guys to understand this particular question. See, a particle starts from rest. A particle starts its motion from rest. Initial velocity is 0. Under the action of constant force. Force is constant, acceleration is constant. Because F is equal to mass into acceleration. If the distance covered in the first 10 seconds, okay? If the distance covered in the first 10 seconds, is S1, and that covered in the first 20 seconds, okay? Here, time is 0. Here it is 10 seconds. Here it is 20 seconds, okay? It is 20 seconds, okay? And this distance is S1 and this distance is given as S2, okay? Then which of the following relation is correct? Now tell me, guys, which ratio I'm supposed to use. This is the complete distance in S1, okay? Then complete distance, it is not talking about in this interval, distance covered in this interval or distance covered in this interval. It is saying the distance covered from here to here, distance covered from here to here. So I can say, guys, distance covered in we say S1 is to S2. It will be X is to 4X. Please use this ratio. Complete distance. When it is asking for the complete distance, here it is giving the interval of 10 seconds. Doesn't matter. Your interval is 1 second, 2 seconds. It can give you 10 seconds, 20 seconds. It can give you 100 seconds, 200 seconds. Doesn't matter. So you can say in this particular case, S1 divided by S2 is equal to X divided by 4X. X and X will cancel. So S2 will be equals to 4 times of S1. So which option? 4 option. And once in NEET 2017, question was asked something like this. NEET 2017. A body starts from rest with a constant acceleration, okay? A body starts from rest with a constant acceleration. A body starts from rest with a constant acceleration, okay? Then you guys are supposed to say S1 is equal to S2 divided by 3 is equal to S3 divided by 7. S1 is equal to S2 by 4 is equal to S3 by 5. S1 is equal to S2 divided by 3 is equal to S3 divided by 5. None. Now see, a body starts from rest with constant acceleration. Okay? It covers the distance, first half of the distance. It covers first half of the distance with S1. Okay? Okay? And then it covers the distance like distance covered in the first second in 1 second is S1. Then distance covered in the 2 seconds is S2. Then distance covered in 3 seconds is basically S3. This was the distance. You guys are supposed to check which of the ratios is correct. Okay? Now tell me, which ratio I am supposed to use? Distance covered in 1 second. Distance covered in 2 seconds. Distance covered in this. Okay? Okay? See guys, in this particular case, or initial velocity is 0, acceleration is constant. See. Distance covered in first second. Sorry, question was like this. Distance covered in first second was S1, in second S2, in third second S3, and in fourth second S4. Now you have to check which ratio is correct. Distance covered in first second S1, in second S2, in third second S3, in fourth second S4. Which option? See guys, you say S1 is to S2 is to S3 is to S4 is going to be X is to 4X is to, sorry, X is to 3X is to 5X is to 7X. Okay, because when it comes to the distance covered in particular second, first second, second second, third second, fourth second. Now if I say S1 divided by S2, if I write this divided by this, you'll say, sir, X divided by 3X. Okay, this and this will cancel. So can I say S1 will come out to be S2 divided by 3? Call this as first equation. Then can I say, sir, S1 by S3, S1 divided by S3 in this case will be X divided by 5X. Yes, this and this cancel. So S1 comes out to be S3 divided by 5. Call this as equation second. Now from this here, S1 is equal to S2 by 3. S1 is equal to S3 by 5. So can I say from first and second, we say S1 is equal to S2 divided by 3 will be equals to S3 divided by 5. This was the question as NEET 2017. Option 3. Okay, let's talk about this. What about this question? What about this question? Tell me. What about this question? What will be the ratio of distance moved by a freely falling body from rest in 4th and 5th second? See guys, if you release an object from certain height, we say its initial velocity is 0. Releasing an object means initial velocity is 0. And acceleration is g, which is constant. So means we can use that ratio. If it falls, like after 1 second it is here, after 2 seconds it is here, after 3 seconds it is here, okay, after 4 seconds it is here. Can you guys tell me in this particular case, guys, this distance will be first second X, in the second 3X, in the third second we say 5X, in the fourth second it will be 7X, and this is X, distance covered in 1 second, distance covered in 2 seconds is 4X, distance covered in 3 seconds is 9X, distance covered in 4 seconds is 16X. Can we use the same ratio? Yes. And sometimes you'll see this is height H1, okay, height covered in the first second, height covered in the second, height covered in the third second, height covered in the fourth second. Or you can say, okay, height covered in 1 second, height covered in 2 seconds, height covered in 3 seconds, height covered in 4 seconds. Exact same ratio. Exact same ratio. Now, what does it say? Moved by a freely falling body in the 4th and 5th second, okay? And in the 5th second, 16, in 4th and 5th second, that is 7:9. S4 divided by S5. In the 4th second, guys, first second, second second, third second, fourth second. And in the 5th second, so it is 7X divided by 9X. This and this will cancel, divided by 9. It is saying fourth means particular second. Okay, just a second, guys, just a second. Okay, okay. Now, done. Okay, what about this one? What about this one? A body starts from rest. Initial velocity is 0. Okay. What is the distance traveled by the, what is the ratio of distance traveled by the body during the 4th and 3rd second? Again, 4th and 3rd. Guys, S4 divided by S3. 4th second. X is to 3x is to 7x. 7x. Third. In the 4th second. 4th second. X is to 3x is to 5x is to 7x. Yeah. 7x divided by 5x. 7 is to 5. All of these are previous year questions. 7 is to 5. Stopping distance. Okay. Stopping distance. Let's take the break after 3 hours, okay? We started the class at 7:10. We'll be taking the break at 10:10 or 10:05. 10:05 I'll give you the break. Okay? So we have 10 minutes left. Then I'll give you the break. Okay. Okay, I'll give you the break. Now guys, take a look. I'll give you the long break, okay? Chill, like 35 minutes, 35 minutes. Stopping distance. Stopping distance. I want you to understand one thing. Let's suppose if a car is moving with some initial velocity u, okay? A car is moving with some initial velocity u. And you applied the brakes. What happens? Will the car stop instantly or after covering some distance? Obviously, after covering some distance. That distance is called stopping distance. And if I say, sir, how do you calculate the stopping distance? It is simply u square divided by 2a. Sir, how do you calculate? B square minus u square is equal to as. Okay. U square by 2a. U is the velocity with which it is moving. 2 into a, acceleration is constant. And in this case, we say acceleration is constant. So if this is constant, so s is proportional to u square. So if a car is moving with some velocity, if you apply brakes, it will stop after covering some distance. It will stop after covering some distance. Okay? Yes. And that distance is called stopping distance. So we say s is proportional to u square. S is proportional to u square. Now guys, what I want you to understand in this one is a car moving with a speed of 50 meter per second. Okay? There is a car which is moving with a speed of 50 meter per second. This car is moving with a speed of 50 meter per second. Okay, applies brakes, stops after 40 meters. So stops after 40 meters. This is the stopping distance. If the same car moves with a speed of 100 meter per second, if the same car moves with a speed of 100 meter per second, okay, and it will stop after the stopping distance of s dash. Now tell me guys, in this case, can I say s is proportional to u square? Yes. In the first case, I say S1 divided by, in the second case, S2 will be equals to velocity U1. In the first case, velocity U1 divided by U2 whole square. Okay, because S is proportional to U square. Velocity here divided by velocity here. Now, what is the stopping distance in the first case? That is 40 divided by S2 is equal to U1. U1 is given as 50. U2 is given as 100 and it is whole square. This and this will cancel. 5 ones are 5, 2s are 10. 1 divided by 2, that is 1 by 4. Okay. So now 1 by 4. 4 into 4 is 160. So S2 will come out to be 160. So basically, if the same car moves with a speed of, no, why are you saying 80? If the same car moves with a speed of 100 meter per second, it will stop after the distance of 180 because it is U1 divided by U2, guys. 50 divided by 100 whole square. 50 ones are 50, 2s are 1 divided by 2 whole square, that is 1 by 4. 4 into 4 into 40, that is 160. S2 will come out to be 160, not 80. Okay. Yes. Okay. Yo. Now you have got motion under gravity. Motion under gravity. See guys, when it comes to the motion under gravity, let's suppose you have got an object over here, this mass m. Is there any force which is acting on this object in the downward direction? Yes, sir, in the downward direction, that is mg. Now, we say whenever the force acts on anybody, we say acceleration will come. F is equal to mass into acceleration. Acceleration will be force divided by mass. Force is acting, that is mg. Mass is m. M and m will cancel. So A will come out to be g. So this is called acceleration due to gravity. A is equal to g, that is acceleration due to gravity. Okay. And we say this g is equal to 9.8 meter per second square. Okay. So a body which falls under gravity, what is the value of that acceleration due to gravity? That is 9.8 meter per second square. Usually we take it 10. Now guys, either you call it motion under gravity or we say vertical motion. It's one and the same thing. Okay. Yes. Now, let's suppose if you have an object, if you are releasing this object, means initial velocity is 0. If you are throwing this object, then initial velocity is not 0. So if you are releasing this object, initial velocity is 0. We say it will fall, acceleration with the acceleration due to gravity. How much time it is going to take from here to here in falling? That is called time of flight. Time it is taking in falling down, reaching ground. This time of flight is under root of 2h divided by g, where h is the height, g is the acceleration due to gravity. Okay. Now, if I say, sir, if you are releasing this object, it will fall and strike the ground. With what velocity it will strike the ground? That is called a velocity of hit. So you will say this velocity of hit is under root of 2h by g. G is the acceleration due to gravity, h is the height. So only two things you learn over here. What is the time in which it will reach the ground? What is the velocity it will strike, with which it will strike the ground? Okay. Okay. Yes. And when it comes to the motion under gravity, what is the important case from which you can expect the question? That is this, because many times questions have been asked that I have shown you over here from this ratio. Any of the question, if they ask you from this ratio, you would be able to solve it. That is for sure. And rest, I will show you some questions. Rest, if they ask you to find the time of flight, they give you height. Okay. Find the time of flight. You can find, that is simple. Okay. This also. Now it has got one more case. That is ground to ground case. That is ground to ground case. If you throw an object, something like this, in the upward direction, it will go till the top. Okay. And at the topmost point, its velocity becomes 0. Then only it will start falling down. So then it falls down. Okay. Now here we define, if you throw a body with the velocity u in the upward direction, how high it can go, that is called the maximum height attained by the object. How high it can go, that is called the maximum height attained by the object. Okay. And this maximum height is, always remember, it is u square by 2g. Use the velocity with which you are throwing it. Okay. Okay. And if I say time of flight, sir, if you are throwing an object in air, it will go in the upward direction, it takes the time t1. Then it falls down, it will take the time t2. What is the total time? Total time is t1 plus t2. That total time is going to be 2u divided by g. So if you throw an object in the upward direction, how high it can go? Maximum height, that is this. How much time it can take this in the entire journey? That is this 2u divided by g. Okay, 2u divided by g. Okay. So guys, it is 10 o'clock. Let's take a break. Dinner break. You said till 10:40. This is a long break. After this, we'll take the short breaks. Please get done with your dinner. Okay. Then we'll continue. You want me to flex my arms? Here it is. Okay, guys, we are back. Let everybody join and come back. We'll start. Okay, let's start. Let's start. Now, guys, let's take a look. Let's take a look. In this particular case, let's now understand position time graph. What does position time graph actually mean? See, let's suppose this is a car over here. This car started from this point. After t is equal to 1 second, car reaches here at x is equal to 1 meters. At t is equal to 2 seconds, car is at x is equal to 2 meters. After t is equal to 3 seconds, car is at x is equal to 3. After t is equal to 4, car is at x is equal to 4 meters. Okay. Now, this is the real life situation. I want you guys to plot this situation graphically. So, we will make its position time graph. We will make its position time graph. See, guys, on this axis, we'll write x position. On this, it is time. When time is 1, position is 1. So, when time is 1, position is 1. When time is 2, position is 2. When time is 3, position is 3. So, it will be the straight line. So, this is the position time graph of this particular situation. Simply, position versus time. This position time graph gives us the idea that how the car is exactly moving with respect to the time. Now, let's suppose if I say slope. Slope is always perpendicular divided by base. Slope means tan theta. Let's find the slope of this position time graph. That is tan theta. Tan theta means perpendicular by base. Perpendicular is x, base is t. So that means either you write delta x by delta t, x by t, whatever you say. Now, what is delta x by delta t? That is velocity. So slope of xt graph gives us velocity. Slope of position time graph gives us velocity. So from now onwards, if somebody says that find the velocity from position time graph, you'll find what? You'll find velocity. Like there is a question over here. There is a question over here. You have got position time graph of two objects. This is object A. This is the graph. This is the object 2B. Okay. Now, guys, listen to me very carefully. It says, find the ratio of displacement of the particle. Which particle has covered the more displacement? See, initial position of the two particles is here. Both initially are at origin, 0. Now, when it comes to the object A, it has covered this much. Let's suppose it is here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 meters. Okay. And when it comes to this particle, it has also covered 10 meters. So I can say, guys, displacement is final position minus initial position. Remember this also. Okay. Now, final position of this object is also same as final position of this object. So can I say in this particular case, displacement of A is equal to displacement of B? Means both have covered the same displacement. Don't say, sir, B has covered more displacement. No. Displacement means final minus initial. But when it comes to the velocity, guys, when it comes to the velocity of object A is greater than velocity of object B. Why is it like that? Because when it comes to the object A, it is making more angle theta 1. Theta 1 is greater than theta 2. So if I say slope of this is greater than slope of this, see guys, clearly slope of this, because it is more steeper, because I can say slope of A is greater than I can say slope of B. That is the reason I'm saying velocity of A is greater than velocity of B. Velocity of A is greater than velocity of B. Why? Because slope of A is greater than slope of B. As simple as that. Why? Because slope is tan theta. Tan theta means theta. theta 1 is greater than theta 2. More is the slope, more will be the velocity. More is the slope, more is going to be the velocity. Okay, more is the slope, more is going to be the velocity, but displacement is equal. Now guys, which of the following graph represents the uniform motion? Uniform motion means velocity is constant. Now see guys, displacement versus time, here. If you check slope at this point, slope at this point, slope at this point, we say slope here is constant. So from displacement position time graph, if you have to find the velocity, you find slope. So if slope is constant means velocity is constant. So in this particular case, we say in case of straight line, velocity is constant. Here, see slope is changing. Here slope is more, less. Here slope is 0. So we can say here velocity is not constant. In this case, see, from here to here velocity is constant, but then it is decreased here. Then you can see over here slope is negative. See here, in this particular case, guys, here theta is less than 90 degrees. When theta is less than 90 degree, in that particular case, always remember slope is negative. Okay, sorry, slope is positive. Okay, so means if slope is positive means velocity in this case is positive from here to here. And in this case, we say slope is negative. So we say in this case, velocity is negative. So means velocity is changing its direction. So this is not the option. And here, we say displacement is constant. So velocity of the body is 0. Velocity of the body is 0. So option A is the correct option. Okay, let's suppose if you get a question something like this. You have position time graph. Okay, the average speed of the particle. What is average speed? That is total distance traveled upon total time taken. Guys, from 0 to 8 seconds. If this is the position time graph. So from 0 to 8 seconds, particle has covered. See, this is the graph. So when it comes to 0 to 6 seconds, particle has covered 20 meters. Then particle has returned to its original position. So total distance, how much is the total distance? Guys, 0 to 20 meters. While coming back, again 20. So that is 20 plus 20, that is 40. Total time is 8. So that is 40 divided by 8, that is 5 meter per second. 5 meter per second. And if somebody asks you what is the average velocity? If somebody asks you what is the average velocity is total displacement traveled. Guys, see. Body is moving, it is covering, sir, 20 meters. So in 6 seconds, it is covering 20 meters. Then in the next 6 to 8 seconds, it is coming back again 0. So total displacement is 0 and divided by 8, it will be 0 meter per second. So average velocity is 0, but average speed is 8 meter per second, that you can see from the graph. I hope this is crystalline clear, this graph. Velocity time graph. Let's talk about velocity time graph. See guys, let's suppose if this car started from this point. At t is equal to 0, its velocity is 0. After t is equal to 1 second, its velocity is 1. After t is equal to 2, velocity is 2. After t is equal to 3, velocity is 3. Plot this situation graphically. Make its velocity time graph. This is VT graph. Now guys, see. Its velocity time graph will be the straight line. This is velocity versus time. Now if you find the slope of this velocity time graph, slope is tan theta. That will be perpendicular by base. That is delta V by delta t. Now delta V by delta t is actually acceleration. So can I say slope of velocity time graph gives us acceleration? Slope of velocity time graph gives us acceleration. Yes. Slope of velocity time graph gives us acceleration. Now one more important thing. Area under velocity time graph. See. So if from now onwards velocity versus time graph is given, they ask you to find the acceleration, what will you find? Slope. If velocity versus time graph is given, okay, this is the graph. If somebody wants to find out this area, guys, always remember, if let's suppose you have y versus x graph, okay, and if they ask you to find this area, always remember this area is integration of whatever is on this axis y multiplied by dx. And here in case of this, area will be integration of whatever is on this axis, that is v, multiplied by this dt. Now what is integration of v dt? If you remember, it is displacement. So means area under velocity time graph gives us displacement. From now onwards, if somebody says that find the displacement from velocity time graph, what will you find? Area. What will you find? That is area. Okay. Like first one, take a look at this. In which graph acceleration is constant? Guys, acceleration will be, when it comes to the velocity time graph, slope means acceleration. You have to check here. This is theta. Here also it is theta. Here also it is theta. Theta is same at every point. So we say slope is constant, acceleration is constant. In this particular case, it is constant. Okay, it is constant. Acceleration is constant. Slope is constant, acceleration is constant. Why? Because theta is same. Theta is same. Okay. Now guys, here. We say here, this is slope. Here, this is slope. Here, this is slope. We say here acceleration is not constant. Why? Because slope is changing, slope is increasing. In this case, we say here, slope is decreasing. At the topmost point, we say acceleration is not constant, it is 0. So we say here acceleration is not constant. Why? Because we say slope is not constant. Slope is only constant when it is a straight line. And here, velocity of the body is constant. Here, velocity is constant. In this case, we say acceleration is 0. Acceleration is 0. And here, you guys can say slope is increasing. Slope is increasing. In this case, slope is decreasing because at the topmost point, slope is 0. It is parallel to x-axis. We say here slope is decreasing, means here acceleration is decreasing. Here acceleration is increasing. Okay. Slope increasing, acceleration increasing. What about this one? Find the displacement covered from 0 to 2 seconds. Okay, find the average velocity. This is velocity time graph. If you have to find the displacement from velocity time graph, you will have to find the area. You will have to find the area. Okay. Now, area will give the displacement from 0 to 2 seconds. From 0 to 2 seconds. That will be area of this triangle. 1 by 2. Base is how much? That is 2. Altitude is how much? That is 4. This and this will cancel. So displacement is 4 meters because area came out to be 4. Find the average acceleration from 0 to 2 seconds. 0 to 2 seconds average acceleration. Average acceleration. That is delta V divided by delta T, or we say slope. Sir, at T is equal to 0, what is the velocity? 0. At T is equal to 2 seconds, what is the velocity? 4. So you say 4 minus 0 upon time is 2 minus 0. So that will come out to be 2 meter per second square is the average acceleration. As simple as that. Let's talk about this one. Let's talk about this one. See, acceleration time graph. Let's suppose this is the car over here. This car is moving with an acceleration 0 meter per second square. At T is equal to 0, we say acceleration is 0. At T is equal to 1 second, acceleration is 1 meter per second square. After T is equal to 2 seconds, its acceleration is 2. After T is equal to 3, its acceleration is 3. Now here, I want you guys to plot this situation graphically. Its acceleration versus time graph will be the straight line. Okay. Now, we do not discuss the slope in case of AT graph, but we discuss area under acceleration time graph. How much is this area under acceleration time graph? Guys. We say if we have to find the area will be integration of A dt. Integration of A dt. Now, what is integration of A dt, guys? We know integration of A dt is delta V, change in velocity, because we have studied this. So, my dear friends, in this particular case, area under acceleration versus time graph gives us change in velocity, Okay, gives us change in velocity. Now. If I say, in which graph acceleration is constant? See. Here. Velocity is proportional to time. In this is velocity versus time, guys. Velocity versus time. In case of velocity versus time, you check the slope. We say here, slope is constant. If slope is constant, means in this case, acceleration is constant. Slope is constant means acceleration is constant. In this case, we say x is proportional to t square. Let's find velocity. Velocity is dx divided by dt. That is differentiation of this. Guys, equation, this is x versus t. Equation of this upward parabola is always x is proportional to t square. Now, if we find velocity, that is 2t. Now, if we find acceleration, that is going to be, that is dv divided by dt. That is going to, what is the differentiation of 2t? That is 2. So, is 2 constant? Yes. So, in this case also, acceleration is constant. Yes. Acceleration is constant. What about this one? This is AT graph. Here, it is a straight line. It is a constant graph. So, in this case, acceleration is constant. We say in all the three cases, acceleration is constant. In all the three cases, acceleration is constant. Okay. I hope acceleration time graph is also clear. Okay. Yes. Now, let's move on to the projectile and relative motion. First and the foremost thing, what is a projectile motion, my dear friends? See, let's suppose you are kicking a football. Okay, this football follows this particular path. This is what we call the projectile motion. Okay, you are throwing an object in air. It follows this path, okay, path of a projectile. That is called the projectile motion. Okay, that is called the projectile motion. Now, when it comes to the projectile motion, first case that we see, ground to ground projectile. Okay, like you are launching a projectile from the ground, it falls onto the ground. You are throwing an object from the ground, it falls onto the ground. Now, see guys, listen to me very carefully. Okay, listen to me very carefully. Let's suppose you are throwing an object with a velocity u at an angle theta initially. Okay. Now, this u will be having two components. Always remember. Okay, always remember. Whenever we have a vector, always remember, if this is a vector A, okay. Wherever vectors are involved, I'll explain that. If this is a vector A, we say if this is the angle theta, we know, sir, this vector will have two components. This is A cos of theta and this is going to be A sine of theta. A cos of theta and A sine of theta. Vector has two components, A cos theta, A sine theta. Now, this ux, this is going to be U cos theta and this is uy is going to be U sine theta. Yes. Now, listen to me very carefully. It goes. When it reaches the topmost point, always remember, at the topmost point, vertical velocity of the projectile is 0. But when it comes to the horizontal velocity ux always remains same. It is U cos theta. Whatever was the horizontal velocity initially, at the topmost point, it will remain the same. Even at this point also, it will be U cos theta only, horizontal velocity. Okay. See, we have divided this projectile motion in two parts. That is horizontal motion and vertical motion. Why is it like that? Because when you talk about the projectile motion, see guys, when the body is moving something like this, it is going forward as well as it is going upward. It is moving forward as well as it is going upward. This is called two-dimensional motion. Body is moving forward as well as body is moving upward. Two-dimensional motion. Okay. Yes. Now, that's the reason we divide it in horizontal motion and vertical motion. Guys, see. Initially, velocity in x direction is U cos theta. This is U. Horizontal velocity is U cos theta. Vertical velocity is U sine theta. Horizontal is U cos theta. Vertical is U sine theta. Is there any force acting in x direction? No. Force in x direction is 0. So acceleration in x direction is 0. Is there any force acting in y direction? Yes. When the object is here, what is the force in y direction? That is mg. That is gravity, mg. So acceleration will be g, acceleration due to gravity. Already we have discussed. Okay. Now, velocity in x direction. Guys, if you can use v is equal to u plus a into t. Velocity v is equal to velocity in x direction initially, u cos theta. Acceleration in x direction, that is 0. So this term will become 0. So v is equal to u cos theta. V is equal to u cos theta. So that's the reason I told you x direction velocity will remain constant throughout. It will remain the same. Okay. And when it comes to the velocity at any particular point, you say, sir, v is equal to u plus a into t. Vertical velocity, initial velocity in y direction, that is u sine theta. Acceleration in y direction, we take that minus g. Always remember, we take acceleration as minus g. Even if the body is going up or the body is coming down, acceleration is always minus g. Time is t. This is the velocity in y direction at any point. Like at this point, velocity in x direction remains the same, but velocity in y direction is u sine theta minus gt. U sine theta minus gt. At topmost point, vertical velocity is 0. Horizontal velocity is u cos theta. I hope this is crystal and clear. Now guys, see. First and the foremost thing is time of flight. Let's suppose you are throwing a projectile from this point to this point. I am saying how much time it will take from initial point to final point. That is going to be the time of flight. And this time of flight is 2u sine theta by g. U is the velocity with which we are throwing. Theta is the angle with the horizontal. So 2u sine theta divided by g. G is the acceleration due to gravity. Next. Sir, if you are throwing, how high it can go? What is the maximum height it can attain? That is u square. U is the initial velocity. Sine square theta divided by 2g. Yes. U square sine square theta divided by 2g. Even you can write it like this also. Guys, what is this u sine theta? U cos theta is ux, horizontal velocity component. U sine theta is uy, vertical velocity component. Can I not write over here? This is uy square divided by 2g. Yes. Even I can write this. T is equal to 2u. U sine theta is uy divided by g. Okay. Now guys, tell me what about this one? Horizontal range. Guys, there is one more formula for the range. R is equal to 2u sine theta, u cos theta divided by g. This is also the formula of range. Even you can write it like this. 2u sine theta means uy, u cos theta means ux divided by g. Keep this in your box. This is also the formula for range. Range means if you are throwing a projectile, how far it can go, that is going to be the range. How far it can go. How high it can go, that is going to be the maximum height. And time of flight is going to be how much time it is going to take. These are all the formulas which you have in the projectile motion. Now. Let's talk about this one. Guys, see. We are given an object is projected with a velocity u is equal to alpha I cap plus beta j cap. See guys. If I say, listen very carefully. If I say there is a body, okay, this is a car. It is moving in x direction with velocity 2 meters per second. I can write it like this, 2 I cap. I cap is that vector which tells us this body, this velocity is in the positive x direction. Even if I say, sir, this is a body. If you are applying a force on this body, you can say, sir, this force is along positive x direction. So you mention force into I cap. I cap means x direction. Okay. If I say there is a body which is moving in y direction with 2 meters per second, you can say 2 j cap. J cap is that unit vector which tells you the direction of the vector. This body is moving in the y direction. K cap means z direction. Now, if I say initial velocity is alpha I cap, beta j cap, means a projectile is launched with a velocity u, okay, with a velocity u. What is the horizontal component? What is the horizontal component? Ux, that is alpha. What is the vertical component? That is uy, that is beta. Okay, because beta j cap means vertical, which is along y direction. Alpha means which is along x direction. Now it says, find height, time of flight, and range. First of all, let's find the maximum height. Maximum height we recently studied. What is the formula for maximum height? Uy square divided by 2g. Uy square divided by 2g. What is the value of uy? That is beta. So beta square divided by 2g. Okay, what is time? Time is 2uy divided by g. See, time is 2uy divided by g. And can I write over here, this is 2 and this is beta divided by g. What is range? Range is 2ux uy divided by g. So range is going to be 2 alpha beta divided by g. This was the question asked in IIT 2014. I hope this is clear. I hope this is clear. I hope this is clear. A cricket ball is hit at an angle of 45 degree to the horizontal with velocity v. Its kinetic energy at topmost point is, see guys, it says you have thrown a cricket ball, okay, you have thrown a cricket ball at an angle of, with a velocity v, at an angle of 45 degrees. What is the kinetic energy at the topmost point? See guys, at topmost point we know vertical velocity vy is 0. Horizontal velocity is vx. It will be v cos theta only. Why? Because if this is v, this is going to be v cos of theta, horizontal component. Horizontal component remains constant throughout the motion. Horizontal component remains constant throughout the motion. Now tell me, at topmost point, when it comes to the kinetic energy, you say it is going to be 1 by 2 mv square. So it is 1 by 2 m is mass. At topmost point, what is the velocity? V cos theta. V cos of 45 only, okay? Because vertical component is 0. Okay, and it is square, V cos square of 45. So it will be 1 divided by 2 m. V cos 45. Cos 45 is 1 by root 2. It's square. So it will be mv square. So this will be v square divided by 2. Because cos 45 is 1 by root 2. 1 by root 2 whole square means 1 by 2. 2 into 2 is 4. So it is going to be 1 by 4 mu mv square. This is the kinetic energy at the topmost. This is the kinetic energy at the topmost. Okay. Now guys, take a look. Two objects are thrown up at an angle of 45 degree and 60 degree respectively with the horizontal. If both attain the same vertical height. Now guys, it says that two objects are thrown up. They are attaining the same vertical height. Two objects are thrown. Both are attaining the same vertical height. Okay. Ratio of magnitude of velocities of these objects. See. What is the value of height? That is u square sine square of theta divided by 2g. And when we are talking about first object, so I'll write u1 sine theta 1 is equal to u2 square sine square of theta 2 divided by 2g. Yes, I can write it like this. Now 2g and 2g will cancel. I can write over here u1 square divided by, take it over here, u2 square will be sine of theta 1 divided by sine of theta 2. It's square, it's square. Now tell me, Sine of theta 1. First object is thrown at 45, sine 45 whole square. 1 divided by root 2 whole square upon second object is thrown at 60 degree, that is sine 60 is root 3 divided by 2 whole square. Now tell me, this is going to be 1 divided by 2 upon, this is going to be root 3, okay, this is going to be 3 because square and root will cancel, 3 divided by 4. Now tell me guys, can we write it 1 divided by 2 into 4 by 3, 2 ones are 2, 2s are 4. Okay, so this is going to be 2 divided by 3, u1 square by u2 square. Sine of theta 2. I made a mistake. Here it must be theta 2. Yo. No problem. If I am writing over here in this particular case, see, directly I'll put the values. So u1 square, sine square of theta 1. Theta 1 is 45 degree. So that is going to be 1 divided by root 2 whole square is equal to u2 square. What is going to be the value of sine of 60? That is root 3 divided by 2 whole square. Now tell me, u1 square into 1 by 2, okay, into 1 by 2 will be equals to u2 square into 3 divided by 4 because root 3 by 4 whole square is 3 by 4. Now 2 ones are 2, 2s are 4. I can write it like this. Now see guys, this is going to be u1 square divided by u2 square is equal to 3 divided by 2. Now take it over here. u1 divided by u2 will be root 3 by 2. Now is it correct? Is it correct? Is it correct? Fine. Yes. Now let's talk about this one. Relation between horizontal range and maximum height. Is there any relation between horizontal range and maximum height? That's what we need to discuss. Yes. This is the relation which I want you guys to remember. H is equal to r tan theta divided by 4. This is the height. This is the range. This is tan of theta. Theta is the angle at which we have projected the projectile divided by 4. Like this will help us to solve the questions. The horizontal range and the maximum height of projectile are equal. H is equal to R. The angle of projection will be, guys, as we are supposed to find the value of theta. As we know, as we say H is equal to R tan of theta divided by 4. So we can say H is equal to, what is the value of R? That is going to be H only. So we can say tan of theta divided by 4. H and H will cancel. So tan theta will come out to be equals to 4. Theta will be equals to tan inverse of 4. Okay. I hope this is clear. Similarly, we have next question. The horizontal range of a projectile is 4 root 3 times maximum height. Range is given as 4 root 3 times maximum height. Okay. Yes. Its angle of projection is, again we have to find theta. Guys, tell me. We say H is equal to R tan of theta divided by 4. Yes. Now R is given as, we can write H is equal to, what is the value of R? That is 4 root 3 H. Then we say tan theta divided by 4. 4 and 4 will cancel, H and H will cancel. So value of tan theta will come out to be 1 divided by root 3. Tell me, when is the value of tan theta as 1 by root 3? We say when theta is equal to 30 degrees. So value of theta came out to be 30. Okay. Yes. 30, not 60. Now take a look here. Take a look here. Conditions for maximum horizontal range. See guys, sir. If you are throwing a projectile, sir, at what angle we must throw the projectile so that this range must be maximum? Directly remember, my dear friends, this theta must be equal to 45 degrees. If theta is equal to 45 degree, range will be maximum. Now this is the formula for range. Yes. Put theta is equal to 45. 2 into 45 is 90. So R will become U square sine of 90 divided by G. Sine 90 is 1. So it will be U square by G. This is the maximum range. So when theta is equal to 45 degree, okay, when theta is equal to 45 degree, in that particular case, range is going to be the maximum, and maximum range is U square by G directly. That's it. That's it. Now, one more important thing. We say range for two different angles is same. Like. Let's suppose you are throwing a projectile over here. This is the first projectile that you are throwing. And you are throwing a next projectile, something like this. Okay. This is one projectile, this is another projectile. Okay. Now see, this has got this much of range. Let's suppose 50 meters. This projectile also has got the same range. Initial and final point are same. Sir, is it possible? Yes. So we can say, if you take an angle alpha, let's suppose 30 degrees. Sir, whatever is the range at this angle, same will be the range at 90 minus alpha. 90 minus alpha. That clear? Like, if you are throwing a projectile, see guys. If you are throwing a projectile, let's suppose at an angle of 30 degrees, okay? It has got the range R. And if you are throwing another projectile at an angle of 90 minus alpha, 90 minus 30, that is 60. So at an angle of 60 degrees, so here also range will be R. So this range and this range will be exactly equal. So means at 30 degree and 60 degree range is same. At 40 degree and 50 degree range is same. Why? Because alpha and 90 minus alpha. So 90 minus 40 is 50. At 70 degree and 20 degree range is same. 80 degree and 10 degree range is same. 15 degree and 70 degree range, 75 degree range is same. Range for two different projectiles is same. Okay. A projectile is fired at an angle of 45 degrees with the horizontal. There is a projectile which we have fired at an angle of 45 degree with the horizontal. Okay. At an angle of 45 degree with the horizontal. Okay. There is a projectile which we have fired at an angle of 45 degree with the horizontal. Okay. Yes. Then it says elevation angle of the projectile at the highest point as seen from the point of projection is. This is the highest point. Join this highest point with this initial point, this one. This is called elevation angle. Okay, this point and this point, join these two. This is the maximum height. This is range. So this will be R divided by 2 from here to here. Now, if I say you have to find the elevation angle, guys, you have to find the tan of alpha. That is this perpendicular divided by base. That is going to be H max divided by base is going to be R by 2. H max divided by R by 2. Okay. What is elevation angle? Join the topmost point with the initial point. Angle between these two is angle of elevation. Now guys, listen to me very carefully. So we say this tan theta is perpendicular by base. So I can say tan of alpha will come out to be, that is, take this here, this is 2H divided by R. Yes. Now tell me one thing. We say as we have already studied, H is R tan of theta divided by 4. Now tell me, you have fired this at an angle of 45 degrees. So what is the value of tan 45? So H is equal to R tan of 45 divided by 4. Tan 45 is 1. So h will come out to be r divided by 4. Now put this in the equation first. This is first. Put in first. If you put this in the equation first, so can I say this tan of alpha will come out to be 2h 2 by r. Instead of h, what can you write? R divided by 4. R and R will cancel. 2 ones are 2 2s are. So tan alpha will come out to be 1 by 2. So alpha will come out to be tan inverse of 1 by 2. I hope this is clear. So this is the elevation angle. Always remember, this is the elevation angle. Tan inverse of 1 by 2. Now guys, one more thing. What is that? That is horizontal projectile. Take a look at horizontal projectile. Take a look at horizontal projectile. Horizontal projectile. Guys. Horizontal projectile means you have got a building over here. Okay. At the topmost point of this tower, there is an object which is thrown horizontally with a velocity u. Okay. If you are throwing this horizontally with a velocity u, it will follow this path. This is called horizontal projectile. Now see, initially, when you throw this projectile, you are throwing it horizontally. It is completely horizontally. Okay. All of its velocity is in the x direction. Ux is equal to u. Okay. So at time t is equal to 0, we say initial velocity ux is equal to u. What is the velocity in y direction? Is there any velocity in y direction? No. No upward, no downward, only horizontally. So uy initially is 0. Okay. Okay. And if I say acceleration, we say acceleration in y direction is minus g. Okay. And acceleration in x direction is 0. Because there is, always remember, in case of horizontal motion, in case of projectile motion, there is no force acting in the x direction. Force always acts in y direction. That is gravitational force, mg. Okay. So acceleration in y direction is minus g, acceleration in x direction is 0. Okay. If acceleration in x direction is 0, what will be the velocity in x direction? Finally, after some point, sir, I can use v is equal to u plus at in x direction. V is equal to initial velocity in x direction, that is u. Acceleration in x direction is 0, so this term will become 0. So v is equal to u only. So final velocity also, it is u. If you are throwing this projectile, let's suppose the projectile reaches here, horizontal velocity will be u only. Okay. When it comes to the vertical velocity, guys, vertical velocity, you say v is equal to u plus a into t. Now see, v is equal to initial velocity in y direction, sir, that is 0, because you are applying in y direction, this is 0. Acceleration is g and t, so this is gt, so this is going to be gt. Okay. And if somebody says what is the net velocity, you say, sir, this net at this point, net will be under root of this square gt whole square plus u square. Okay, at this point, because this is the resultant vector. This is one vector, this is another vector. So root of this square plus this square will be this square, will be equal to this resultant velocity. Okay. Okay. I hope this is crystal and clear. Now see, time of flight. If you have thrown an object from certain height, from this height, if you are throwing an object horizontally, it will fall down. Okay. How much time it is going to take in falling? That is under root of 2h by g. Under root of 2h by g, where h is the height of the tower, g is the acceleration due to gravity. If somebody says how far it can fall, how far it can go, that is range. Range will be u. U is the initial velocity with which you are throwing into under root of 2h divided by g. This is going to be the range. That's it. These are all the formulas. Okay. and y is equal to 1 by 2 gt square. This you can apply in the y direction to find this vertical displacement. Like. Okay, one more important thing. If you throw an object horizontally, it will go. Let's suppose when the object reaches here, this is its velocity v. Okay, it will have horizontal component u, vertical component gt. And let's suppose if it is making angle alpha with the horizontal, how can you find this angle alpha? Tan of alpha, that is perpendicular divided by base, gt divided by u. Keep this thing in your mind. And this velocity will be under root of u square plus this gt whole square. That's what I have told you. Let's talk about this. See, ball is projected with a velocity of 30 meter per second. Understand this very carefully. Ball is projected with a velocity of 30 meter per second in horizontal direction from some height. Find the time when it is making 45 degree with the horizontal. So it is going something like this. Okay. You guys are supposed to tell me, let's suppose when it reaches here, it is making 45 degrees with the horizontal. At this point, it is making 45 degree with the horizontal. You have to tell me what is the time here. See guys, initially velocity, horizontal velocity is 30. Here also you will be 30 because we know horizontal velocity remains constant throughout the motion. When it comes to the vertical velocity is gt. We know, sir. Yes. Now tell me. This angle is given. This velocity is given. This velocity is given. Now tell me, tan alpha is gt by u. Can I say tan of 45, alpha is 45, is gt divided by u is 30. Tan 45 is 1. Take it over here. 30 into 1 is 30 is equal to g into t. G is the acceleration due to gravity. We usually take it 10 meter per second square. So 30 by 10 is equal to t. This and this will cancel. So t will come out to be 3 seconds. So after 3 seconds, object will be making 45 degree with the horizon. Is this clear? Please let me know in the chats. Everybody out there, let me know in the chats. Let me know in the chats. I am writing the magnitude only here. You can take minus g also. Minus g means velocity, minus gt means acceleration is downward. Negative sign, that is what is telling you. When you take magnitude only, just take gt. Now see, a body is thrown horizontally with a velocity root 2gh from the top of a tower of height h. It strikes the level ground through the foot of the tower at distance x. It strikes the ground at a distance x from the tower, foot of the tower. The value of x is, you have to find x. X means range. You have to find range. Okay. What is the value of range? Guys, see the formula. Range, u under root of 2h by g. So that is u under root of 2h divided by g. Now tell me, r is equal to, what is the value of u? u is given as 2gh under root of 2h divided by g. Yes. Now guys, root h into root h is h. See, 2 root 2 into root 2 is 2. Root h into root h is h. Okay, everybody knows it. Root h into root h is whole. Root h into root h is root 2. Root h into root h is a root h of whole square. Square and root h, square and h will, square and root will cancel. It remains h only. And then you have root g divided by root g. This and this will cancel. So answer is 2h. Relative motion. Now guys, see, listen to me very carefully. Let's suppose there is a car which is moving with a velocity a, va. Okay. There is a car which is moving with a velocity vb, another car. And there is a person exactly over here on the ground which is at rest. If I ask this particular person, tell me, what is the speed of this car A? You'll say, sir, if it is going with 10 meter per second. Okay. You'll say, sir, it is moving with 10 meter per second, simply. And let's suppose this is going with 5 meter per second. Sir, it is, this person will say, it is going with 5. Now, what if I ask, or let's suppose both are going with 10. Now, what if I ask this person B, what is the speed of A? Person B is saying, this A is on my side. I can speak to him. I can ask him anything I want. So I don't think he's having some speed. So his speed is 0. So according to B, speed of A is 0. Even according to A, speed of B is 0. This is called a relative motion. This is called a relative velocity. How do we find the relative velocity? Guys. We say velocity of A with respect to B. Velocity of A with respect to B. It is velocity of A minus velocity of B. So basically it says velocity of A is 10 minus velocity of B is also 10. That is 0. This is the relative velocity of A with respect to B. Now if I say this is C. What is the velocity of A with respect to C? Now see guys. You'll say, sir, it is velocity of A minus velocity of C. Velocity of A is how much? 10. Velocity of C is 0 because C is at rest. So it is 10 meter per second. That is what I was saying. According to this person, velocity of this is 10 because he himself is at rest. Okay. According to this person, velocity of this is 0. And velocity of B with respect to A is velocity of B minus velocity of A. Let's suppose if I ask you the question something like this. Guys, you have got a car over here. This car has a velocity VA is equal to 10 meter per second. And there is one more car over here which is having the velocity of VB is equal to 10 meter per second. Okay. Okay, 10 and 10. If I say, what is the velocity of A with respect to B? What will you say? Velocity of A minus velocity of B. You'll say velocity of A is 10 minus velocity of B is how much? It is in the negative direction, so it is minus 10. Now see, 10 plus 10 is 20 meter per second. Now that is the reason. If you are sitting inside the car, your friend is on, if you are in a bus and another bus is crossing, at that point of time, why does it feel like the speed have increased? It is, the two buses are crossing very fastly. The speed has been increased. It is because of relative motion. This is because of relative motion, speed is increased. In reality, with respect to the ground, your speed is only 10. With respect to the ground, its speed is only 10. But with respect to each other, their speed is 20. And if they are moving in the same direction, their speed will be 0. This is the concept of relative velocity. Now, there is an important problem, that is Rain-Man problem. There is the Rain-Man problem. Okay. Now, guys, see, what is Rain-Man problem? A Rain-Man problem is basically, it is to save yourself from rain. It is to save yourself from the rain. It is to save yourself from the rain. Okay. That is the Rain-Man problem. Saving yourself from the rain. Now guys, see, let's suppose this is a bicycle riding over here. And if rain is falling, why does it feel like when you are riding the bicycle at that point of time, why does it feel like rain is hitting your face? Or while you are walking, it feels like rain is hitting your face while you stop. If you are standing here at rest, rain is falling vertically downwards, hitting your head. Okay. But when you start moving, at that point of time, it feels like a rain is hitting your face. So, my dear friends, while you are standing over here, okay, you are standing over here, it feels like rain is falling vertically downwards, okay? So, you open the umbrella opposite to the direction of rain. But while you are moving in the forward direction, it feels like a rain is hitting your face. So, you open the umbrella something like this. Yes. Now, let me show you why does it exactly happen. Let me show you. See guys. Let's suppose the rain in this particular case is falling over here. Okay. Let's suppose I'm saying rain is falling at the rate of 3 meters per second. Okay. This man is moving with a velocity of 2 meters per second. If you are standing at rest, it feels like rain is falling vertically downwards, hitting your head. While you walk, while you move, run, at that point of time, we say rain is hitting your face. Why does it feel like that? Why does this happen? See, guys, if I say in this particular case, listen to me very carefully. Listen to me very carefully. This is velocity of man. This is velocity of rain. If I say, sir, what is the velocity of this rain with respect to man? We'll be saying, sir, velocity of rain with respect to man. That is velocity of rain minus velocity of man. Yes. Now, tell me one thing. Tell me one thing. Tell me one thing. Tell me one thing. If I say velocity of rain with respect to man, what is the velocity of rain? The rain is falling vertically downwards. If there is a vector which is vertically downwards in y direction, negative y, we mention j cap with it. If it is in plus y plus j cap, negative y minus j cap. So I'll be writing over here, it is minus 3j cap, this velocity. Then we say this formula is minus. Velocity of man, that is 2i cap. I cap means this velocity is in the plus x direction. I cap gives you the direction of a vector quantity which is along plus x axis. J cap gives you the direction which is along plus y axis. Minus j is minus y axis. Now I say plot this. Plot this graphically. See guys, if you have to draw these vectors, minus 3j cap means downward. Minus 3j cap means downward. Okay, this is velocity of rain. Okay, minus 2i cap means backward, because plus 2i cap is forward, minus 2j cap is, minus 2i cap is backward. Velocity of man. Now this vector, the resultant vector will be this. This is velocity of a rain with respect to man. Now guys, this is the velocity of rain according to man. So if rain is falling at an angle something like this, man has to open the umbrella something like this. At an angle with the vertical. At an angle with the vertical, that is theta. This angle is also theta. Now guys, listen to me very carefully. If somebody asks you, what is the velocity of rain with respect to man? You'll be saying that is under root of this vector square plus this vector square. That is Vm square plus Vr square. So that is going to be under root of, what is Vm? Okay, what is Vm? That is 2 square. This is 3 square. That is 2 square plus 3. That is going, 2 square is 4, 3 square is 9. 9 plus 4 is, we can say, root 30. Similarly, if somebody asks you, how do you find this theta? You say, sir, tan of theta in this particular case is, tan of theta is perpendicular by base. That is Vm divided by Vr. So what is this? This is the angle at which you have to tilt the umbrella so that you can save yourself from rain. This is vertical. This is the angle theta. You have to tilt the umbrella so that you'll save yourself from rain. This is that angle, Vm by Vr. Okay. Now I hope you got the feel. Why does it feel like rain is falling at some angle? It is because of the relative motion. Okay. Now take a look. In case of rain man problem, there are two cases, generally two cases. The first one which we discussed, when rain is falling vertically downwards. In this case, rain is falling vertically downwards, okay? Man is moving. When in reality, rain is falling vertically downwards, man is moving, okay? Guys, see. If man comes to rest, okay, rain is falling vertically downwards. When man moves, it feels like it is falling at some angle. Already we discussed velocity of rain, velocity of man. This will be the velocity of rain with respect to man. And this is the velocity of rain with respect to man. This is the theta angle. Already we have discussed this. Okay. Second case is case number 2. When rain is falling vertically at some angle. Already rain is falling at some angle. Where is that? This. Rain is falling at some angle. Sir, how is it possible that rain can fall at some angle? How is it possible? See, let's suppose if rain is falling vertically downwards. Wind is blowing over here. Due to this wind, don't you think that the rain is going to tilt? Okay, so the rain is going to tilt something like this. Due to this wind, the rain is going to tilt something like this. Yes. Now. Let's suppose when this man is at rest, when the man is at rest, rain is falling at some angle already. This is velocity of rain. Previously, when the man was at rest, rain was falling vertically downwards. Okay. When man moves, it appears that rain is falling at some angle, but in reality, it is falling vertically downwards. Next case is, when man is at rest, rain is falling at some angle, theta. This is VR, this will be VR cos theta. This will be VR sin theta. Okay. Now see. Now here man is moving. Listen to me very carefully. Tell me one thing. If man moves with the same velocity of this, Vm is equal to Vr. Recently I have told you in relative motion concept, if the two bodies move with the same velocity, what is their relative velocity? 0. Okay, horizontally we are talking about. Now, if this velocity becomes equal to this velocity, can I say these two will cancel each other? Yes. We say if Vm becomes equal to Vr sin theta. Okay, if this becomes equal to this, then this is cancelling with this. Only one velocity of the rain remains, that is this. Then rain will fall vertically downward. Why? Because then in that case, there will be no velocity of the rain. This is cancelling with this. With respect to the man, I'm saying. Okay, then rain will fall vertically downward. So in that case, velocity of rain with respect to man, it is going to be Vr cos theta only. I hope this point is very clear to each and every single student. Okay, if this velocity becomes equal to this velocity, then with respect to the man, rain is falling vertically downwards. But if man stops, rain will fall again at some angle. Is this point clear? Please tell me in the chats. So these 2 points you guys need to understand in the second case. That's what is mentioned. Here, the question can be asked, with what velocity man should move such that rain will appear to fall vertically downwards? In that case, you will say this condition. If the rain is appearing to fall vertically downwards, then the speed of rain with respect to the man will be, that is this. Please tell me in the chats. Please tell me in the chats. Is this clear? Please tell me in the chats. Okay, let's take a look at the question. See, when a person walks on a straight road with 10 km per hour, okay, see guys, this is the person which is walking on a straight road, velocity of man is 10 km per hour. Okay, rain appears to fall vertically downwards. Rain appears to fall vertically downwards. Appears. What does that mean? Rain is not falling vertically downward. Rain appears to fall vertically downward. Okay, so in reality, rain is falling at some angle. Okay, so this is velocity of rain, and this is theta. This is theta. So this will be VR cos theta. Okay, this is going to be VR sin theta. Okay, this is exactly the case number 2. This is exactly the case number 2. When man is at rest, rain is falling at some angle. When man moves with some velocity, exact this velocity, then it appears rain is falling vertically downwards with what velocity? VR cos theta. Exactly the case number 2. Okay. As he stops, the rain appears to fall at an angle of 30 degree. As he stops, rain appears to fall at an angle of 30 degree. That's what I was saying. Theta in this case is given as 30 degrees. With the vertical. The speed of the rain with respect to the ground is, you guys are supposed to find velocity of a rain. Not with respect to the man. Velocity of rain only with respect to the ground. Now tell me, can I say here, this is the case 2. In this particular case, this velocity is equal to this velocity. Vm is equal to VR sin theta. Yes, sir. Can I say Vm, value of Vm in this particular case is 10, is equal to VR sin of 30. Sin 30 is 1 by 2. 2 into 10 is 20. So VR will come out to be done. VR will come out to be 20. Even if somebody asks you find the velocity of rain with respect to man, velocity of rain with respect to the man, so that is VR cos theta. Okay, so that is going to be VR is how much? That is 20. Cos theta, cos 30 is root 3 by 2. 2 ones are 2 tens are, so this is going to be 10 root 3 meter per second. Both the values. This is the simplest way to understand rain man problem. And only there are these 2 cases, nothing else. Then you have got riverboat problem. Guys, see, riverboat problem means you will be given a river, okay, and you will have to cross the river. Okay, first case in this case is that is crossing the river in minimum time. First thing is crossing the river in minimum time. Now, my dear friends, let's suppose this is the person over here. Understand this very carefully. This is the person over here. And this person has to cross this particular river. Okay, this person has to cross the river. And I say this is the velocity of man. Something like this. River is flowing in this direction. This is the velocity of river. Instead of making here, I'll make it this at this point. When person dives into the water, at that point of time, it will have two velocities. One is his own velocity, another will be due to the river. Okay. Now, resultant of this one and this one will be net, V net, that is this. Now, guys, we say in this particular case, the man wants to travel to the opposite side. But due to when he dives and tries to cross, due to this river velocity, it will basically, he will reach to this particular point. So basically this pitch, he will be dragged from this opposite point. This is called the pitch or drift. And if I say how much is the minimum time in which it will cross, minimum time is going to be D. D is the width of the river. D is going to be the width of the river upon V minimum, upon Vm. Because see, D divided by Vm. Vm is the velocity with which it wants to cross. Vr is the velocity with which this drag is produced, with which it will be dragged. So that's why in the time it is D divided by Vm. Okay. Even if somebody asks you the net velocity, this net velocity, don't you think it will be under root of this plus this whole square? Yes, under root of Vr square plus Vm square. If somebody asks you how much is this drift, sir, this distance, we say distance is equal to speed into time. This is the formula. That's what we use. Drift is equal to speed into time. With what speed it is drifting? Vr, velocity of river, multiplied by time. Time is D divided by Vm, because we have calculated the time here. These are the three cases we say when it comes to the crossing the river in minimum time. Okay. Now take a look at the question. A river of 4 mile wide. This is a river. Okay. This width D is given as 4 mile. Okay. Is flowing at a rate of 2 miles per hour. Is flowing at a rate of 2 miles per hour. In this particular case, velocity of the river is 2 miles per hour. The minimum time taken by the boat to cross the river, you have to find the minimum time to cross the river. Okay, with a speed, the minimum time taken by the boat to cross the river with a speed of 4. Okay, velocity of man or boat is given as, that is 4 miles per hour. Now tell me, in this particular case, you have to tell me minimum time. We say T minimum is going to be distance upon velocity of man. Recently we calculated. So D is 4. Velocity of man is also 4. This and this will cancel. It will be 1 hour. So it is going to take 1 hour. It's in hour, not in second. Okay. Now, my dear friends, listen to me very carefully. So you got the value of minimum time. Let's suppose if I say this person wants to go, okay, something like this, but due to the river velocity, it will be dragged. It will land here. How much is this drift created? So can I say this drift is going to be, guys, what is the formula for drift? VR up into D divided by V minimum. Okay, that is VR into D divided by V minimum. Sorry, V man. VR, velocity of river, that is 2. And what is the value of this? That is 1. So this is going to be 2 miles. So 2 miles is the drift created in this case. 2 miles is the drift created in this case. Next, a boat is sent across a river with a velocity of 8 km per hour. So this is the river. A boat is sent with a velocity of 8 km per hour. A boat is sent with a velocity of 8 km per hour. V boat is 8. The resultant velocity of the boat is 10 km per hour. Resultant net, V net is 10. Then the velocity of river is, you have to find velocity of river. Guys, don't you think we recently calculated this also? net velocity is under root of VR square plus VM square. So we say net velocity is under root of VR square plus VM square. Now take the square over here. So this is V net square, and then this Vm also minus Vm square is going to be VR square. So VR will come out to be under root of this V net square minus, we say, Vm square. Okay, it is under root of, what is V net? V net is given as 10 square, Vb is given as 8 square. Velocity of boat, so this is 10 square, that is 100, minus velocity of man or boat, 8 square, that is 64. That is 36, root 36. That is going to be 6. Yes, 6. 6. Next we have crossing the river in the shortest path. Now guys, first one was crossing the river in the shortest time. If this is the river over here, okay, if this is the river over here, you have to cross this river in the shortest path. Tell me. If this is the river, will this be the shortest path, this be the shortest path, this? Obviously this one. This is going to be the shortest path. Now, if I say, sir, you started crossing the river directly, but this river velocity will drag you. You will land. This will be the actual path you followed. So you will basically create the pitch. You don't have to create the pitch. So in order to travel through the shortest path, don't you think you should originally leave at some angle, and then while you are drifted, you will be straightly moving and cross the opposite side? In this case, it will no doubt take you the minimum time. Okay, you will land here, drift will be created, time will be minimum. Always remember, in order to travel with the minimum time, you have to travel straight with straight. Okay, but when it comes to the shortest path, so you initially leave at some angle, that is theta. This is velocity of man and this is angle theta. This is velocity of man and this is angle theta. Okay. Now guys, see, this is velocity of man. This is angle theta. Can I say this is Vm cos theta? This will be Vm sin theta. Yes. Now see. Due to this velocity, it is being dragged. Okay, due to this Vr. If this velocity becomes equal to this velocity, Vm sin theta. Now these two will cancel each other. Net velocity will be what? Vm cos theta. So it will directly cross. So what is the condition to cross through the minimum path, through the shortest path? This velocity must be equal to this velocity. Vm sin theta must be equal to Vr. These two will cancel each other. Resultant velocity net will be Vm cos theta, which is straight. So then it will travel through the straight path. That's it. Only one condition. Now, only one condition. Now tell me, JEE Mains 2019, stream of river has a velocity of 2 km/h. There is a stream. It has got the velocity of 2 km/h. So this is the stream. Okay. Velocity is 2 km/h. Velocity of the stream is 2 km/h. Swimmer can swim with 4 km/h. Swimmer can swim with 4. Velocity of man is 4. So that he travels straight with respect to flow, means he has to reach to the opposite side. Straight with respect to flow means he has to travel through the shortest path. If the person has to travel through the shortest path, understand this very carefully, he has to move at some angle initially. This is theta. This is Vm. This component will be Vm cos theta. This component will be Vm sin theta. Now tell me guys, in order to travel through the shortest path, don't you think this velocity should be equal to this velocity? So VR must be equal to Vm sine theta. Now what is the value of VR? Velocity of river is 2 km. This is 2. What is the value of Vm? Stream, it can, boat can swim with a 4 km per hour. And then we say sine of theta. 2 ones are 2 twos are. It is 1 by 2. Sine theta is 1 by 2. Sine theta is 1 by 2. So theta will be equals to 30 degrees. Means theta is 30 degrees. Now you have to find the direction of the swimmer so that he travels straight with respect to flow. Guys. This is the direction of flow, downward. This is the direction of swimmer. This angle is 30. This angle is how much? 90. So alpha will come out to be 90 plus 30. Alpha will come out to be 120. So with respect to flow, he has to, see. Not with respect to this line. With respect to flow, he has to move at an angle of 120 degree initially. So 120 degree is the answer, not 30 degree. 120 degree. Is that clear? Then we have the chapter 4. Okay, let's start the chapter 4. Okay, let's start this chapter. That is the chapter 4. Guys, smash the like button, huh? If you have not liked the session yet, do it right away. What is NLM? Okay, Newton's laws of motion. Newton's laws of motion. Now guys, take a look. Take a look. Okay. We say, just a second, guys. Just a second. Laws of motion. First law of motion. What does first law of motion say? Everybody wants to keep its state of rest. or uniform motion until and unless it is acted upon by some external force. What does that mean? That means, let's suppose if you have a body over here which is in rest, okay? If I say net external force on this body is 0, force acting on this side is F, from this side also F, net is 0. We say this body will remain in the rest forever. If net external force on this body is 0, it will remain in the rest forever. Now, if this body is moving with some constant velocity, net external force is 0. We say it will keep on moving with a constant velocity forever. Velocity will not change. Okay. Then, my dear friends, we say, if this body is moving in a uniform direction, in a proper direction, okay, in uniform direction, if net external force is 0, it will not change its direction. Direction will remain the same. Direction will remain the same. That's what it is saying. That's what it is saying. Okay. See, guys, everybody wants to keep its state of rest and uniform motion until and unless it is acted upon by some external force. Okay. Everybody, if this is a body, it wants to keep its state of rest. It wants to remain in the state of rest until and unless it is acted upon by some external force, until and unless some external force acts on it. Then it will change that state. If it is in the uniform motion, it will keep on moving in the same velocity. I hope this is clear. I hope this is clear. This is the first law of motion. Then we define momentum. What is momentum? Momentum is defined as the product of mass and velocity. See, guys, let's suppose you have a truck over here. This truck has large mass. It has velocity. Then you have the toy car. This is a wall, big wall, concrete wall. If the truck hits the wall, if the toy car hits the wall, tell me, which of the two is going to break the wall? Which of the two is going to break the wall? If truck hits the wall and toy car hits the wall, which of the two is going to destroy the wall? You'll say, sir, truck. Why? Because truck has large mass. Is it because of that? We say no. See, if I say truck is moving with a very less velocity, very slowly. Truck is moving with a very slow velocity, very less velocity. Okay. Now, it will move. It is not going to destroy the wall. So, in order to destroy the wall, we say value of mass should be large, value of velocity should be large in combination. So, means momentum must be large. So, momentum is product of mass and velocity. When mass and velocity combines, just a second, guys. Just a second. Hello. Just a second, guys. You are kidhar ho? What are you guys doing there? Yes. Can you guys, can you see? What are you guys doing there without me? Oh. Ask them in the chats, guys. He wants me to cancel the session. Okay, and celebrate his birthday. Can we do that? Who? Yo. Can you? Yeah. Now he's 30 years old, man. Now I'm 30-year-old. 30 years old, huh? And she's just 31. No. Yawar is 15. She has crossed 35 last year, bro. She has crossed 35 last year. Yes, two. Okay, that's very nice. Two of them are in the class itself, huh? You want to say something to the kids? Today. Okay, yeah, yeah. Chalo, take care, take care, take care. Bye bye. So, they're having fun, they're enjoying, and I'm taking the class. Wow. Wow. Mm. With the most boring people. Okay, now guys, let's move. So basically, what is momentum? Momentum is simply the product of mass and velocity. When a mass comes in motion, when a mass comes in motion, we say momentum is generated in that mass. Momentum is generated in that mass. Okay, okay. So we say P is equal to mv. P is equal to mv. Now, guys, this toy car, it is having the less mass, so it will be having less momentum. So it is the momentum which is breaking the wall. So we say, what is train is having a huge momentum. Train is having a lot of momentum. Why? Because train has a lot of velocity. Train has a huge mass. That's why it has got a lot of momentum. So that's how we define momentum. Okay, now guys, see. Let's suppose in this particular case, there's an object over here which is having the mass m. This is the object which is having mass m. It is moving with a velocity v. Okay. Now guys, if I say what is the momentum of this mass and. Yes, if I say what is the momentum of this mass, you say m into v. Now let's suppose you applied some external force. Due to this external force, its velocity will change. So here velocity becomes v dash, mass is m. What is the momentum here? That is m into v dash. Can I say due to the external force, momentum of this is initial momentum, this is final momentum. Due to the external force, momentum of the body changed, that is delta P. So due to the external force, momentum of the body changes. So I can say this force is proportional to, I can say delta P divided by delta T. Yes. So this is what we call the Newton's second law. This is what we call the Newton's second law. This is what we call the Newton's second law. Okay. This is what we call the Newton's second law. That is delta P divided by delta T. On applying the force on any body, net external force, we say momentum of the body changes, velocity of the body changes. Okay, so that is delta P divided by delta T, and this is the average force. Now you can also write it like this: instantaneous force, that is dP divided by dt. Okay, this is the Newton's second law. Now tell me one thing, can I write it like this, sir? F is equal to d by dt of, what is this? This is m into v. Okay, I'll write it over here. We say F is equal to d by dt of mass into velocity. D by dt of mass into velocity. Okay. D by dt of mass into velocity. Okay. Now, guys, can I say if mass is constant, take this mass out. Okay. Mass is constant, take this. So dv divided by dt. What is dv by dt? That is acceleration. So F is equal to ma. So this is also the Newton's second law. But when mass is constant, in that case, you say mass into acceleration, F is equal to ma. Now, guys, if I say mass is also variable, velocity is also variable. So can you write in something like this? F is equal to, listen very carefully. Sir, this is u into v. Okay, differentiation of u into v. Now, m as it is, differentiation of velocity, dv divided by dt. then plus V as it is differentiation of mass, dm divided by. This is the differential version of Newton's second. Okay. Okay. So basically, what is the original Newton's second law? F is equal to dp by dt. Rate of change of momentum is directly proportional to external force. You apply external force, momentum will change. Okay, if mass is then constant, you say F is equal to ma. If both are variable, then you say in that particular case, m dv by d plus v dm by dt. Okay, this. Now let's talk about this. Take a look. A cricket ball of mass 250 kg collides with a bat. Okay, let's suppose this is the bat. This is the bat. This cricket ball collides with the bat. It is moving with the mass is m, velocity is v. Okay, collides with the bat with a velocity of 10 meter per second. Okay, if it collides with the bat, it comes back. Okay, after reflection, and returns with the same velocity, mass is same. Okay, it is coming, returning with the same velocity. Within 0.1 seconds, the force act is, we are supposed to find the force. See guys. First of all, find the change in momentum. Can you find change in momentum delta P? That is final momentum minus initial momentum. P final minus P initial. Okay. See. You say P final, delta P in this particular case. Delta P in this particular case. Tell me guys one thing. What is the final momentum? Sir, m into v. It is in the backward direction. Velocity is negative. So it is minus mv. Then we say this minus. Initial momentum is mv. So you guys will say minus 2 times of mv. This is change in momentum. If you write the magnitude only, so magnitude only will be, that is 2mv. Magnitude only will be 2mv. Now tell me, guys, if you have to find the force, that is delta P divided by delta T. This is how we find the force. So you say F is equal to, what is the value of delta P? 2mv divided by delta T, 0.01 seconds. Okay. 2. Mass of this object, 250 grams. Okay. Let's find this only, delta P here. Tell me, 2. Mass is 250. 250 grams. 250, if you have to convert this into kgs, 250 divided by 1000. Okay. And velocity is given as 10 meter per second. Now 0 will cancel, 0 will cancel. 2 ones are 2, 5s are 10, 5 ones are 5, 5s are 25. So delta P comes out to be 5. This is 5 upon 0.1. 5 upon 0.1. 5 upon 1 by 10. This will be 50 Newton. Answer is 50 Newton. Yes, 50 is correct. 50 is correct. Simply find the change in momentum first, then find the force. Okay, let's talk about this one. A vertical metal weighing 2 kg is resting on a frictionless plane. This is a metal block, which is resting on a frictionless plane, and its mass is 2 kg. Its mass is 2 kg. Okay, its mass is 2 kg. It is struck by a jet releasing a water of 1 kg per second. It is struck by a jet releasing a water of 1 kg per second. It is struck by a jet releasing a water of 1 kg per second. Okay. This jet is releasing a water of 1 kg per second. It is struck by a jet releasing a water of 1 kg per second. Okay. Okay. Yes. At a speed of, this is given as 5 meter per second. Calculate the initial acceleration of the block. We have to find the acceleration of the block. Guys, in order to find the acceleration of the block, listen to me very carefully. We say force is equal to mass into acceleration. Acceleration is force upon mass. Okay. So first you have to check how much is the force acting over here. See. In order to find the force acting, we say F is equal to, see, I would want you guys to use this particular formula. See. Formula is, if, let's suppose, if velocity is constant, so can I say dv by dt will come out to be 0, differentiation of constant will be 0. In that case, this will come out to be v dm by dt. This is also the Newton's second. If velocity is constant. And guys, if mass is constant, in that case, this term will become 0. In that case, this term will become 0. And then it will come out to m dv by dt. That is, we have done over there. So force here is v dm divided by dt. What is this dm by dt? How much mass is acting on this one? How much mass is we are throwing on this one? That is 1 kg per second. Dm by dt, mass per second. F is given as, velocity is 5. This value of dm by dt is given as 1. So force in this case is given as 5 Newton. Okay. Yes. Now acceleration. How much force is acting on the block? That is 5. Mass is 2. 5 by 2 is, that is 2.5 meter per second square. I hope this is crystalline clear. 2.5 meter per second square. .5 meter per second. Rocket propulsion. What does case of rocket propulsion actually say? See guys, when it comes to the rocket propulsion, I want you to understand this very, very, very carefully. I want you to understand this very, very, very carefully. See, you have got a rocket over here. This is the rocket that you have got. Okay. Now guys, we say here, fuel burns due to which mass of the rocket decreases. See, inside this rocket, there is fuel. When this fuel burns, exhaust gases come out. Due to those exhaust gases, it pushes the rocket in the upward direction. Okay. So basically, it creates the thrust due to which a rocket goes up. So how does the rocket go up? Fuel inside the rocket burns. It comes out in the form of exhaust gases. Okay, it comes out in the form of exhaust gases, due to which thrust is created and it goes up. This is the up thrust. This is mg is acting in the downward direction. So acceleration will be in the upward direction. Now guys, if we use this formula, Newton's second law, F thrust. If I ask you how much is the F thrust over here, this is v dm by dt. dm by dt means rate of combustion of fuel. How much fuel is decreasing over here? V is the velocity, where dm by dt is the rate of combustion of fuel. Now apply the second law in this case. Guys, see. Net force is equal to mass into acceleration. Net force is this force, upward force minus downward force. Net force is always large minus small. Upward force is F, that is v dm by dt, minus downward force is mg is equal to mass into acceleration. This is the formula we remember in case of rocket propulsion. This is the formula we remember in case of rocket propulsion. That's it. Now guys, see the question. If the force on a rocket moving in a force-free space with an exhaust velocity gas, exhaust velocity gas, V is given as 300 meter per second, and force acting is given as 201 Newton. Find the rate of combustion of fuel. You are supposed to find dm divided by dt. Guys, see, it is saying the rocket is moving in a force-free space, means there is no gravity. There is no gravity. Okay, there is no gravity. If this gravity is not present, so can I directly say how much is the force acting up thrust? V dm by dt. So I can in this particular say F is equal to v dm divided by dt. This force in this case is given as 210. Velocity is given as 300. And then you said dm divided by dt. Take it over here. dm divided by dt will come out to be 210 divided by 300. This will come out to be 2.7 kg per second. 2.7 kg. 0.7 or 2.7? Okay. 210 divided by 300. And this will cancel. Yes, 0.7. Yeah, 0.7. No, we'll take the break exactly at 1 o'clock. Yeah, we have 30 minutes. Now, guys, forces and mechanics. The first force that we need to talk over here is weight. See, guys, we say it is the gravitational pull by the earth. Let's suppose you have got an object over here. Its mass is m. We say, is there any force which is acting on this mass in the downward direction? Yes, that is mg. What is that? That is the gravitational pull. It is always vertically downwards. Its magnitude is mass into acceleration due to gravity. Mass into acceleration due to gravity. We say, okay. Now, my dear friends, let's suppose you have mass over here. On this mass, acceleration due to gravity, this mg will act in the downward direction. If this is theta, this will be also theta. This component will be mg cos theta. This component will be mg sin theta. Another force, normal reaction. It acts when two bodies come in contact. Whenever two bodies come in contact, normal force acts. Like I'm placing my hand over here. On my hand, force is acting in the outward direction. On this, force is acting in the inward direction. Okay. So it acts whenever two surfaces are in contact. It is always perpendicular to the surface in contact. It is always perpendicular to the surface in contact. These two bodies, see guys, on this block, normal force is acting in the upward direction. Okay. Similarly, on the table, normal force is acting in the downward direction. Okay. So it is between the two bodies. It is always perpendicular to the surface in contact. Perpendicular. It is always of pushing nature. This normal reaction pushes the block in the upward direction. It pushes here. Similarly, here, this is the wall. This is the block. Here, normal force is acting in this direction, something like this. Okay. Here, this is going to be the normal. Now, take a look here. If I say you have a block over here, on this, you have this block, and in the upward direction, this is N. In the downward direction, this is mg. This is theta, so this will be mg cos theta. So from this side, this is going to be mg sin theta. This is the normal reaction. Even in this case, you can say N will be equals to upward force is equal to downward. Okay. Then you say tension. What is tension? We say it is a force which is generated in the string. It is a force which is generated in the string. Now guys, you have got a string over here, a mass is attached. Is there any force which is acting on the mass in the downward direction? Yes, that is mg. But still, this mg is not able to pull it in the downward direction. Why? Because some force is saving it from falling. That is the tension force in the upward direction. So we say in this particular case, this tension is equal to mg. Okay, so it is always created in the tension and it is away from the body. So here it is away from the body. Like here, this block. In this case, this is the tension. Here, this is the tension. Okay. And if the string is same, tension will be same. This is the same string. So here tension is T. Here also tension is going to be T. Okay. Like this is the block over here. We say in this case, this is tension T1, tension. Then another string. When the string changes, tension changes. Here tension is T2. Here tension is T2. If the string changes, tension changes. Okay. Then we say free body diagram. Just a second, guys. Just a second. I'll come. Just a second. 2 minutes. Now, free body diagram. See, guys, to make the free body diagram for a body, we say draw all the forces acting on it. Then make the equation. See. Let's suppose you have got a body over here. You have to make its FBD. First and the foremost thing, you have to draw all the forces acting on it. You say in the downward direction, it has mg. So if this is theta, this will be theta. This will be mg cos theta. This will be mg sin theta. In the upward direction, this is normal. This will be tension. Now you can make it here. Now see on this body, in the upward direction, normal force. Downward direction, mg cos theta. From this side, mg sin theta. From this side, it is tension. Now you can balance these equations and you can write n is equal to mg cos theta. You can say tension is equal to mg sin theta. You can say it something like this. Okay, this is how we make the free body diagram. Then guys, if I say you have to make the free body diagram of these three, let's take this mass. In the upward direction, normal reaction. In the downward direction, mg. So if I say this mass, in the downward direction, it is mg. In the upward direction, it is N1 normal reaction. From the right side, it is tension T1. Similarly, you have got this mass over here. In the downward direction, it is mg. In the upward direction, it has got N2. From the right side, it has got T2. From the left side, it has got T1. Then guys, if you have got over here M3, in the downward direction, it is mg. In the upward direction, it is going to be N3. From the right side, it is going to be T2. Okay. So this is the free body diagram of all the three. That's it. Motion of the connected mass system. If you ever see a system something like this, and if they ask you to find the acceleration of the system, see guys. First and the foremost thing, what is the mass force acting on this in the downward direction? That is m into g. So that is 3g. That is 3g means 3 into 10, that is 30 newtons. m into g. G is 10. 3 into 10 is 30. On this, it is going to be 5 into 10, that is 50 Newton. If they ask you to find the acceleration of this system, always remember acceleration you write, I'll write over here. Acceleration is net pulling force divided by net mass. Net pulling force divided by net mass. Now guys, when it comes to the net pulling force, sir, here this is 50, here this is tension T1. In this case also it is tension T1, here also it is tension T1 because string is same, so tension will be same. In this case tension is T2. Sir, shall we consider this tension also in the pulling force? No, 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 no. Okay. And here mg of this is in the downward direction, that is balanced with the normal reaction. See, net pulling force will be, this will be considered as pulling force, this will be considered as pulling force. So it is going to be 50 minus 30 divided by net mass. 5 plus 2 is 7, 7 plus 3 is 10. So this is 10. So this is 20 divided by 10. This will come out to be 2 meter per second square. 2 meter per second square. Okay. So directly net pulling force divided by net mass will give you the acceleration of the system. Like you have this. Find the tension and acceleration. What is the acceleration? Net pulling force. What is the force on this in the downward direction? That is 20 Newton. On this, it will be 30 Newton. M into G. 3 into 10, that is 30. 2 into 10 is 20. What is the net pulling force? That is 30 minus 20 divided by, what is the net mass? 3 plus 2 is 5. So 30 minus 20 is 10 divided by 5. 5 ones are 5 twos are 2 meter per second square. Okay. Now, if you have to find the tension also, see guys. In this case, this is the tension T. Here also, this is going to be the tension T. See, take any block over here. Take any block over here. This is 30 Newton. See. 30. This is 20. So 30 is greater than 20. Whatever is the direction of net force, larger force, that will be the direction of acceleration. See, so you say 30. Now, guys, take this block 3 kg. In the downward direction, it is 30 Newton. This is the acceleration. This is the tension. Use second law. What does second law say? Net force is equal to mass into acceleration. Net force will be 30 minus T. 30 minus T is equal to mass into acceleration. 3 into acceleration is whatever is the acceleration of the system, that will be the acceleration of this mass, that will be the acceleration of this mass, that is 2. Okay. So 3 into 2 is 6. So 30 minus 6 is equal, take it over here, tension. So T will come out to be 24 Newton. Is this clear? Is this clear? Please tell me in the chats with the fire emojis. Everyone means everyone. Let me know in the chats with the fire emojis if this is crystalline clear to each and every single student. Quick. All the lovebirds in the chats, please do smash the like button, okay? Then leave, okay? Because liking the session is mandatory. We consider pulley and string over here massless. Okay. Now, let's suppose, okay, we have this system. Find the tension in the strings. Okay, first of all, what is the acceleration? Acceleration is going to be net pulling force. There is only one pulling force. Sir, shall we not consider these tension as a pulling force? No, these are the internal forces of the system. Only 40 Newton. So 40 divided by net mass. 10 plus 6 is 16 plus 4 is 20. So that is 2 meter per second square. Directly is the acceleration. Now you have to find tension T1, T2. If you want to find the tension T1, take this block. This is the block that is 10 kg. Force is acting over here T1 and acceleration of this block is 2 meter per second square. Whatever is the acceleration of the entire system, same is the acceleration of this block, this block, this block, because this is a connected block. Now, we say use Newton's second law. Net force is equal to mass into acceleration. Net force is equal to T1. Mass in this case is 10. Acceleration is 2. So that is going to be 10 into 2 is 20 Newton. Done. Okay, let's find the tension T2. Take any block over here. Let's take 6 kg block. This is 6 kg block. In the forward direction, it is T2. In the backward direction, it is T1. Now, guys, tell me, acceleration of this block is 2. Use net force is equal to mass into acceleration. Net force is T2 minus T1. T2 minus T1 is equal to net force, mass into acceleration. Mass is 6 into 2. T1 is 20. So T2 minus 20 is equal to 12. So 20 plus 12, that is 32. T2 will come out to be 32 Newton. I hope this is clear. Okay. Find the value of T dash in the string. See guys. When it comes to the pulley, see this is the pulley. From this side we say, let's suppose we are pulling it with a force 5 Newton. From the upper side we are pulling it with the force T dash. Okay, T dash. From the lower side it is 5 Newton, 5 Newton. Always remember, whatever is the force on upper side will be equals to the force on lower side. Okay, like this T dash will be equals to this force plus this force. That is 5 plus 5 is, we can say over here in this particular case 10 Newton. Okay, or you can say simply guys, this is T, this is T. Okay, so this T plus T will be equals to this T dash. 2T is equal to this T dash. So T dash will come out to be 5 plus 5 is 10 Newton. In this case, what is the value of T dash? 10 plus 10 is 20 Newton. In this case, what is the value of T dash? That is 40 Newton. Okay, that's it. That's it. Like you have got this question. A force is applied on this block. Okay, see guys, this is holding it with the tension T. We are supposed to find the force applied by the man to hold the block. How much force means you are supposed to find the tension. How much force this man is applying so that it is holding the block. See, this is tension T. This is tension T over here. Okay. Okay. And here it is tension T. 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 T and T. Now tell me, if this is T, this is T. T plus T is 2T. So in the upward force, downward force, this is 2T. T plus T is 2T, upward force, downward force, this is 2T. And here also it is T. 2T plus 2T plus T, that is 5T. And here in the downward direction, M into G, that is 10 into 10, that is 100 Newton. If we take this block, in the downward direction, it is 100 Newton. In the upward direction, it is 5T. Can we balance it? So we say 5T will be equals to 100 Newton. T will be equals to 100 divided by 5, that is 20. So this person has to apply 20 Newton of force, then it can hold this particular block. Then it can hold this particular block. You have got the spring force. You have got the spring force. Now guys, take a look. Take a look. You have got the spring force. Let's suppose in this particular case, you have a block over here, and in this particular case, there is a spring connected to this block. Now, if you extend this block, okay, if you elongate this block, if you elongate the spring over here with a displacement x, we know that this spring will create a restoring force. It will pull the block back to the original position. Okay, this restoring force is what we call the spring force. If you elongate the block, the force created by the spring in order to restore it is what we call the restoring force. So if we elongate the spring here, a force will be developed in it called spring force. And this spring force is equal to K times of X. This spring force is equal to K times of X. Okay. Now guys, if you elongate more, we say spring will create more restoring force. That's why we say F is proportional to, we say minus X. If displacement is done in this direction, force will be opposite to it. That's why you have got negative sign. More is the displacement, more will be force. Okay, where K is the spring constant. K is the spring constant. Okay. Okay. Now guys, listen to me very carefully in this particular case. Let's suppose you have a spring connected over here and this is the mass. What is the force acting on this mass in the downward direction? That is mg. Now due to this force, we say spring will create the restoring force in the upward direction. That spring force will be K times of X. Now at equilibrium, don't you think this downward force will be equal to upward force? K times of equal X will be equals to mg. So X will be equals to, this X is the elongation in the spring. That is mg divided by K. Yes. Next, let's suppose this one. Find the reading of a spring balance and extension in the spring. See guys, in this spring, what is the force which is created? K times of X. Now in the downward direction, you have tension T. Here you have tension T. Here you have tension T. Same tension. And when it comes to this particular block, you have 5. In the downward direction, 50 Newton. Let's first find the tension. Can I say tension in this case will be upward force is equal to downward force. It is not moving, it's at rest. Tension will be equals to 50 Newton. Yes. If this is 50, this will be 50. Tension in the string. Here also it will be 50. Same tension. Now guys, this 50 plus, I say T plus T is 2T. Downward force is equal to upward force. K times of X is equal to 2T. Okay. Now K, spring constant, is given as 200. Into X is given as 2 into tension is given as 50. 2 into 50 is 100. So 200 into X is equal to 100. This and this will cancel. X will be equals to 1 by 2. That's what we were supposed to calculate. Find the extension in the string, 0.5 meters. 1 by 2, not 2. 0.5 meters. Extension in the spring. Simple, simple. Okay. Pseudo force. Guys, let's take a look here. If there is a person which is at rest, okay, and you see, you have placed a block over here. I'll give you the feel of pseudo force. See guys, if you have placed a block over here, okay, this is the block. Okay, this block is at rest. Now guys, there is a person which is exactly at rest, Now, if I ask this particular person, is that block moving or at rest? This person is saying that block is at rest. I can see it. Now, if I ask this person, which is moving with some velocity, constant velocity, is that block at rest or moving? Now, how many of you have imagined that you are moving in the car? And when you look out of the window, you feel that the trees are moving, the trees are coming towards you. But in reality, you are moving, the trees are at rest. Same is the case here. This person feels like the block is coming towards him, but in reality, only this person is in motion. So with respect to this, it is in the motion. Similarly, if this is the person which is moving with an acceleration, velocity is not constant. If I ask this, is that block in motion or at rest? This person will also say, this block is moving with an acceleration A, with an acceleration A. Why? Because this person himself has the acceleration A. This person is saying it has got the constant velocity V. Whenever, this is the observer right now, who is observing that block. Whenever observer has an acceleration, it is called non-inertial frame. Non-inertial frame means when observer is in the accelerated frame. Inertial frame means when observer is in the, we say, when observer has either it is at rest or it is moving with the constant velocity. When observer is moving with the constant velocity or it is at rest, it is called inertial frame. Non-inertial frame means when observer is moving with a constant, is moving with an acceleration. Now see, with respect to this person, it has got an acceleration, and we know, sir, acceleration is force divided by mass. If there is a acceleration or anybody has acceleration, means force is acting on that body. If a body has acceleration, means force is acting on this. So we say here force is acting on this body, that is F. Sir, in reality, does this body has acceleration? No. This is the fake acceleration. So according to this person who is in the non-inertial frame, this block has acceleration. If this block has fake acceleration, means fake force is acting on this one. This force, so we say when observer is in non-inertial frame, pseudo force acts on the body. When observer is in the non-inertial frame, we say pseudo force acts on the body. Okay, so that pseudo force itself is called mass into acceleration. Now, if I say, sir, according to this person, is there any acceleration of this block? No. If there is no acceleration, there is no force. But according to this person, we say this has the acceleration because he is feeling like he's getting that feeling. He gets that feeling. So that's why we say it's fake acceleration. So fake force, that is called pseudo force. Okay. Yes. So when does the pseudo force act? Pseudo force acts when the observer is in the non-inertial frame. Now see, this is the person C which is at rest. This is the person which is at rest. Okay. Now if I say this is the lift. Lift is going up with an acceleration A. There is a block in this and this is the person A. This is the person A, this is the person B. If I ask this person B, tell me, what is the normal reaction acting on this block? He is saying, sir, normal reaction is N in the downward direction mg. According to this person, guys, listen to me very carefully, which is at rest in the inertial frame. He is saying, sir, upward force, net force. He is applying the Newton's second law. What does that say? Net force is mass into acceleration. Net force is N minus mg is equal to mass into acceleration. Mass is m, acceleration is. He is saying, sir, N is equal to MA plus M. Okay. Normal reaction according to this person is MA plus MG. But if I ask this person A, what is the normal reaction acting on this? He himself is inside the lift. He is saying, I don't feel like the lift is in the motion. Block is in front of me. Block is in at rest. So he is saying, according to this person A, N is equal to mg. Upward force is equal to downward force. But this person said, if it is in motion, upward force minus downward force is equal to mass into acceleration. But he is saying block is at rest. So N is equal to mg. Which one is correct? That one or this one? Now guys, listen to me very carefully. So when we talk from its frame, okay, listen to me very carefully. We apply pseudo force. Why? Because this person is in the accelerated frame, non-inertial frame. When the observer is in the non-inertial frame, okay, pseudo force acts on the block. So pseudo force I will act on this block in the opposite direction, that is MA. Now tell me, according to this person, upward force is equal to downward force. N is equal to upward force, downward force, that is mg plus ma. Now see, answer is coming out to be exactly same. If you solve from the inertial frame perspective, if you solve from the non-inertial frame perspective, answer in both the cases will come out to be the same. Okay, I hope this is crystal and clear. Okay, I hope this is crystal and clear. Now guys, find the pseudo force on the block. This person is in the accelerated frame. This block cart has got the acceleration of 3 meter per second square. So it is forward. So on this block, we say pseudo force will act in the backward direction. Okay, we say this pseudo force will be mass into acceleration, simply backward, opposite. Whatever is the acceleration of the person, opposite to that will be of the block. Mass is 5, acceleration is 3. 5 into 3 is 15 meter per second square. I hope you are getting me what I am trying to say. So basically, whenever the observer is in the non-inertial frame, in that case, you need to apply the pseudo force. Like here, when observer was in the non-inertial frame, we applied the pseudo force on the block in the opposite direction. That's it. That's it. Then you got the exact value as according to the person B, this was the answer. Then you are getting the exact value. Otherwise, this is not the answer. Okay. So next chapter is going to be the friction. So we'll no. Let's not take friction. Let's take this chapter. Let's take center of mass next chapter. But let's keep the break till 1:20. Is that okay? Okay, guys, let's move further and let's discuss the center of mass. Let's discuss the center of mass. Now, guys, listen to me very carefully. When it comes to the concept center of mass, we say, let's suppose if I have this body over here, if I want to hold this body at one point, sir, will that be here? No, 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 no. Will that be here? No, no. That would be somewhere around at the center, okay? So we consider that point as the center of mass, okay? It is that point where whole mass of the body is supposed to be concentrated. That is called the center of mass, okay? Okay, okay. So basically, if we have to hold a body, if we have to hold that body, hold a body at one point, it will be the center of mass, okay? So we say it would be around at the center over here, okay? Now, my dear friends, listen to me very carefully. Let's suppose if I say in this particular case, you have a body, you are applying a force on this particular body, okay? In this particular case, if you are applying the force at this point 1, okay, then you write F is equal to force is equal to mass into acceleration. In this case, we consider acceleration of center of mass, okay? It is basically the acceleration of center of mass, okay? I hope this is crystalline clear. Like, if you have an object over here, okay? And if this object is moving, if you have to write its kinetic energy, you say 1 by 2 mv square, velocity of what? Center of mass. It is not, you are not writing this point, you are taking the velocity of center of mass. So, in nutshell, when it comes to the center of mass, it is that point where whole mass of the body is supposed to be concentrated. That's it. That is the point. Okay. Now, center of mass of a body can be inside or outside the body. Like, if let's suppose you have got this object over here, something like this. Okay. Now, in this particular case, this is the axis of symmetry. This is the axis of symmetry. Okay. Which is cutting it something like this vertically, which is cutting it something like this vertically. Okay. So we are saying in this particular case, we are assuming the center of mass somewhere around exactly over here. Okay. If this is a ring, we are assuming somewhere around over here. Center of mass lies near to the heavier object. Like if you check over here, from this side, mass is more. So center of mass would be around over here. Okay. For the square object, we consider the center of mass at the center. Now, guys, since when it comes to the idea of center of mass that I have given you, okay, now what is the exact point that we need to understand? That is location of center of mass, where the center of mass is exactly present. See guys, let's suppose you have two objects, M1 and M2, okay? And if I make over here, this is the x-axis, y-axis, with respect to the origin, this is at R1 distance, this is at R2, this unit vector R1, this is the R2. Okay. Now, this is the position vector, it's not unit vector, this is the position vector, this is the position vector. Now, my dear friends, if I am saying, sir, these two masses, like this was the center of mass for the body. Similarly, if you have two discrete masses, how can you find the center of mass between the two discrete masses? So you will be saying, sir, when it comes to the center of mass, RCOM, this is the position vector of center of mass. This will be M1 R1, this M1 R1 plus M2 R2 upon M1 plus M2. This is going to be the location of center of mass or the position of center of mass. If you have to find the x-coordinate of center of mass, M1 x1, x1 is the x-coordinate of center of mass. Okay, M1 x1. Okay, then we say M2 x2 upon M1 plus M2. If you have to find the y-coordinate of center of mass, like guys, what is the x-coordinate of this mass? X, y is y1, z coordinate is z1, x2, y2, z2. Similarly, X coordinate of center of mass, Y coordinate of center of mass, Z coordinate of center of mass. So it is going to be m1y1 plus m2y2 upon m1 plus m2. Z coordinate is going to be m1z1 plus m2z2 upon m1 plus m2. Okay. Like you have a question exactly over here. In this particular case, if you have to find over here the center of mass, if you have to find over here the center of mass, take a look in this particular case. Find the position of center of mass. One object is placed over here, another object is placed at this point, another object is placed at this point, another object is placed at this point. And if you are supposed to find the center of mass, RCOM, okay, position of center of mass, what will you say? Sir, position of center of mass. You'll say, sir, that is M1R1 plus M2R2, okay, then plus M3R3, then plus we say M4R4. This is how we are supposed to find out. Now, guys, upon you say M1 plus M2 plus you say M3 plus you say M4. Now, when it comes to RCOM, my dear friends, listen to me very carefully. RCOM. Now, this is exactly placed at origin. We say its position vector will be 0. So, we say 2, M1 is 2 and this is going to be 0. Then we say plus. When it comes to this object, guys, its x coordinate is 10, y coordinate is 0. So I can write this is M2, M2 is 4. And when it comes to its x coordinate, that is going to be 10 I cap, okay? I cap means, sir, it is at what position when it comes to the x-axis, sir, at 10. Then we say plus. When it comes to this one, you say, sir, it is going to be 16 M3 into R3. That is going to be 10 I cap plus 10 J cap, 10 I cap plus 10 J cap. Okay, then we say plus M4 R4. M4 is going to be the 8 and radius vector. How do you write the radius vector of this one? It is given only y coordinate, x coordinate in this case is 0. Okay, so it is going to be 10 J cap divided by we say M1 plus M2, that is 2 plus 4 plus 16 plus 8. Okay, now you just have to solve this. That's it. We say 4 into 10 is 40 I cap. 16 into 10, 160 I cap. 16 into 10, 160 J cap, 80 J cap. Okay, then accordingly you guys solve it and you'll get the correct answer in this particular case. Okay, I hope you guys will do it. Okay, because it is not that complicated. Simply, this is 40 I cap plus 160 I cap, then plus 80 J cap. Okay, do the addition. Okay, then you will finally get the answer. Okay, then my dear friends, let's move on to this one. We say if the position vector of three particles M1, M2 and M3 are given as, this is the position vector of first particle, this is R1. This is position vector of second particle R2. This is the position of third particle R3. Again, you guys are supposed to tell me, find the position vector of center of mass. CRCOM, you guys are supposed to find out. It is not mentioned, I'll directly write. How can we find that? You guys will be writing M1R1 again. What is the value of M1? Value of M1 is given as 3 kg. So this is 3 kg. R1, that is I plus J plus I can say K cap. Okay. Then I can say plus. M2R2. M2 in this particular case is given as 2 and R2 in this case is given as 2I cap plus 3J cap plus I would say K cap. Then I say plus M3R3. M3 is given as 5. Then I say in this particular case I minus J plus K. Simple calculation. Then I say R1 plus R2 plus R3. R1 is given as, that is 3 plus 2 plus I can say 5. Just the simple calculation over here. When it comes to RCOM, so what will you say? This is 3i cap plus 3j cap plus 3k cap. Similarly, 2j cap plus 2 3s are 6j cap. Then do the addition and then solve it. Tell me quickly in the chats, is this clear? Is this clear, everyone, guys? Let me know in the chats, is this crystalline clear to each and every single student? Is this clear? Let's move on to the next one. What about this? What about this? What is the position of center of mass from 4 kg in the given arrangement? This 4 kg mass is present as 0, 0, and this mass is present at, this is 8 meters, okay? This mass is present at minus 12, this is present at minus 22. Okay. Now see guys, in this particular case, if you have to find, listen to me very carefully. Guys, all the masses are present at x-axis. Don't you think that we can find, don't you think in this case we can find the XCOM, x coordinate of center of mass? That is going to be, sir, m1 x1 plus I can say m2 x2, then I can say m3 x3, then I can say m4 x4. Okay, then I would write over here m1 plus I would say m2 plus m3, then I would say plus m4. Now XCOM, why am I finding the x coordinate of center of mass only? Because all the masses are present on x-axis only. m1 x1, guys, this is the first mass. So I would say 4 into 0, it is present at 0. Then we say plus. Let's talk about this mass. This, which is 3 kg. 3 kg is present at how much distance? 8 meters. So 3 into 8. Okay, then we say plus. This is present at what distance? Minus 12. So we say 2 into minus 12. Then plus. This is present at what distance? 10 plus 12, that is minus 22. Because from this side it is minus. So it is going to be 6 into minus 22. Then upon m1 plus m2 plus m3 plus m4. 6 kg plus 2 kg plus 4 kg plus 3 kg. Okay, just the calculation, solve it, and you will get the x coordinate of center of mass. I hope this is crystal and clear how we are finding the center of mass of a body. So what did I say? Center of mass is defined as that point where whole mass of the system is concentrated. Okay. Now guys, there is a concept that is what we call, listen to me very carefully. There is a concept that is what we call shift in the center of mass. Listen to me very carefully. Let's suppose this is the, guys, this is y-axis, this is x-axis. This is mass m1, this is mass m2. This is the position vector of r1, this is the position vector r2. If I say simply, sir, what is the center of mass for these two objects? You would say, sir, the position of center of mass is m1 r1 plus m2 r2 upon m1 plus m2. Okay. This is the position of center of mass for these two objects. Okay, this is the position of center of mass for these two objects. Now guys, we say if we shift m1 and m2, if we shift this m1 and m2 from their position, don't you think if we shift them, so we say center of mass will also shift. If you are shifting the mass from one point to another, center of mass will also shift. Yes. Now see, guys, shift in the center of mass. How much center of mass will shift? That is m1 delta r1 plus m2 delta r2 upon m1 plus m2. What is delta r1? Where delta r1 and delta r2 is the shift in the mass m1 and shift in the mass m2. How much this you will shift, how much you will shift this one, that is going to be delta r1 and delta r2. Okay. Now, guys, one more important thing. Center of mass of continuous mass system. Now, previously I was saying discrete masses. Sir, you have got M1 mass, you have got M2 mass. Tell me where is the center of mass? I told you X coordinate, Y coordinate, Z coordinate, or directly position vector. But when you have a continuous body, this is a disk, this is a disk. Where will be its center of mass? This is a rod. Where is going to be its center of mass? This is a sheet. Where is going to be its center of mass? This is the sphere. Where is going to be its center of mass? Here, mass is distributed in length, area, and volume. Length, area, and volume. See, guys, if you have a body in which mass is distributed, what you guys are supposed to do is that, understand this very carefully. Take a small element, small dm mass, which is very small, point mass, okay? Then check its distance from the origin. This is the position vector, okay? Now, guys, listen to me very carefully. Listen to me very carefully. Now, once we do this, let's take a small dm mass and find its moment. Then find its moment of mass. Okay. Now, my dear friends, listen to me very carefully. Listen to me very carefully. Do one thing. Let's take one more small dm point mass. Okay, let's check its position vector. Let's check one more point mass. Let's check its position vector. Okay. Now, guys, in this particular case, don't you think that, guys, we can use that particular formula. dm multiplied by r is the moment of mass of this. Okay, dm multiplied by r. It is like m1 r1. If you take another one, m2 r2. If you take another one, m3 r3, that is dm into r plus dm into r plus dm into r up to infinity, plus divided by dm plus dm plus dm plus dm. This is the approach that we use over here. This will give us the center of mass of a continuous body. Now, guys, if you keep on adding these, don't you think I can write it something like this? This is integration of r dm. Guys, if you keep on adding these up to infinity, so it is integration of r dm upon integration of dm. This is how we find the center of mass of a continuous body. Okay, this is the approach that we use. Okay, this is the position of center of mass in case of a continuous body. Now, if I say x coordinate here, that is integration of x dm upon integration of dm. Y coordinate, that is going to be integration of y dm upon integration of dm. Z coordinate, integration of z dm upon integration of dm. So in case of a continuous body, this will give us the position of center of mass of x coordinate of center of mass, y coordinate of center of mass, z coordinate of center of mass. Yes. Now take a look. Let's suppose you have example. This is a rod. Okay, this is a rod. Okay. Mass of the rod is m, length of the rod is l. Okay. In this particular case, this rod is placed something like this on the x-axis. So we will find its center of mass, its x coordinate only. Why? Because the rod is present on the x-axis only. Now what will you say? Use this formula, integration x dm upon integration dm. So here x and guys, you can see this particular process from your end. I will be directly showing you. See. Center of mass came out to be at L by 2, means exactly at the center. 0.5 L. Using this approach, center of mass of the rod came out to be at its center. Now, guys, listen. Center of mass of variable mass system. Very important. I want you to understand this very carefully. Center of mass of variable mass system. What does center of mass of variable mass system mean? See. In the previous case, mass is constant. The amount of mass present at unit length here is the amount of mass present at unit length here. At every point, same mass is present. Okay. But here, from this end to this end, I am saying lambda is proportional to x. Lambda is proportional. Lambda is mass per unit length. Mass per unit length. Okay, mass per unit length. Okay, so lambda is proportional to x in this particular case. As you move towards right, we say its mass increases. Its mass increases. Mass is not constant in this case. Guys, what I want you to understand is, if lambda is proportional to x, in that particular case, directly remember, if lambda is proportional to x, guys, directly, if lambda is proportional to x, in that particular case, center of mass will be at 0.66 L or 2L by 3. What did I say? If you have a rod in which lambda is constant, mass is not changing, lambda is constant, we say its center of mass will be at center L by 2. If you have a rod in which lambda is proportional to x, in that case, XCOM is going to be, that is 2L divided by 3, 0.66 L. Next, if in a rod, lambda is proportional to x square, center of mass will be at 0.75 L. Directly remember. If lambda is proportional to x cube, center of mass is going to be at 0.5 L. Directly remember. When it comes to x cube, 0.5 L, x square, 0.75 L, lambda is proportional to x, 0.6 L, lambda is constant, 0.5 L. Is this clear? Please tell me in the chats. Approach is here. You guys can use this formula and you will get the answer. Now tell me the answer of this question. This is a previous year question. See, in this, the density of a thin rod, okay, linear mass density, lambda is linear mass density. Okay, mass per unit area, sorry, mass per unit length. On unit length, how much mass is present? Okay, now see, in this particular case, can I say lambda is proportional to x square? Yes. If lambda is proportional to x square, I want you to understand this particular thing. Can I say when it comes to the center of mass, XCOM, this will be at 0.75 L? Yes. Directly, this is going to be the answer. Why? Because lambda is lambda naught divided by L square, and then you have x square over here. So center of mass will be at 0.75 L. Okay. Yes. Okay, what about this one? You have a question. Find the location of center of mass. You have a rod placed something like this. You have a rod placed something like this. You have a rod placed something like this. We are assuming the center of mass of this rod here, center of mass of this rod here, center of mass of this rod here. What is the location of the center of mass of this entire system? See. Guys, when it comes to RCOM, how do you write? M1 R1. Mass of this rod is M. R1. Okay, guys. We say this is present on x-axis. Its center of mass is at what distance from the origin? Sir, it is at L by 2. So I'll write L by 2 into I cap. M1 R1. And Y component is 0. When it comes to this one, it is present here at x is equal to 0. Its x coordinate is 0. Y coordinate is L by 2. Then we say plus M. And then we say L divided by 2 J cap. Then we say plus. When it comes to this rod, its mass is also M. And here, it is at what distance from the origin when it comes to the x-axis? L by 2. This distance is L. So this is L by 2 I cap plus LJ cap. And then you say M plus M, that is going to be 3M. So this M will cancel. So RCOM, it is going to be L by 2I plus L by 2J plus L by 2I. L by 2I plus L by 2I, it is going to be Li. L by 2 plus L by 2 is L. Then we say plus L by 2J plus L. That is 2L plus L. That is 3L divided by 2J. Then whole divided by this 3. Okay. Now, what can you say? This 3 and 3 will cancel. So this 3 will come over here in divide. Okay. You can write it like this. See guys, you can write it like this. L divided by 3I plus L divided by 2J. This is the position of center of mass when it comes to this system. Okay. Now guys, take a look. Center of mass of an arc. Let's suppose arc, when it comes to the arc, see. You have got a complete circle. This is the semicircle. This is a chord. If I say this portion of the circle, this is called the arc. This is called the arc. And this is the center. This is the radius. This is the radius. Guys. Its center of mass will lie on the y-axis. It will lie on the y-axis. If you draw this, it will lie on the y-axis. And its y-coordinate of the center of mass will be r. R is the radius. Sine theta by 2. Theta is the angle between this radius and this radius upon theta by 2. That's it. That's it. That's it. Okay. Then, if you take a look, center of mass of a semicircular ring. If you have got semicircular ring over here, this is a semicircular ring. This x-axis, this is y-axis. Okay, guys. You can use this particular formula, general formula. So for semicircular ring, what is the angle between this radius and radius? That is 180. So this is 180. So means pi. So r sine 180 by 2 or pi divided by 2. Sine pi by 2 is sine 90. That is 1. So sine 90 is 1. So it will r by 2. So take this in the numerator, 2r by pi. So this is the position of center of mass. That is 2r by pi. Y coordinate. X coordinate is 0 because it will be somewhere around over here. Next, center of mass of a complete ring. This is a complete ring. Center of mass will be exactly at the center. So if you are drawing the x-axis and y-axis, so it will be at the origin. So x center of mass is 0, y center of mass is 0. Even you can use this formula also, you'll get it 0. Okay. Center of mass of uniform semi-disk. Okay. Guys, axiom will be 0. Its center of mass would be somewhere around over here. That is 4r by pi. 4r by pi on y-axis. Center of mass of hollow sphere. Center of mass of hollow hemisphere. It is a hollow hemisphere. Okay. Center of mass of hollow hemisphere. Hollow hemisphere. In this particular case, we say over here, YCOM is going to be r by 2. Okay, YCOM is going to be r by 2. Okay, so if this is a hollow hemisphere, cap, so we say on the y-axis somewhere around over here, r by 2, and XCOM is going to be 0. X coordinate of center of mass is 0. YCM is going to be r by 2, where r is the radius. Center of mass of solid hemisphere, it is going to be at what distance? We say 3r by 8. And x coordinate is 0. Why? Because it is exactly on y-axis. Next, center of mass of hollow cone. So it is a hollow cone. So h is the height of the hollow cone. It will be exactly at h by 3. Y coordinate. X coordinate is 0. Center of mass of solid cone. It will be at h by 4. It will be at h by 4. Y x coordinate is 0. Velocity of center of mass. Guys, take a look. Take a look. If I say in this particular case, take a look over here. We say there is a mass m1 which is moving with a velocity v1. There is a mass m2 which is moving with a velocity v2. Don't you think that in this particular case, if the two masses are moving, their center of mass will be also in motion? So v1 is the velocity of this mass, v2 is the velocity of this mass. Velocity of center of mass is VCOM. So VCOM is going to be m1 v1 plus m2 v2 upon m1 plus m2. So if the two masses remain stationary, center of mass is stationary. If the two masses move, center of mass moves. Okay. Now guys, let's take a look at this particular question. Here they are saying, find the velocity of center of mass. This is m1, this is v1, this is v2. Now, how do you find the velocity of center of mass? What is the formula? That is m1 v1 plus m2 v2 upon, we say, m1 plus, we say, m2. So velocity of center of mass is going to be m1 v1. m1 in this particular case is, this is m. Okay. v1 in this particular case is how much? This is 2. And 2 in the x direction. So this is 2i cap. Then plus m into, how much is that? 2j cap upon m1 plus m2. That is m plus m. That is 2m. M will cancel. 2i cap plus 2j cap divided by 2. Okay. So VCOM in this particular case, I can say in this particular case, this is 2 into I plus j cap. Okay. Divided by 2. This and this will cancel. So this will come out to be I plus j cap. Yes. Now, this is the velocity of center of mass. Even you can find the magnitude also. So that is under root of 1 square plus 1 square, because I cap plus j cap. So that is going to be root 2. That is going to be root 2. That is going to be root 2. I hope velocity of center of mass is also clear. Now take a look. Acceleration of center of mass. See guys, if you have m1 mass, it is having the acceleration a1. If you have m2 mass, it is having the acceleration a2. Okay. If the two masses are having the acceleration a1 and a2, then we say center of mass will also have the acceleration. ACOM is going to be m1a1 plus m2a2 upon m1 plus m2. Okay. Now guys, we say force is equal to mass into acceleration. So m1a1, can I write it as f1? Yes. m2a2, can I write it as f2? So we can write it something like this also. That is f1 plus f2 upon, we can say m1 plus m2. Okay. Now take a look at this particular question that we have. Three particles, 1 kg, 2 kg, 3 kg are subjected to forces. This force, this force, this force. Then find the magnitude of acceleration of center of mass of the system. Guys, acceleration of center of mass. In terms of force, what did we study? F1 plus F2 upon M1 plus M2. So I can say this is F1 plus F2 plus I can say F3 upon M1 plus M2 plus I can say M3. Now tell me, F1 plus F2 plus F3 in this particular case, guys. This force plus this force plus this force, direct addition. See, 3i cap minus I cap, that is 2i cap. Okay. Then we say 3i cap, okay. 3i cap plus I cap is equal to 4i cap minus I cap, that is 3i cap. So 3i cap is net. Then we say, because if we directly write it here, then we write this here, then we write this here. We have to do the addition subtraction. I'm doing it here only. Then I say minus 2j cap plus 2j cap. Minus 2j plus 2j. Then we say this plus j. Okay, I with I, j with j, k with k. Okay, this and this will cancel, plus j cap. Then plus 2k cap minus k cap. 2k cap minus k cap. Then we say plus k cap. This and this will cancel, plus 2k cap. Plus 2k cap upon m1 plus m2 plus m3. 3 plus 2 plus 1. That is 3 plus 2 is 5. That is 6. That is 6. So this is going to be the acceleration of center of mass in this particular case. Okay. This is going to be the acceleration of center of mass in this particular case. Is that clear? Even you can find the magnitude also, that is under root of 3 square plus 1 square plus 2 square divided by this. Now, let's take a look at this. Two particles of mass 1 kg and 3 kg are having the acceleration this and this. Find the acceleration of center of mass. Again, simple. ACOM, that is M1A1 plus M2A2 upon M1 plus M2. Just apply, put the values and get the answer. Okay, now guys, listen to me very carefully. If let's suppose you have a system something like this, okay, this is a pulley, this is a mass M1 attached, this is a mass M2 attached, okay. In this particular case, if I am saying in this particular system, what is going to be the acceleration of center of mass? You directly remember this, we don't have to derive it. Acceleration of center of mass is m2 minus m1 upon m2 plus m1 whole square into g. This will be the acceleration of center of mass, because you have two masses, they will be having the center of mass also. So this is going to be the acceleration of center of mass. If you have a system something like this, this is placed on box, its acceleration is a1, its acceleration is a2, m1, m2. Okay. In this case, if they ask you to find the acceleration of center of mass of this system, m2 into g, okay, m2 into g upon m1 plus m2 whole square, then we say m1 into I cap minus m2 into j cap. So directly remember these formulas in order to find the acceleration of center of mass. Okay. Okay, what about this question? What about this question? A ball is thrown upwards. Okay, there is a ball which is thrown upwards. And another ball is thrown downwards of same mass. Okay. Find the acceleration of the center of mass. Okay. It is thrown upwards. What is its acceleration? That is minus g. It is thrown downwards. What is its acceleration? Minus g. Because we always take acceleration as minus g. Now tell me guys. And it is in y direction, so it is j cap. It is j cap. So we know a1, we know a2. Let's find the acceleration of center of mass. That is m1a1 plus m2a2 upon m1 plus we say m2. m1, that is m. a1, that is g into j cap plus m into g into j cap divided by 2m. Okay, this will cancel. So this is gj cap, so 2 times gj cap upon 2. This and this will cancel, so gj cap. You can write it something like this. This is the acceleration of center of mass. Even if you put the negative sign along, then you have to put negative here also. Let's move on to the collisions portion. Is this clear till over here? Guys, give me the signal in the chats first. Whosoever is watching, I want you guys to tell me in the chats if everything is crystalline clear. Let me know in the chats if everything is crystalline clear. Now, guys, take a look. Collisions. Understand this very carefully. Collisions. Understand this very carefully. It is the interaction between two or more than two objects, okay, in which no external force acts. So momentum of the system is always conserved. Like if you have one mass over here, it is moving with a velocity u1. You have m2, it is moving with a velocity u2. If they collide, okay, if they collide, okay, collision takes place. After, this is before the collision. After the collision, m1 moves with a velocity v1, m2 moves with a velocity v2. Okay. We say this is the case of collision when two bodies collide. Here, no doubt they are applying these two forces, F21 and F12 on each other, but these are the internal forces. Now, guys, always remember, we say, what is the momentum before the collision? M1 U1. M1 U1 is the momentum of this one, mass into velocity, plus M2 U2. Same will be the momentum after the collision, M1 V1 plus M2 V2. Okay, momentum before the collision, momentum after the collision. Okay. Now, guys, in this particular case, I want you to understand this point also. We say momentum of the system is always conserved. Okay, before the collision, after the collision, at the time of collision. Okay. And my dear friends, relative velocity of approach. How do you define relative velocity? Guys, this velocity minus this velocity, VA minus VB, that is relative velocity. And if they are approaching, this is what we call the relative velocity of approach, V1 minus U1 minus U2. Then we say relative velocity of separation. Okay, that is going to be V2 minus V1. That is going to be V2 minus V1. Okay, V2 minus V1. Okay. And in this particular case, guys, divide the two equations, V2 minus V1 divided by U2 minus V1. We say it is E. E is what we call the coefficient of restitution. Coefficient of restitution is simply velocity of separation divided by velocity of approach. That's it. Now, how many types of collision are there? There are three types of collision. Elastic collision. First, we talk about the elastic collision. It is that collision after which two objects regain its shape, size, etc. It also regains its kinetic energy, which was converted to potential during the time of collision. Means whatever is the kinetic energy before the collision, after the collision, kinetic energy will be regained. It will be same. And for elastic collision, we say value of E is 1. Coefficient of restitution is 1. Okay. If coefficient of restitution is 1, we can say velocity of separation becomes equal to the velocity of approach. Why? Because this divided by this is equal to E. If you put E is equal to 1, so this term will be equal to this term. Kinetic energy before the collision will be equals to the kinetic energy after the collision. Kinetic energy remains conserved. Keep this thing in your mind. Momentum is always conserved. Momentum before the collision is equal to momentum after the collision. Okay. Now, guys, let's suppose if somebody says, sir, elastic collision is taking place. Sir, before the collision, velocity of mass is u1, velocity of this mass is u2. Find the velocity of the mass after the collision, v1 and v2. This you need to remember. Value of v1 is m1 minus m2 into u1 divided by m1 plus m2 plus 2 times of m2 u2 upon m1 plus m2. This is the velocity of the body after the collision in case of elastic collision. Then you say this is the velocity v2. This is the velocity v2. Okay, you can write it down. These are the expressions that you guys need to remember. Then you have the inelastic collisions. We say it is that collision in which an object does not regain its kinetic energy. At the time of collision, deformation takes place. Due to which kinetic energy is changed to potential energy. After deformation, masses does not regain to their original size and shape. So when collision takes place, the two bodies will not regain their shape. See, the shape, it is deformed, it is deformed. But when it comes to the elastic collision, we say the two bodies exactly regain their shape, size, everything like it was before. This is the difference between elastic and inelastic collision. Inelastic collision. Okay. Now, guys, when it comes to the inelastic collision, guys, we say value of E is greater than 0, less than 1. Okay. And one more important thing, my dear friends, momentum is conserved here also. Okay, because net external force is 0, so momentum is conserved. So now, guys, see. If the value of E is 0.5, it can be greater than 0, less than 1. Then in that case, V2 minus V1 will be equal to half of U1 minus U2. Then in that case, we say velocity of separation will be less than velocity of approach. Why? Velocity of separation is 1/2 of velocity of approach. Then in that particular case, we say kinetic energy final is less than kinetic energy initial, means kinetic energy is lost in the compression or deformation. Okay. So what I'm trying to say, if E is 0.5, this velocity becomes less than this velocity. Separation velocity becomes less than approach velocity. So obviously, final kinetic energy will be less than initial kinetic energy. Why? Because if the two bodies are colliding inelastically, they lost the energy in deformation here. So that energy is lost. So after the collision, energy is lost. Okay. And guys, in case of inelastic collision, if somebody says, I want you to understand, what is the velocity of the body after the collision? What is the velocity of the mass 1 after the collision? m1 minus E times of m2 upon m1 plus m2 into u1. Then we say E plus 1 into m2 into u2 upon m1 plus m2. u2 is the velocity of the second mass. Similarly, velocity of the second mass after the collision, m2 minus E times of m1 into u2 upon m1 plus m2 plus E plus 1 m1 u1 upon m1 plus m2. Okay. Then you have got perfectly inelastic collision. It is that collision. Guys, I hope you remember this expression. This is very important. This is the velocity of mass 1 after the inelastic collision. This is the velocity of mass 2 after the inelastic collision. Then when it comes to the perfectly inelastic collision, it is that collision in which a body stick to each other after the collision. Like this and this, when they are colliding, after the collision, the two bodies stick to each other, then move with a common velocity. Okay. Here, in this case, coefficient of restitution E is 0. If E is 0 in this particular case, take it over here. This term will become 0. So V2 will be equals to U1. V1 will be equals to V. Both will have the same velocity afterwards. And in this case, kinetic energy is not conserved. Momentum is conserved. Momentum is always conserved. Okay. Now. If I ask you to find out the combined velocity, how much is the combined velocity after the collision? You say that is m1 u1 plus m2 u2 upon m1 plus m2. Simply. This is going to be the velocity after the collision. Now, guys, loss in kinetic energy. In case of elastic collision, we say body regains to its original shape. So kinetic energy initial is equal to kinetic energy final. There is zero loss in kinetic energy. When it comes to the inelastic collision, directly remember, sir, kinetic energy is lost. Why? Because body is deformed. So loss in kinetic energy is 1 by 2 m1 m2 upon m1 plus m2. Then we say u relative square. Then we say 1 minus e square. U relative is initial velocity u1 minus initial velocity u2 of mass 2. Okay. Then perfectly inelastic. When it comes to the perfectly inelastic, we say loss in kinetic energy is 1 by 2 m1 m2 upon m1 plus m2 u relative square. This is in case of perfectly inelastic. This is in case of inelastic. And in case of elastic, there is no loss in the kinetic energy. Like you have two masses 4 kg and 8 kg collide with each other, and collision is perfectly inelastic. Collision is perfectly inelastic. If collision is perfectly inelastic, then find the velocities of the masses after the collision. If collision is perfectly inelastic, okay, this collision, velocity of the combined masses after the collision, m1 u1 plus m2 u2 upon m1 plus m2, we can say P is going to be m1 u1 plus m2 u2 upon m1 plus m2. Simple formula. Okay. Now tell me, what is the value of m1? That is 4 kg. What is the value of u1? Collide with each other. 4 kg. Perfectly inelastically. Find the velocities. Two masses collide with each other perfectly inelastically. But the velocity is not given. Let me check. Why isn't the velocity given? Diagram is missing. Okay, let's suppose whatever we give. Let's suppose this is the mass which is moving with 8 meter per second. Okay, this is m. This is another, okay, it is given, this is moving with 4 meter per second. Okay, they collide with inelastically. Then in this particular case, what is going to be the velocity after the collision? Because after the collision, we say two masses stick to each other, then they move with a combined velocity. That is going to be m1 u1. m1 is 4 into 8. Okay, then plus m2 u2, that is 4 into 8 upon m1 plus m2, 8 plus 4. Okay, this is going to be the velocity after the collision. Okay, a ball of mass 4 kg moving on a smooth horizontal surface makes an elastic collision with another ball of mass m. Okay, a ball of mass 4 kg, this is 4 kg mass. Okay, on a horizontal smooth surface makes an elastic collision with another ball of mass m. Okay, it makes an elastic collision of ball of mass m at rest. So means its u2 is equal to 0. Okay, in the line of motion of the first, if after the collision first ball moves with the in the same direction with the 1/4 of its velocity. Okay, now this first ball, if after the collision First ball moves with this in the same direction, with 1/4 of its velocity. Let's suppose here its velocity is u, and here its velocity becomes u by 4. Okay, of its velocity. Then the mass of the second ball is, this is the second ball. We are supposed to find the mass of this second ball. Mass of this is 4 kg. We are supposed to find the value of m. Simple. What is the formula you are going to use? Guys. In this particular case, if I say, what is the velocity of this particular ball after the collision? Well, see, take this inelastic collision. I'll show you the approach. Which collision it is? It is perfectly elastic collision. This is perfectly elastic collision, yes. And in case of perfectly elastic collision, this is the velocity of the mass 1 after the collision. This is the velocity of the mass 2 after the collision. Okay. Now guys, what I'm trying to say in this particular case, that is, you take this particular equation, okay? When you take this particular equation, okay, this is the velocity and this will be u divided by 4. m1 minus m2, this is m, this is given as, this is 4 kg, this is given as m2. That is what you guys are supposed to calculate. Okay, then u1, initial velocity, initially that is given as u. Okay, m1 plus m2, then we say plus 2 times of m2. m2, that is the second mass you need to calculate. u2, initial velocity, this is at rest, so this term will become 0. Okay, then you guys can simplify this and you can answer. So I will leave it on to you. I hope you will take this equation, because this term in that particular case will become 0. Why? Because it says the second mass is at rest. It says this second mass is at rest. u2 is at rest. So that's why the second term will become 0 in that case. Second term is going to become 0. That's why this term will become 0. Only you have to use this. V1, this is u by 4. M1 is 4 kg minus M2. That's what you are supposed to calculate. U1, that is u upon M1, 4 plus M2. So then you can use this and get the answer. I hope you will do it from your end. You'll do it from your end. I have explained the question here. Now take a look. Okay. See? Elastic collision between two objects in which one object is very much greater than other. This is a truck. Okay, this is a truck. And this truck is moving with a velocity, let's suppose u1. This truck is moving with a velocity, let's suppose u1. Okay, this truck moving with a velocity u1. And its mass is m, capital M. And there is another, this is B, very small object, its mass is small m. It is moving with a velocity u2. And mass of truck is much greater than this B. Okay. Now guys, when this truck hits the B, what will happen to the velocity of the truck, sir? This B is going to create nothing. Okay, it is going to change nothing. So I would say in this particular case, velocity V1, okay, after the collision of this mass, it remains same as U1. It remains same as U, whatever was the initial velocity. And my dear friends, when it comes to the velocity of this B, V2, directly remember, velocity of the B will become 2 times of V1 minus U1. 2 times of V1 minus U1. Okay? 2 times of V1 minus U1. V1 is the velocity of the truck after the collision. U1 is the velocity of the truck before the, U2 is the velocity of the B before the collision. Velocity of the truck after the collision, velocity of the B before the collision. Okay? Okay? Yes. Now, case 2. If the smaller object, smaller mass is moving in the opposite direction. Now, if the B is moving in this direction, here we take this as U2. This is U1. What about the velocity of the truck? It remains unchanged, same. Final velocity V1 is equal to initial velocity U1. But when it comes to the velocity of B, you say, sir, V2, velocity of B, it will be 2 times of U1 minus. In the previous case, we were taking over here minus U1, minus U2. Right now, I'll be taking minus of minus U2. Why? Because it is moving in the opposite direction. So we have to take its velocity as negative. Minus into minus is plus. So 2 times U1 plus U2. This will be the velocity of the B or the small mass after the collision if it is moving in the opposite direction. If it is moving in the same direction, then this is going to be the velocity. Solve this. A vehicle is moving with a speed of 15 meters per second, strikes an object very small at rest. Okay, head-on collision. Then you guys are supposed to tell me strikes an object of head-on elastically. Then the velocity of the object after the collision will be. Tell me, what is going to be the velocity of the object after the collision? Tell me. Two times U1 minus U2. This. Two times V1, 2 times U1 minus U2, 2 times U1 minus U2. That's it. Okay, so velocity is going to be, this is V2, 2 times U1. So 2 into 15 minus U2. So this small object is at 0, it is at rest. So V2 is going to be, that is 30 meters per second. Yes, 30 meters per second. Because it says the small object is exactly at rest. Now take a look. Fraction of kinetic energy transferred in case of elastic collision in which second object is at rest. See guys, if I say there is a mass m1, initial velocity is u1. Okay. Yes. Initial velocity is u1. See, in this particular case, we say this second mass, it is at rest. Okay, it is m2, it is at rest. Now, when this strikes with this one, now this mass is moving with a velocity v1. This mass is moving with a velocity v2. We know how to calculate v1 and v2. Now we say when it comes to the elastic collision, kinetic energy is conserved. Okay, whatever is the kinetic energy before, net kinetic energy will be after the collision. Okay. Now. See. Initially, only this object was having the kinetic energy. This was having 0 because this was at rest. Now, can I say here some fraction of kinetic energy has been transferred to the mass m2. It has transferred the kinetic energy to the mass m2. Okay. And some fraction of the kinetic energy has been retained in m1. Some kinetic energy has been retained. Let's suppose this has 15 joule. This is at rest. So after it strikes, it is retaining 7.5. It is transferring 7.5. Okay. So my dear friends, if I say, listen very carefully. If m1 is equal to m, if this mass is equal to m, and m2 is equal to n times of m, this is at rest, this is moving with a speed u1. Directly remember, fraction of kinetic energy transferred to the second object. 4n upon 1 plus n square. N means this is how many times bigger than this. 4n upon 1 plus n square. Ignore the derivation. Fraction of kinetic energy retained. How much kinetic energy this will retain? 1 minus n upon 1 plus n whole square, and it is whole square here. 1 minus n upon 1 plus n whole square. That's it. That's it. 4 kg mass collides with 2 kg mass. Okay. 4 kg mass collides with 2 kg mass at rest. Okay, NEET 2019. And if the collision is elastic, then the fraction of kinetic energy transferred to the 2 kg mass. This is 4 kg mass. Okay, this is 2 kg mass. Okay, this is at rest. When this collides with this one, it will transfer the energy. So fraction of kinetic energy transferred 4n upon 1 plus n whole square. So kinetic energy transferred, that is 4n upon 1 plus n whole square. Okay, what is the value of n? This is 4, this is 2. What is that? This is how many times bigger than this? 2 times. Okay. 2 ones are 2, 2s are 4. So this will be 4 into 2 upon 1 plus 2 whole square. This will be 8 divided by 9. Okay, let's talk about this first. See, take a look, guys. Take a look, guys. Let's suppose there is an object over here. This is an object. If you drop this object from certain height, okay? If you drop this object from certain height, initial velocity 0, okay? So when it is about to strike the ground, this is velocity before the collision. When it strikes the ground, it rebounds. This is velocity after the collision. And then it will not reach the same height. It will go till this height. This is height after the collision. Then again it falls down. It falls down. Okay. This is velocity after second collision. Okay. Just after the collision, guys, please remember this. Important. Just after the collision, if I say how much is this velocity, this is going to be e times of under root of 2gh. E times of, E is the coefficient of restitution. E times of under root of 2gh, where h is the height before the collision, where h is the height before the collision. Okay. Now, my dear friends, if I say how much is this velocity, velocity of hit, already we studied this in the projectile motion. This is under root of 2gh. Motion under gravity, if you release an object with what velocity, it will strike the ground, under root 2gh. So this is UBC. UBC is under root 2gh. VAC, velocity after the collision, that is E into under root of 2gh. Okay. So we can say E will be equals to velocity of separation divided by velocity of approach. Velocity of separation divided by velocity of approach. This is we know. Now. Velocity of separation. Separation means this VAC. Approach means this is approaching, this is separation. VAC divided by UBC. And here you can say this also. VAC will be E times UBC. Okay. Please do remember these expressions. Now. If I say, guys, please remember this directly. If I say height after the collision, what is going to be the height after the collision? This height after the first collision. So it is E square height before the collision. E square height before the collision. Okay. And if I say, guys, listen carefully. When it comes to velocity after the collision, it is E times UBC. Why? Because under root of 2gh is velocity before the collision. Velocity after the collision, E times UBC. Okay. Yes. So height after the collision, E square height before the collision. Keep this thing in your mind. Okay, one more important thing. Velocity after second collision, E square UBC. Velocity before the collision. Okay, velocity after nth collision. Then you say E raised power n UBC. E raised power n UBC. Height after n collisions, E raised power 2n upon HBC. E raised power 2n upon HBC. Please keep these expressions in your mind. Keep these expressions in your mind. Height after n collision, okay, 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 and I would say velocity after nth collision, E raised power n, E raised power 2n. Let's suppose after second collision, if somebody asks you what is the height, you say height is E raised power 2 into 2. Put n is equal to 2 into 2 is 4. So 4 height before the collision. Okay. Now guys, see, take a look at this question. Take a look at this question. A body of mass m falls from the height h. A body of mass m falls from the height h on the ground. If E be the coefficient of restitution between the body and the ground, then the distance traveled by the body before it comes to rest. Then the distance traveled by the body before it comes to rest. Okay. Now guys, when it falls, this height, this distance you need to calculate. Okay. Okay. This is the derivation for this question. Okay. So directly, you remember this particular here. H into 1 plus E square upon 1 minus E square. Okay. H is the height fallen. 1 plus E square upon 1 minus E square. Okay. I hope this is crystal clear to each and every single student out there. This is also clear. This is also clear. There is no doubt in this one. There is no doubt in this one. Okay, like this is also derived exactly. Height after the collision, okay? That is velocity divided by 2g. With what velocity will go up? Divided by 2g. Okay? 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 Is that clear? Okay. So please keep these expressions in your mind. Keep these expressions in your mind, guys. Okay. This is velocity after the second collision, E square UBC. Velocity before the collision. And simply, velocity after nth collision will be simply E raised power n UBC. Velocity height after nth collision, E raised power 2n height before the collision. That's it. That's it. That's it. That's it. Okay. Now, let's move on to the chapter that is rotational motion. Okay. Now, guys, let's finish the rotational motion in next 1 hour. It is not that difficult. It will not take us much time. See, guys, listen to me very carefully. Listen to me very carefully. When it comes to the chapter rotational motion, I want you to understand very carefully. See, first topic is moment of inertia. What is moment of inertia? We say it is the property due to which it opposes the cause of rotational motion. See. Guys, let's suppose we have got over here a rod. We have got a bigger rod, thicker rod. What do you think? Which of the two rods is difficult to rotate? Which of the two rods is difficult to rotate? Sir, in this particular case, this is difficult to rotate. So it is difficult to change its rotational state. Rotational state means if it is at rest. Now, if you want this rod to come in motion, you have to apply some torque. So it will come in the motion. It will come in the motion. Okay. So that's what it is saying. Sir, it is because, guys, it is like in translational motion, we define it something like this. If you have a mass m, if you have a bigger mass m, okay, which one is difficult to rotate? This one. Okay, if we have to change the state of these two, which one is going to create more opposition? This one. This one will create more opposition if we have to change its state. So that's what I'm trying to say in this particular case, my dear friends. That's what I'm trying to say. See, this one is having more moment of inertia. It has more mass, it has more moment of inertia. That's the reason it will create more opposition. That's the reason it is difficult to rotate this as compared to this. That's the greater is the mass, greater is the moment of inertia. Moment of inertia is same as mass in rotational motion. Okay. So we say, how do we define the moment of inertia? Moment of inertia simply means the resistance created by the object. Okay. If we want to change its rotational state. Okay. So this will be having large moment of inertia. This will be having small moment of inertia. Why? This has large mass. This has less mass. Okay. So moment of inertia is nothing but opposition created by the object. Okay. Okay. If we want to change its rotational state, if it is at rest, we want to make it in motion, it will create the opposition. That's it. Okay. Now guys, let's suppose if you have an object, okay, this is M, which is at r distance. Let's suppose it wants to rotate about this axis. Axis means it is like you have tied a stone. You have tied a rope to a stone. Now you want to rotate it. It is rotating about this axis, Now, how much will be the moment of inertia of this mass about this axis? We say I is equal to mr square. Okay, where m is the mass, r is the distance, perpendicular distance from the axis of rotation. Where r is the perpendicular distance from the axis of rotation. And when it comes to the SI unit, for mass it is kg, for this radius it is r, it is meter, so it is meter square. Okay. Yes. Now guys, if you have system of masses, how do you find the net moment of inertia about this axis? Let's suppose, so sir, that is I is equal to m1 r1 square plus m2 r2 square plus m3 r3 square plus m4 r4 square. This is going to be the net moment of inertia in this particular case. Okay. Like, let's suppose, guys, see. Let's suppose you have the mass m1 over here. You have the mass m2 over here. Okay. And these two masses, this mass and this mass, okay, it is rotating about this axis. This mass and this mass, it is rotating about this axis. Okay. And my dear friends, listen to me very carefully. And when it comes to this mass and this mass, let's suppose this is the center of mass. It is rotating about an axis which is passing through its center of mass. Now, sir, how much is going to be this distance? Directly remember, this is the value of the distance from the center of mass from m1. m2 into r upon m1 plus m2. And then, if this is the center of mass, from the center of mass to the m2, what is the distance? m2 into r upon m1 plus m2. So this is going to be the perpendicular distance between the axis of rotation and m2. This is going to be the perpendicular distance between m1 and axis of rotation. Now, moment of inertia is going to be I into m1 r1 square plus m2 r2 square. So instead of r1, I'll be putting its value. Instead of r2, I'll be putting its value. So directly I want you to remember this result because this was asked in 2016 NEET and 2019 NEET. You have to find the moment of inertia about an axis which is passing through the center of mass. Okay. Okay, this distance from here to here, it is R1. This distance from here to here, it is R2. This is going to be the moment of inertia in this particular case. Okay, just this simply. Let's suppose you have a question something like this. You have a question something like this. What is the moment of inertia of this system about this axis which is passing through this mass? See. When it comes to the net moment of inertia, you say moment of inertia about this mass, it is 0. It is 0. Then we say plus. Why? Because axis of rotation is passing through this mass. Axis of rotation is passing through this mass. Why? Because if the axis of rotation passes through the mass, moment of inertia of that mass is 0. Okay. Because here R is not defined. R is 0. That's why moment of inertia is 0. Then what is the moment of inertia of this mass? That is m into perpendicular distance, that is a square. Now, when it comes to this mass, shall you take this distance? No. You have to take perpendicular distance. Sir, this is a by 2, so this will be also a by 2. So this will be plus m into a square divided by 2, that is a square by 4. Okay. Now this is going to be 4ma square. Now see, 4ma square plus ma square, that is 5ma square. That is 5ma square divided by 4. 5ma square divided by 4. Okay. Now guys, what about the moment of inertia of this system about this axis? See, moment of inertia of this will be 0, of this will be 0. And how much is this distance? Root 3 by 2. I'll write over here, moment of inertia, it is going to be root 3a by 2, root 3a by 2. Okay. That is, for this it is going to be 0, for this it is going to be 0 plus 0 plus. And what about this? This is going to be root 3a divided by 2 whole square into m. Okay. Is that clear? Is that clear? Tell me. Okay. Now guys, tell me. So I can say moment of inertia will be root 3 is 3 a square divided by 4, and then you write m over. Okay, what about this one? See, if you find the moment of inertia in this case, see, moment of inertia of this will be about this axis. It is passing through this mass and this mass, it is 0. And if the side is a, always remember half of the diagonal is a by root 2. Half of this diagonal is also a by root 2. Now, moment of inertia of this mass will be m into a square divided by 2, because a by root 2 whole square, a square by 2 plus m into a square by 2. So it is going to be 2 times of m a square divided by 2. 2 and 2 will cancel. It will be m a square. Now you have parallel axis theorem. See guys, what does parallel axis theorem actually mean? Listen to me very carefully. Suppose we know the moment of inertia about an axis which is passing through the center of mass. Listen carefully. Let's suppose this is an object over here. This is the moment of, this is the axis which is passing through its center of mass. You know the moment of inertia about this axis. You know. Okay. Then we can find the moment of inertia about an axis which is parallel to center of mass. Okay, then we can find the moment of inertia about an axis which is parallel to center of mass axis by using parallel axis theorem. If you know the moment of inertia, about an axis which is passing through the center, of mass, then you can find the moment of inertia about an axis which is parallel to this axis, okay, center of mass axis. Okay, so by using parallel axis theorem, that is this one. Moment of inertia about this axis, IP, will be equals to moment of inertia about the center of mass plus md square, where m is the mass and d is the perpendicular distance between the two. Condition is two axes must be parallel, one axis must pass through center of mass, this one, okay, d must be the perpendicular distance between them. This is the condition. If these are satisfied, you can do it. Like. Let's take a look. Okay. Moment of okay. Here. Let's talk about the parallel axis theorem. Let's use the parallel axis theorem over here. Guys, see, this is a ring. Guys. When it comes to a ring, moment of inertia of a ring about an axis which is passing through the center of mass, it is mr square. Always remember. Now you want to find the moment of inertia which is passing through the edge. Use parallel axis theorem. What does that say? Moment of inertia about this axis will be equals to moment of inertia about cm plus md square. Now, moment of inertia of this is mr square plus moment of, then we say mass m, and what is this perpendicular distance? That is r square. So I would say 2 times of mr square. Okay, 2 times of mr square. Then you say perpendicular axis theorem. According to the perpendicular axis theorem, what does it say? Moment of inertia about z-axis is equal to moment of inertia about x-axis plus moment of inertia about y-axis. See, if let's suppose this is a disk over here, okay? If this is a disk over here, it is valid for 2D objects only. If this is a disk over here, okay? Now, there is a axis which is perpendicular to the plane of the disk. Another axis is something like this, okay? This is a disk. One axis is this, another axis is this, another axis is perpendicular, okay? It says moment of inertia of this disk will be equal to moment of inertia of this plus moment of inertia of this, okay? See, all the three axes must be mutually perpendicular. X-axis, y-axis, z-axis. X and y-axis must lie in the same plane of the body. X is lying in this plane, y-axis is lying in the same plane. Okay. So we say perpendicular axis theorem says that you can say moment of inertia about this axis will be equals to moment of inertia about I plus moment of inertia about X. Z must be perpendicular to the plane. It is like this. Let me show you. It is like this. Let me show you. It is like this. Let me show you. See. Guys. This is x-axis. This is y-axis. This is z-axis. X-axis, y-axis. These two axes must lie in this plane. Third axis must be perpendicular to the plane. Keep that thing in your mind. Okay, then you can use parallel axis theorem, and this is parallel axis. Ix plus Iy is equal to Iz. Okay, now use here, guys, moment of inertia of a ring about an axis which is passing through the center of mass, that is mr square. Okay, what about the moment of inertia about its diameter, about its diameter, this, see, use the parallel axis, perpendicular axis theorem. What does that say? Iz will be equals to Ix plus Iy. Now Iz is mr square is equal to Ix, moment of inertia about x-axis. This is also its diameter. This is also its, if this is a ring, this is also the diameter, this is also the diameter. So this is the moment of inertia about the diameter, plus this is also the moment of inertia about diameter. So this is mr square is equal to 2 times Id. So Id will come out to be mr square divided by 2. Mr square divided by 2. Now, if somebody says, what is the moment of inertia of a disk? You say it is mr square by 2. Mr square by 2. Okay. Find the moment of inertia of a disk about its diameter. Use the perpendicular axis theorem. Iz will be equals to Ix plus Iy. Now guys, Ix and Iy are the diameters. So Iz, moment of inertia of a disk about its center of mass, that is mr square by 2. This you remember, this is mr square divided by 2 is equal, this is Id plus Id, 2 times of Id. So we can write mr square by 2 is equal to 2 times of Id. So Id will be equals to mr square divided by 4. Okay, moment of inertia of a rod. Moment of inertia of a rod about an axis which is passing through its edge, it is going to be ml square by 3. Moment of inertia of a rod which is passing through its center of mass, it is going to be ml square by 12. It is going to be ml square by 12. Okay, if somebody says, what is the moment of, this is the moment of inertia, ICOM. What is the moment of inertia of a rod about an axis which is parallel to the center of mass axis, and distance between these two is L by 4. Can I use the parallel axis theorem? Parallel axis theorem. What does that say? Moment of inertia about this axis I is equal to ICM plus MD square. Yes, sir. Sir, I is equal to ICOM. Moment of inertia about this axis, that is ML square divided by 12. Then we say plus M. Then what is this? This distance L by 4. So L square divided by 16. 4 square is 16. This is going to be the moment of inertia. Now see, moment of inertia of a half disk. Now moment of inertia of a half disk. If this is the half disk, about its center of mass, okay, about its center of mass, something like this. This is the moment of inertia about an axis which is passing through its center of mass. Mr square 1 by 4, 16 upon 9 pi square. 16 upon 9 pi square. Similarly, if the axis is perpendicular to the plane of the disk, previously axis was something like this. Right now it is perpendicular. It is entering, like it is showing something like this. This will be mr square 1 by 2, 16 divided by 9 pi square. Okay. We are talking about the half disk. Center of mass of hollow sphere. This is a hollow sphere. Okay. Guys. About an axis which is passing through its center of mass, it is 2 by 3 mr square. About an axis which is touching the edge, 5 by 3 mr square. Moment of inertia of a solid sphere about an axis which is passing through center of mass, it is 2 by 5 mr square. Okay, and when it comes to the edge, use perpendicular axis theorem, it is 7 by 5 mr square. Find the moment of inertia of a spherical shell about an axis passing through its center of mass. Okay, the spherical shell means hollow spheres. First, moment of inertia about its center, hollow sphere, center and edges. When it comes to the center, Okay, this is 2 by 3 mr square. So I'll write over here moment of inertia of this hollow sphere. Net I'll write 2 by 3 mr square. Then we say plus 2 times of moment of inertia of this plus moment of inertia of this. That will be same because axis is passing through their edge. That is going to be 5 by 3 mr square. So this is 2 times 5 by 3 mr square. Done. Do the further simplification in this particular case. Take mr square common. Then 2 by 3 into 10 by 3. 2 by 3 minus 10 by 3. Now we say in this particular case, guys, take a look. Moment of inertia of a hollow cylinder. Moment of inertia of a hollow cylinder. If you have got a hollow cylinder over here, okay, in case of a hollow cylinder, about an axis passing through its center, about an axis which is passing through its center, it is mr square. It is mr square. It is formed by the combination of many rings, basically. That's why it is having the mr square only. Now, about an axis which is passing through its edge, okay, use the perpendicular axis theorem, mr square plus mr square, this will be 2mr square. So about its center, it is mr square. About its edge, it will be 2 times mr square. Then, moment of inertia of a solid cylinder about an axis which is passing through its center, that is mr square by 2, because it is the combination of many disks. Whatever is the moment of inertia of a disk, same will be for this. And about an axis passing through its edge, that is 3 by 2 mr square. 3 by 2 mr square. Okay. Then we say moment of inertia of a plate. Moment of inertia of a plate. Let's suppose this is the plate that you have got over here. Okay. In this particular case, if I say moment of inertia about this axis IA, it is going to be MAQA square divided by 3. Okay. And about this axis, MA square divided by 12. Basically, it is like many rods are joined together and form this. MA square by 12, MA square divided by 3. Now, if you have this same sheet, but right now you are cutting its breadth, okay, then in this case, it is going to be MB square divided by 12. Right now, it is MB square divided by 12. And about this axis, it is going to be MB square divided by 3. Here, if you are cutting the length, then you take as MA square by 3, MA square by 12. If you are cutting the breadth, in that case, MB square by 12, MB square by 3. This is the difference. And if you take the same plate, about this axis which is perpendicular to the plate, it is going to be MA square by 6. Okay? 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 Yes. Yes. Next topic we have torque. Before torque, let's take a break. Break is till 3:25 a.m. 20 minutes break. Now, guys, take a look. Let's move on to the next concept. That is what we call the torque. That is what we call the torque. Now, what is this torque? We say torque is defined as the rotational version of force. It is simply the rotational version of force. Okay. Now, my dear friends, listen to me very carefully. Let's suppose if we have this nut over here, and if we have to open this nut, we use this particular opener, okay, in order to open this particular nut over here. Okay. Yes. Now, guys, if I say, sir, you apply the force at this position, this point, you apply the force at this point. Do you think that you can open this nut? No, sir, it will not rotate. So, in order to rotate this particular opener, so that it should basically rotate, this nut should basically rotate, you will have to apply the force at this end point, okay, such that there should be distance between this and this. This is the axis of rotation. It is rotating about this axis, so there must be some distance. This is our distance. So you cannot apply the force at the axis of rotation exactly, then it will not rotate. Okay. So when you apply the force here, on the application of this force, we say a rotating effect is being created. That rotating effect is called torque. Okay. Now, guys, see. It is like if you have to open this door, will you apply the force on the axis of rotation, or will you apply the force at this point? At this point, then only you would be able to open the door. Okay, so basically when you apply the force at this point, it is creating the rotating effect due to which door opens. So this rotating effect is called torque. So on the application of force, torque is created. And we say this torque is equal to that is R. Okay, how far you apply the force from the axis of rotation, then we say F. Okay, and then we say sine of theta. So why do we mention sine theta? See guys, if I'm saying if you are applying the force at an angle theta, this force will have two components, F cos theta and it will have F sine theta. Now, which of the two components will rotate it? Obviously, F sine theta, because F cos theta is pulling it in the outward direction. So that's the reason here torque will be created due to F sine theta and R. So that is R F sine theta due to these two. Okay. And then we further say, guys, AB sine theta means A cross B. RF sine theta means R cross F. So torque, this is the another formula of torque. Direction of torque is always perpendicular to R and F. Like if this is R, this is the radius vector. If you are applying the force something like this, torque will be perpendicular to it. Okay, okay, okay. So my dear friends, what is the value of torque? Torque is simply RF sine theta. Now let's talk about the maximum torque. Let's suppose you want to rotate this particular rod. Okay, you are applying the force over here. So from here to here, this is going to be the radius vector. Okay, R. What is the angle between? If you extend this, what is the angle between R and F? That is 90. So if you put sine 90 over theta is equal to 90, this will be tau is equal to R into F. So RF sine 90. Sine 90 is 1. So torque in that particular case will be R into F. And this is called the maximum torque. This is called the maximum torque. Keep this thing in your mind. Okay. This is called the maximum torque. This is called the maximum torque. This is called the maximum torque. So when theta is 90, angle between radius and force is 90. In that case, we say torque is maximum. Now guys, let's talk about the minimum torque. Minimum torque means if let's suppose this is the rod, you are pulling this rod in the outward direction. Radius is also in the same direction. R and F, angle between these two is 0 degrees. So you are pulling it, you are not rotating. So if theta is 0, sine 0 is 0, so torque in that case is going to be 0. This is called the minimum torque. This is called the minimum torque. Like, let's suppose there is a question over here. The moment of force F is given as this, okay? F is given as, force is given as this. At a point 2, 0, 3. About a point, there is a point, this is the point, okay? That is 2 minus 3 minus 2. And a force is acting at this point. And coordinates of this point are given as 2, 0, minus 3. Okay. And in this particular case, you are supposed to find the value of torque. Guys. Force factor is given. Let's find the radius factor. Let's find this radius factor. Radius factor is 2 minus 2, that is 0 I cap. 0, then we say minus of minus 3, that is plus 3 j cap. Then we say 3 minus of minus 2, that is 3 plus minus 3 plus 2. That is going to be minus k cap. This is the radius factor. Now, when it comes to the torque, if you have to find the torque over here, so torque is going to be R cross F. Okay. And guys, R cross F. R is given, that you got the R. F is given. How do you find A cross B? R cross F is going to be, that is A cross B. So you write over here I, J and K. This is how we write the cross product. If you have two vectors, force vector is given, radius vector is given, you have to find their cross product. You make the determinant. Then radius factor. Then coefficient of I over here is 0. Coefficient of J is 3. So you write 3. Coefficient of K is minus 1. You write over here minus 1. Then you write coefficient of I over here in case of force it is 4. Then it is 5. Then it is minus 6. Okay. Now guys, further. First we solve it for I. I'll write over here I. Okay. Hide this column, hide this row. 3 into 6 is 18. This is minus 18. Okay. Then we say 5 into 1 is 5. So 5 into 1 is 5. So it is minus into minus is plus. So plus 5. Okay. Then solve it for J. Okay. So it is going to be minus J cap. Now hide this column and hide this row. Solve this and this will be 0. 4 into minus 1 is minus 4. This will be 0 minus of minus 4. That will be plus 4. Then we say plus K cap. For K, hide this column and hide this row. This will be 0. 4 into 3 is 12. So 0 minus 12 minus 12. Okay. Now in this particular case, torque will come out to be 18 minus 5. Okay. So this will come out to be 13. So this will be minus 13 I cap. Please do check it from your end also. Minus 4 J cap. Then we say minus 12 K cap. This is going to be the torque in this particular case. Okay. Do check it from your end. Okay. It's calculations, everything. Approaches this only. J mains 2025. Okay. The coordinates of a particle are given with respect to the origin. Okay. Coordinates. This is the particle. Okay. Let's suppose the particle is here. Its coordinates are given as 1, 1, 1 with respect to the origin. So how do you write its radius vector? Radius vector will be I cap plus J cap plus K cap. Why? Because it is saying it is 1 meter away from the x-axis. Okay, it is at 2 when it comes to the y-axis. Okay, okay, okay. And then we say 1 k cap. And force acting on this particular particle over here is, if a force acting on it, that is, force in this case is given as I cap minus j cap, I cap minus j cap plus I can say k cap. Okay. Then the magnitude of the torque is, in this particular case, you guys are supposed to find magnitude of the torque. So torque here is going to be, that is simply when it comes to the torque, it is going to be, that is R cross F, R cross F. And how do you find R cross F? Make the determinant once again. This is I, J and K. Now, when it comes to this R is 1, 1, 1 because coefficient of 1, 1, 1. And for this coefficient is 1 minus 1 plus 1. Now, solve it like I did in the previous question. Okay. Is this clear? Is this clear? Give me the signal in the chats, guys. I need to know in the chats if this is crystalline clear. Let's suppose if the question is something like this. Find the torque due to mg, due to this force mg, about O, about this O. Guys, what is this distance? That is L by 2. See. You say, sir, torque is RF sine of theta. Here, angle between this radius vector and mg is 90. So torque in this case is R. R is L by 2. Force in this case is mg and that is sine 90. So mg L by 2. When it comes to the, this is about O. This is about O. When it comes to about this point, center of mass, about COM, I can simply say torque will be 0. Why? Because this mg is passing through COM, obviously torque will be 0. Obviously torque will be 0. If the force passes through the center of mass, in that case torque is 0. Why? Because you cannot define the radius factor here. Radius is 0. Okay. Now guys, let's take a look over here. When it comes to the translational motion, I want you to understand one thing. Translational motion means in which a body is moving in a straight line. Okay. We have defined its velocity is ds by dt. Change in displacement upon change in time. Here you have, guys, here you have displacement, how much a body moves, okay, how much a body moves from one point to another. When it comes to the rotational motion, guys, see, when it comes to the rotation, if I say this rod is rotating, it has angular velocity omega. It is rotating with the angular velocity omega. Okay, it is rotating with the angular velocity omega. Here, guys. It has linear displacement s. It has angular displacement theta. How much a body is moving, that is linear displacement. How much a body is rotating, that is angular displacement. Here you have linear velocity v. Here you have angular velocity omega. V is equal to ds by dt. Here you have omega is equal to d theta by dt. Rate of change of angular displacement with respect to time. Rate of change of linear displacement with respect to time. Here you have acceleration is equal to dv by dt, velocity upon time. Here you have angular acceleration is equal to d omega by dt. Omega is the angular velocity. Alpha is the angular acceleration. Here you have Newton's second law. F is equal to mass into acceleration, dp by dt. Here you have Newton's second law. Tau is equal to dl by dt, or you can also say I alpha. What is I? I is the moment of inertia. And you have got here mass. Moment of inertia plays the same role in rotational motion as mass plays in linear motion. Here you have got momentum. P is equal to mv. Here you have got L is equal to I omega. Here you have mass, here you have moment of inertia. Here you have linear velocity, here you have angular velocity. Here you have linear momentum, here you have angular momentum. Here you have work is equal to force into displacement. If the body rotates, torque into angular displacement will give you the work. Okay, okay. Or integration of f ds, here it is integration of tau d theta. Okay. Then my dear friends, one more important thing. Here kinetic energy is 1 by 2 mv square, or you say p square by 2m. Here kinetic energy 1 by 2 li square, because here you have mass, you have moment of inertia. Here you have velocity, here you have angular velocity. Here you have momentum, here you have angular momentum. Okay. Then guys, one more important thing. What is that? That is, see, power. Power is force multiplied by velocity. And when it comes to the power in rotational motion, it is torque multiplied by angular velocity. Impulse, okay, m delta v or f dt. Here it is I delta omega or tau delta theta, delta dt. So basically, this is the analogy. Like you have things in translational motion, similarly, there are things in rotational motion. That's it. That's it. Okay. Now, one more important thing. See, guys, we say equations of motion. We say equations of motion. Like you have translational motion. Here, when acceleration is constant, you say v is equal to u plus at. Okay, s is equal to ut plus 1 by 2 at square. V square minus u square is equal to as. Displacement in n second, u plus a by 2, 2n minus 1. S is equal to u square by 2a. If you remember all of these equations, I made you explain. Similarly, their analogy, when angular acceleration is constant, we say final velocity is equal to initial velocity plus acceleration in time. Final angular velocity, initial angular velocity, angular acceleration into time. Okay. Here you have got displacement is equal to ut plus 1 by 2 at square. Angular displacement is equal to omega I into t plus 1 by 2 into alpha t square. Here it is alpha t square. Alpha t square. See, v square minus u square is equal to as final angular velocity square minus initial angular velocity square 2 alpha theta. 2 alpha theta. Then you say s nth. Okay, displacement in n second. You have got angular displacement in n second. Omega I plus alpha by 2 into 2n minus 1. Stopping distance is omega I square divided by 2 alpha. All the equations you have over here. Okay. Now there was a question, JEE Mains 2025. A circular disc of radius r of mass m is rotating about an axis perpendicular to its plane. An external torque is applied such that theta is equal to, angular displacement is given as theta is equal to 5t square minus 8t. How much power is delivered by the torque when t is equal to 2 seconds? Guys, we say, what is the formula for torque, for power? What is the formula for power? Here it is F into V, here it is tau into omega. Here it is tau into omega. Okay. Here it is tau into omega. So I'll write in this particular case, power is equal to tau into omega. Now guys, theta is given, you don't know the torque, you don't know the angular velocity. Let's find the angular velocity first. Sir, omega in this particular case is d theta by dt, rate of change of angular displacement. That is differentiation of this. 5 into 2 is 10t minus we say 8 Then if I say angular acceleration, that is d omega by dt. Differentiation of angular velocity, that will be 10 only. That will be 10 only. If you got this, how can you find torque? Torque is equal to I times of alpha. That's what I said. Like you have force is equal to mass into acceleration. Torque is equal to I into alpha. So now it is saying that a circular disk is rotating of mass m, radius r, is rotating about an axis perpendicular to its plane. Means that circular disk has a moment of inertia mr square by 2. So it is mr square divided by 2. Okay. Into alpha. This is the torque. Now you have to find the power. You have to find the power. And what is the value of alpha? Alpha came out to be 10. So you put 10 over here. Is 10. 2 ones are 2 5s are 10. So torque came out to be 5 mr square. Okay. Now you have to find the power. Power is torque. And power is torque. Torque is 5 mr square. And then omega is given as 10t minus 8. 10t minus 8. Now tell me guys, power will be 5 mr square. Then we say 10. At what time it is asking for the power? 2. 10 into 2 minus 8. So that is 20 minus 8. That is 12. So 5 into 12 is 60 mr square. 60 mr square is going to be the power in this. Yes, 60 mr square. Gravitational potential energy of a rigid body. Let's suppose if you place a rod somewhere around over here, you consider its mass at center of mass. Okay. And here, when it comes to the potential energy, you say potential energy mgh, but h will be L by 2, mgl by 2. Here, below the surface, minus mgl by 2. On the surface, you consider it 0. Potential energy. Now, guys, since I told you kinetic energy in terms of momentum, it is p square by 2m. And in rotation motion, it is L square by 2I. Okay. Because here you have mass, here you have moment of inertia. Here you have momentum P, here you have angular momentum L. So you can write over here. Guys, see, let's suppose if you have a disk. Okay, you want to write the kinetic, if it is rotating with angular velocity omega, you want to write its kinetic energy. It is 1 by 2 I omega square, 1 by 2. This I in this particular case is mr square by 2 into omega square. Because moment of inertia of a disk about an axis which is passing through its perpendicular to the plane, passing through the center, it is going to be mr square by 2. 2 into 2 is 4. This is going to be the angular. This is going to be the kinetic energy. Similarly, here 1 by 2 I omega square. I will be 2 by 5 mr square. This is the solid sphere. For solid sphere, it is 2 by 5 mr square. I hope this is clear. Now, guys, let's move on to the angular momentum. Angular momentum. See, guys. Let's move on to the angular momentum. Let's suppose you have a mass over here. With respect to this point, if I take a look at this mass, it is moving in a straight line. It is not moving angularly. But with respect to this point, if you sit at this point, it is moving angularly. It is cutting some angle. See, this is the radius vector. This is the angle over here. So with respect to the point B, the body will have angular momentum. With respect to the point A, body is performing translational motion. With respect to the point B, body is performing angular motion. Okay. So with respect to point A, it will have linear momentum. With respect to point B, body will have angular momentum. Okay. Sir, it means we define angular momentum about a point. Yes. We always define angular momentum about a point. Like about this point, angular momentum, we are saying L is equal to mvr sine theta. L is equal to mvr sine theta. Now, my dear friends, see, this is the formula for angular momentum. mvr sine of theta. M is the mass, v is the velocity, and then we say r sine theta. Theta is the angle between v and r. Even you can write it something like this. M and v means momentum. So you can say it is r cross mv, r cross p. This is also the formula of angular momentum. So simply, if a mass is moving with respect to some point in an angular motion, it will have angular momentum. That's it. Now guys, this is the angular momentum of a translating body. Sir, a body is doing translational motion. It can have angular momentum. Yes, about this point it does have. If a body is rotating, if a body is angular momentum of a purely rotating body, okay, in that case we say L is equal to mvr. We say V is equal to r omega. This is the equation everybody knows. Okay, so instead of this V, we will put over here, that is r omega. So it will be L is equal to mr omega. So L is equal to I omega. This is the angular momentum of a purely rotating body. Now see, if this rod is rotating, what is its moment of inertia about the center of mass? ml square by 12. How can we write its angular momentum? I into omega. I will be ml square by 12 multiplied by omega. That's it. An object is projected with speed u at an angle theta with the horizontal. Okay. An object is projected with the speed u. Okay. At an angle theta with the horizontal. Find the angular momentum when the object is at maximum height. When the object is at maximum height, at this height. When the object is at maximum height, find the angular momentum. See guys, understand this very carefully. We say when the object is at maximum height, this is its velocity. That is u cos theta. Because vertical velocity will be 0. And this will be the radius vector. This will be the radius vector, r. And this is the maximum height, h max. Okay. Now, if you define angular momentum over here, you say r m v. Okay. Then we say sine of theta. Okay. Now, guys, you write over here L is equal to this R is as it is. And then mv sine theta. mv sine theta. Guys, we say when it comes to the angular momentum, we say L is equal to, see, we say L is equal to, that is R perpendicular, okay, into P. So that is how we define. Now, in this particular case, you tell me one thing. If this is the mass m, it is moving with the velocity u cos theta. Perpendicular distance is simply this. So I can write L is equal to mv into r. Guys, see. We will prefer which distance? We will prefer this distance because this is perpendicular distance. So m, okay, mass, velocity is this. I can write L is equal to m, velocity is u cos of theta, and perpendicular distance I am taking this. That is h max. Because if this is the radius, guys, this is the radius. This will be the parallel component. This will be the perpendicular component. Okay. And L will come out to be, that is M u cos theta. Then H max, what is the maximum height of this projectile? U square sine square theta divided by 2g. This is the answer to the question. Conservation of angular momentum, important. Conservation of angular momentum. See guys, when it comes to the Newton's second law, F is equal dp by dt. If we say external force on a body is 0, so this will be 0, dp by dt is 0. So multiply this with dt, dp will be 0. dp is 0 means momentum is conserved. Momentum will not change. Change in momentum is 0. So means initial momentum is equal to final momentum. Okay. Now in angular motion, if I say net torque, what is the rotational version of Newton's second law? dl by dt is equal to net torque. If net torque is 0, we say put this equal to 0, multiply this over here, so dl will be 0. Means angular momentum will not change. Angular momentum remains conserved. So L final is equal to L initial. Means if on a system net torque is equal to 0, then angular momentum remains conserved in that particular system. Then angular momentum remains conserved. Like, guys, this is the question which was asked in J-Mains 2024. We say a thin circular disk of mass m and radius r is rotating about an axis, passing through its center with angular velocity omega. This thin disk is rotating about an axis with angular velocity omega. Its mass is m. If another disk of m by 2 is placed gently on the first disk, another disk of m by 2 is placed gently on the first disk, okay, coaxially, then the new angular velocity will be, what will be the new angular velocity? Guys, see. Initially, there was only one disk. Finally, there are two disks rotating. See, here, net torque is equal to 0. There is no external torque, okay? So, angular momentum initial is equal to angular momentum final. And guys, when it comes to initial angular momentum, initially, we say only this was present. So we say it is m into r square. Okay, how do we write? L is equal to I into omega. Final angular momentum I dash omega dash. I into omega. Moment of inertia initially. What is the moment of inertia of this disk? It's a disk, that is mr square divided by 2. Omega is omega. Finally, you have got both the disks. Moment of inertia of first disk, it is mr square by 2 plus moment of inertia of this disk, its mass is m by 2. So mr square divided by 2 into 2 is 4. And final angular velocity is omega dash. Okay. So mr square. This will be omega divided by 2 is equal to 1 by 2, 1 by 4. 4 into 1 is 4. 2 into 1 is 2. So 4 plus 2 is 6 divided by 2 4s are 8 into omega dash. 2 1s are 2 4s are 8. 2 2s are 4, 2 3s are 6. Take it over there. Omega dash will come out to be 2 omega divided by 3. This is the final angular velocity. Okay. This is the another question. This I'll give you as homework on the same concept. Okay. Or let me solve this question over here only. A circular ring of mass m and radius r is rotating about its axis with angular velocity omega. Okay. A circular ring. Okay. There is a circular ring which is rotating about its axis, which is having the mass m and radius r. Okay. With constant angular velocity omega. Two particles of each mass m. Now what we are doing is that we are taking this ring, we are adding a mass m over here, we are adding a mass m over here. On the opposite ends of the diameter of the ring, the new angular velocity will be, what will be the new angular velocity? Omega dash. Guys, here, when you add the mass, still net torque will be 0. Sir, but in this case, this mg will create the torque. This torque will be cancelled with this torque. Okay? This is the radius r. R cross f. R cross f. This torque is inward. Now this torque is outward. This torque inward, outward. Net torque is again 0. Now in this case, guys, tell me, angular momentum initially is equal to angular momentum finally. When it comes to the initial angular momentum, initially mass is m, moment of inertia of a ring. It is a ring. mr square I into omega is equal to final angular momentum. Finally, you have got moment of inertia of the ring mr square plus moment of inertia of this, that is mr square plus mr square, 2 times of m, and radius is r square. Then omega dash. What can you cancel? R square, R square, R square. Okay, so it is m omega is equal to, here it is m plus 2m into omega dash. Omega dash will come out to be m omega upon m plus 2 omega. So this is the final angular velocity. This question was even asked in many times in the JEE also. Okay. So my dear friends, I think we need to end the session, okay? Now work, power, energy is left and friction is left. Okay, I will finish that in the part 2. What? Do check it from your end now, guys, huh? Do check it now from your end. mr square, 2mr square. m plus 2m, m plus 2m, m plus 2m, m plus 2m. Yes, it is m plus 2m. Okay. Yeah. Now, guys, I would want you guys, once I end the live stream, I would want you guys to let me know how was the session, okay? So that's all for today. Okay. So do comment later on how was the session and everything. Okay. So take care and bye-bye. Thank you. Good night. Good night. I'm also feeling very tired. Extremely tired, I must say.